Hi, my name is Bob Tabor with www.learnvisualstudio.net. This series of lessons should provide an introduction to the fundamentals of the C# programming language and programming in general. Now, if you're already an experienced software developer coming from another platform or another programming language, then frankly, these might move a little bit slow in some parts. You might be better served to find another resource to use as a starting point. But if you're completely new to programming and you're new to the C# programming language, then this is a great place to start. We're going to walk through every action and we're going to talk about every single line of code that we'll write together. And I'm going to try to anticipate the problems that you might experience while typing in your first lines of code as you're working through these exercises. Based on my interaction with absolute beginners over the past 12 years of helping people just like you learn C# and .NET through videos just like these. Okay. These videos were recorded using Visual Studio 2013 Express for Windows Desktop, which is a free edition of Visual Studio available for download from Microsoft.com/Express. And this is also important. Since we're merely covering the basics of the C# programming language, the things that I'm going to cover in this series of videos will apply to all versions and all editions of Visual Studio. So this includes Visual Studio 2008, 2010, 2012, 2013, and whatever comes next. It also means that you can use the Express editions or any commercial versions that you might have access to of Visual Studio. So in other words, and I can't more emphatically state this, as long as there's a C# to learn, these videos will still be valid. When new versions of Visual Studio do become available, the features that are added rarely affect the features that are relevant to the absolute basics and the fundamentals of C# in particular. So you can watch these and follow these videos 10 years from now, and they should still be valid. In the very next lesson, we're going to walk through the installation steps of Visual Studio 2013 Express for Windows Desktop. Now, feel free to skip that lesson if you already have Visual Studio 2013 Express for Windows Desktop installed, or if you have any later version of Visual Studio installed. To get the most out of this series, you should be an active learner, meaning that you should attempt to follow along. I call this getting your hands dirty in the code. There's no better way to learn than following along and writing the code yourself. Pause the video, rewind the video. While I do make the code that I wrote available for download, and you're welcome to reference it if you like, you should really be typing this in yourself into your own copy of Visual Studio. Furthermore, I would encourage you to not be in a rush to complete this course. If something doesn't make sense, again, pause the video, rewind it, watch it again, or find other articles, other resources on MSDN or Microsoft.com or Channel 9 or Microsoft Virtual Academy or my own website, again, www.learnvisualstudio.net, that could help make that concept clearer. Like I said earlier, if you're new to programming, I'm excited for you. You're embarking on an exciting journey that's immersive and is rewarding. And you can do this. If you've ever gotten stuck in the past trying to learn to program, I promise you that if you put in the time and you work with me, that working together we're going to build a knowledge of C# and you'll be well equipped to move on to more advanced tutorials where you can learn how to build your own web, Windows, and phone applications. And if you ever have any questions about this series or if I can help you in any way, please feel free to write me personally at bob@learnvisualstudio.net, or you can contact me on Twitter at @BobTabor. So after installing Visual Studio 2013 Express for Windows Desktop in the very next lesson, we're going to create our first program in lesson number 3. It's a simple program that we're going to build on until we get the fundamentals under our belts. So I hope you're excited because I am. So let's go ahead and get started. See you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need in order to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, I'm going to install the free edition of Visual Studio named Visual Studio Express that you can use to follow along with the rest of this course. If you already have some edition of Visual Studio 2013 or greater installed, such as Express or Professional, Premium, or Ultimate, then you can skip this lesson and continue on to the next one where we build our first app. Also, if you're adept at installing your own software, then I'm willing to bet that you could probably figure this out on your own. Okay. Like I said, the free edition Visual Studio Express can always be downloaded from Microsoft.com/express, and it will forward you to the right page. It happens to look like this now, but they change it up occasionally, so don't be jarred if it looks a little bit different. And on this page, you're going to quickly come to realize that there's not just one free Express edition, but there's several. And you're going to choose the one that you need based on the platform, or rather, depending on the type of application that you want to build. So, for example, if you scroll down on this page, there's Express 2013 for web, Express 2013 for Windows, Express 2013 for Windows Desktop, and Express 2013 for, where are you? There you are, Windows Phone. And so this is vitally important. You need Express 2013 for Windows Desktop. If you do not have this free edition of Visual Studio installed, then you won't be able to follow along with me as we work through the exercises in this series. Now, if you already have Professional, Premium, or Ultimate, all those editions have all application types available from your single Visual Studio installation. But that's not the case with the free edition Visual Studio Express. There are other differences as well, but generally you're only going to need the Professional Edition or greater once you learn C# and .NET and you need some advanced features, or whenever you're working with a team of developers. So a common mistake that new developers make whenever they're attempting to follow along in the series is that they mistakenly download Express 2013 for Windows instead of for Windows Desktop. So you would use the Windows edition for building store apps, you know, like the Windows Store. And we have a whole series about that on Channel 9 and then also on Microsoft Virtual Academy if you're interested in that. But we're going to use, let's get back to the desktop, we're going to use, where are you? There you are, Express 2013 for Windows Desktop to create simple console window applications in this course. So locate the Express 2013 for Windows Desktop edition, and then you'll click the download link. And you'll see a panel reveal that describes more about Visual Studio Express 2013 for Windows Desktop. In this panel, you'll also have several options, whether your download languages prefer to be English or something else, whether you would want to install the DVD or just the little installer. So in ISO, this DVD5 ISO image, it's basically just a DVD image that includes all the features, even those that you may not need, and therefore it might take a little bit longer to download. So honestly, I recommend that you choose that first option by selecting the Install Now link. All right, that'll take you to another page that would ask you to potentially log in. As you can see, I'm already logged in, but if I wasn't, I would see a page that looks like this, asking me to log in. So I'm going to go ahead, log in, and then I'll have the option to either download the Express 2013 for Windows Desktop or Ultimate. And I wouldn't recommend this one yet because it's a time trial. So let's just go ahead and choose Express 2013 for Windows Desktop. If you're using Windows Explorer, you're going to be asked whether you want to save the installer or run it. Typically, I just click the Run button, but you might choose to click Save if you think you'll need to install it again in the future. So when the installer begins, you're going to have the option of installing onto a different folder or drive. I generally leave the default locations alone. However, you might want to change this if you're running out of room on your primary hard drive. You're also going to be asked to read and agree to the license terms and the privacy policy by clicking the checkbox. And once you've agreed to the terms, then you want to click the big install button at the very bottom of the dialog. Because Visual Studio will need to modify some of the settings of your operating system and your file system, then you're going to be presented with a UAC, User Account Control dialog, asking for permission. So we want to click the Yes button. And so next, the setup application will begin to create a system restore point, which is a standard installation procedure to allow you to get back to your computer settings prior to the installation if something goes wrong. And then it'll start to download the relevant components of Visual Studio onto your computer. So I have a pretty fast internet connection, and still this takes about 10 minutes to go through. So you might want to take a quick break while you're waiting for this and come back in a few minutes. Okay, so once everything's been set up successfully, then you're going to see the successful setup message in the setup application, and we will want to click that launch button here at the bottom of the window to start Visual Studio. And here again, we're going to ask to sign into Visual Studio. This time it explains that you're going to gain some benefits from signing in. However, you can skip this step if you want to with that little link below the sign in button. I'm a conformist, so I will click the sign in button. I will put in my account. And as you can see, Visual Studio will search online and set up this copy of Visual Studio according to my previous preferences. And after a moment or so, I see the Start Page tab loaded in the main area of Visual Studio, indicating that I'm ready to get started. So now we are ready to write our first lines of code in C#. In the very next lesson, we'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, I want to show you how to build the most simple C# application, a Hello World application. It'll simply display the message Hello World in a Windows console window. Now, I'm not going to attempt to explain much in this lesson. You're going to get a feel for the workflow. In other words, how to create a new project, where to type the code, how to test your application and see it working, and so on. So for now, just try to follow along and don't worry if something doesn't make sense immediately. Over the course of the next lessons, we're going to dissect this tiny little example, and we're going to explain every line of code that we write and why we did it. So I'm going to assume that you already installed the most recent version of Visual Studio Express Edition or one of the greater editions, and you're asking yourself the question, what do I do now? Okay, so first what I want to do is close down. If you're following along from the previous lesson, we left it in this state. I'm going to go ahead and close this and show you how to get back to Visual Studio. So what I want to do in Windows 8.1 is go to see all my apps by name, and I'm going to find Visual Studio Express 2013 for desktop in the list of apps. I'm going to right click it, and that'll bring up the little taskbar, and I'm going to select Pin to Taskbar. And so now whenever I return to the desktop, I can see that Visual Studio icon is in the taskbar for our convenience. And so if you want to, you can remove this after the course, but it's just a nice quick convenient way to get back to it. All right, so let's go ahead and click the Visual Studio icon, and we'll launch Visual Studio. And so in Visual Studio's File menu, I'm going to select New Project. And in the New Project dialog, I want to choose a project template to start with. So first of all, you want to make sure that you're working with the Visual C# templates, okay? I can't tell you how many times I've selected Visual Basic and I didn't mean to. And then we want to choose the console application in that center pane. And then I'm going to type the word, I'm going to remove the name that was there by default, and I'm going to type in hello, capital W in world, no spaces, capital H hello, capital W world, and then I'm going to click the OK button in the lower right hand corner. And then after a moment or so, you'll see that Visual Studio will create a new project based on the project template that you selected, the Windows Console application. Okay, so you're going to come to understand what a project template is and what it provides for you throughout the remainder of this course. For now, let's just keep moving forward, okay? So the dialog disappeared, and we're loaded into the main pane of the IDE, the Integrated Development Environment. So I want to find this opening and closing set of curly braces underneath the word static void main, all right? And I want to type in the following code. And so I positioned my mouse cursor, as you saw, kind of somewhere in between, and then hit the enter key on my keyboard. I can do it a couple times just to make some space for myself where I'm going to begin to type. And then I'm going to begin typing the word console. All right, and notice when I do that, I get this little pop-up menu that pops up under where you're typing. So don't let that distract you for now. Later, this is going to become your best friend. But for now, just ignore it and continue focus on typing the following code between those two curly braces. So console dot write line, and then I'm going to use double quotes, 2 double quotes, and type in the word hello space world between those 2 double quotes. And then I'm going to put a semicolon at the very end of the line. So console, capital C in console, dot, write line, capital W, capital L, write line, no spaces between those 2 words. An opening parenthesis, a double quote, the word hello world with a space in between, then another double quote, a closing parenthesis, and then a semicolon at the end, okay? And so now let's do the same here with read line. All right, so again, capital C in console, period, read line, capital R, capital L, opening parenthesis, closing parenthesis, nothing in between, and then a semicolon at the end. Okay, so I want you to inspect the code to make sure it looks just like what you see here on my screen. Again, capitalization is important, as is the spaces or lack of spaces, the use of special characters like double quotes, parentheses, whether opening or closing parentheses, semicolons, and so forth. It has to be identical, okay? And so if you see any red squiggly lines underneath something that you typed, that is your cue that Visual Studio is giving you that you didn't type something correctly. So take a moment to carefully inspect your work before going forward. All right, so what we're going to do is click this little Save All button in the toolbar here at the top. And then I want to run the application. So I'm going to click this little Start button in the toolbar. It's next to that little green triangle button. All right, and so if you did everything correctly, you should see a Windows command or console window open up with the message, Hello World. All right, awesome. So let's go ahead and click the red X in the upper right hand corner, and you can see that Visual Studio returns to its state. There might be some other windows open. You can just close those for now. All right. So if you see a message that there were build errors, then it's probably because you typed something incorrectly. So let's go through a few scenarios, some common problems that people have when they first start writing software. Okay, so when you see this dialog, there were build errors, would you like to continue and run the last successful build? Choose the No button. All right, and when you do, you're going to see an error list that will appear docked by default at the bottom of the IDE, at the bottom of Visual Studio. And it will give you clues as to what went wrong. The quickest remedy is to take a close look at what you typed in and see how your code deviates from the code that I wrote. And so here are some possible error messages and their remedies. So first of all, you can see that I have this invalid token. The parenthesis in class struct or interface member declaration, right? And as you'll learn, the curly braces define a block of code or a code block. Different commands belong in different types of code blocks, and we're going to discuss those in an upcoming lesson. But for now, if you see that message, it's probably because you didn't put the code in the right place. Make sure that you're putting it in between this opening and closing curly brace underneath the word static void main. So I'm going to just use my mouse cursor, highlight both those lines of code, hit Control X on my keyboard, move my mouse cursor inside, and hit Control V on my keyboard to paste it inside, and that should get me back into a working state. All right? All right, so if you see the build errors dialog and the message is that there is a semicolon expected in lines 13 and 14, and so to fix this, all you need to do is just add a semicolon to the 2 lines of code that you wrote, like so. Just like a properly formed English sentence must finish with punctuation, C# code also has to conclude with a semicolon. You are missing that in 1 or 2 lines of code, and so by adding it back in, your application should run. Great. If you see the build errors dialog and you get the message that there was a parenthesis expected, invalid expression term, parenthesis, and then a semicolon expected, or something along those lines. Well, this is a little bit trickier to interpret from the error messages, admittedly. The words hello world must be surrounded in double quotation marks. Make sure that yours has double quotation marks around the two words hello and world, like you see here on my screen. The reason is because we want those two words to literally be written to the screen, and so we use the double quotation marks to denote that those words represent a string literal. We'll talk about strings and string literals later in these lessons. For now, just apply those double quotes around hello world and you should be good to go again. Great. If you see the build errors dialog and you get the errors that say the name console does not exist in the current context, there's a good reason, because it's not lowercase c in console, or maybe you misspelled the word, but I suspect, as many beginners do, they don't realize that C# is case sensitive, so it's not lowercase c in console. You see the little blue squiggly line kind of giving you a hint. It's capital C in the word console. So as I said a few times, C# is picky about capitalization, so make sure you type exactly what I typed from now throughout the end of this series of lessons. Console with a lowercase c and console with a capital C are two different things as far as C# is concerned. So just capitalize the code, or capitalize the C in console, and you should be good to go again. Great. Similarly, if you get the build errors dialog and you see system console does not contain a definition for write line or read line, it's similar. It's because the W in write line must be capitalized and the L in line must be capitalized. The R in read line and the L in read line have to be capitalized as well. All right, so again, precision is important with C#, and there are some shortcuts that'll help you improve the speed and the accuracy of typing when you're in the Visual Studio Text Editor, and I'll talk about those a little bit later, and they are a godsend, and they will help you never to get it wrong. But if you see something that says that you know console should have a definition for write line, I mean, I wrote it, it's spelled correctly, make sure that the capitalization is also correct, all right? So if you find some errors or issues whenever you're typing in the code, try to pay attention to the error list like we have up to this point and let it guide you to help remedy the situation. Honestly, it's usually something pretty small. Once you learn more about the C# syntax, these issues will occur less and less often, or at least you'll be able to spot them or identify them quickly using the little blue and red squiggly lines that appear under your code. We'll talk about what those mean in an upcoming lesson. Okay, so assuming you got this to work, you're well on your way to building applications. As you undoubtedly learned in this lesson, writing C# code is an exercise in preciseness. Fortunately, the IDE will help you write code correctly, or at the very least, it's going to show you where you went wrong. So in the next lesson, we're going to focus on the syntax of the C# code that we wrote. If preciseness is required, then you're going to need to have some explanation as to what all these little words and these symbols mean that we've been typing in. It's really easy once you get a few basics under your belt. So we'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps for the world's best companies as quickly as possible. So in this lesson, we want to start with the process of dissecting this first tiny little application that we created. I want to spend a few moments to look at every line of code in this file, this program.cs file that you see here in the tab name, as a basis for future exploration in C#. So first of all, let's take a quick review of what we did in the previous lesson. First of all, we used the Visual Studio IDE to create a new Hello World project. And then we wrote code in the area that was defined by those two curly braces. We made some space for ourselves and typed in 2 lines of code. And then we ran the application by clicking on this little start button here up in the toolbar. And this opened up a Windows command line window, the console window. Our application appeared. It was simple. It was just the words Hello World displayed in that window. And I didn't point this out, but you can use the Enter key on your keyboard to actually move past that pause in the application and let the application continue on and exit out, all right? And at which point that Windows command line window just disappears. So I hope you can see how your actions when writing and building the application are manifested whenever you ran the application and interacted with it. But what I really want to do is cement these ideas in your mind because they really provide the basis, the foundation for everything that comes next. So let's start from the inside, the code that we actually wrote, and work our way outside. And so we used a programming language called C#. There are many programming languages in the world, but at this moment, C# is one of two popular programming languages used to create .NET applications. C# is one of the main programming languages that Microsoft supports in Visual Studio. And so I'd highly recommend that you learn as much about C# as you can over the coming days and weeks. It's probably your best choice as you're getting started. Now, most developers aspire to master one programming language when they're first starting out. But once you master a single programming language, learning a second and a third language will be easier because many of the concepts will transfer over, even if the syntax is just a little bit different. As someone who has been writing applications for over 20 years, I can assure you that C# is a great programming language to start with. So when you learn how to write applications with C#, learning the syntax of C#, or in other words, the nouns and the verbs and the punctuation of the programming language, is just half of the battle. The other half of the battle is learning about related pre-built functionality available to the programming language. In our case, Microsoft has created something called the .NET framework. And while that sounds mysterious, it's actually not that bad. For now, there are just two parts of the .NET framework that really concern us. First, there's a class library, which is simply a library of code that Microsoft wrote to take care of difficult tasks so that we, as developers, don't have to worry about them. So there's library code to help with math operations, or working with text, or displaying things to the computer screen, or transmitting information over the internet, and a bunch of other stuff, okay? So that's the first part, the class library. The second part of the .NET framework is called the runtime. It's also known as the Common Language Runtime, or the CLR. And it's just a protective bubble that your application lives inside of. And I use the phrase a protective bubble because the CLR, the runtime, takes care of low-level details so that you, the developer, can focus on what the application does and less about how to interact with the computer's operating system, its memory, its hardware, and so on. Furthermore, the CLR provides a layer of protection for the end user so that you, the malicious, evil software developer, you can't do much harm to the user's computer, at least not without their approval or their knowledge, all right? So for right now, it's the .NET Framework class library that I want to focus on. So when we typed in the phrase console.writeLine, we were using some code in that class library that knows how to display text in a Windows command line window. And all we have to do is tell it what we want to display, or rather, we just have to tell it the important part, okay? We don't care how it writes the text, we just care that the text gets displayed to the screen. And that's what we did here in the first line. Okay, so let's focus back on this code. When I wrote this code, I made sure to emphasize that you must write the code in the correct place between the opening and closing curly braces, otherwise the application will encounter an error whenever you try to run it. We talked about that at length. The correct place was between that opening, closing, curly braces, as you see on the screen. The curly braces define a code block, a block of code. So as you can see, there are several sets of curly braces. And you can think of this as a series of containers. I'm going to oversimplify for just a moment, and we're going to build on this definition later, but this innermost code block that's defined by these curly braces, they have a name. And the name of that block of code is main. That's the name of this code. And this code just so happens to be executed first when the application comes to life, when the application is executed. So let's not worry about those other words there like static and void and string and args. We'll get to all that a little bit later on. But this entire code block here, it defines something called a method. And a method is simply a block of code that has a name. Later on, you're going to come to realize that a method is much more than that, but let's just use that as a working definition for the next couple of lessons. The method has a name, so when you have a name, you can call that name and you can execute that block of code associated with that name. Again, more about methods a little bit later. All right, so the main method lives within another set of curly braces like you see here. It's a class named program. Think of a class as simply an organizational tool, a way to keep all of your methods organized. You put all of the methods that are somehow related together in a single class. Now, what do I mean by related? Well, that's up for you to decide. And as you get deeper into programming, you're going to come to understand the philosophies of writing code that will dictate where the code should reside. In fact, a class is so much more than just an organization tool. I really oversimplified it. But just like I said about methods, let's just keep it really simple for now. Let's just use that as a working definition for a couple of lessons until we get a chance to talk about creating your own classes a little bit later in this series of lessons. The main takeaway for now is that code is organized into curly brace containers, and you have some blocks of code that reside inside of other blocks of code, all right? So notice that the class program itself lives inside of a block of code. Let me highlight it. And it's called Hello World. Again, to keep things simple, just think of a namespace Hello World, as yet another way of organizing code. We're going to come back to this later, and I'm going to tell you more about classes, more about namespaces, but for now, just think of them as simple ways of keeping code organized. And remember that the methods that you create need to live within inside a class and a namespace. All right? All right, so let's take a look at this first line of code that we wrote. Let's investigate it even more. Console.writeLine, open parentheses, close parentheses, open double quotes, hello world. At the end of the line, we have a semicolon. Great. Here we're actually executing a method, a name block of code that somebody else wrote. The method name is writeLine, and the writeLine method lives inside of a class named console, okay? In fact, that second line of code that we wrote here is executing another method inside of that class called readLine. readLine is another name block of code that somebody else wrote at Microsoft, and both of these methods are organized into the same class named console, right? So since both of these methods deal with interacting with the Windows console, it just makes sense that they're both organized and they live inside the console class, right? So both of those methods have been written by somebody else, somebody at Microsoft. So we're borrowing code, or rather we're executing code that was written by somebody else by merely referencing the class name and the method name. And then notice there is a little period between each of those, that little dot operator right there, okay? That's called a member accessor. In other words, we can access a member of the console class by using a period after the name of the class, then typing in the name of the member, or rather the method that we want to execute. All right, so next, both the writeLine and the readLine methods have a pair of parentheses immediately following them. In the case of readLine, that's all we have, but in the case of writeLine, we have something in between the opening and closing parentheses, okay? The double quotes tell C# that we're passing a literal string into the methods. In other words, we literally want those exact words to be displayed. As opposed to what, you might ask? Well, I'll answer that a little bit later when we talk about variables. The key idea here is that some methods can accept input values, such as a literal string in this case, which is then used by the writeLine method to display to the console window. And we'll come back to the notion of methods in the future and passing in values to a method like we did with this hello world in the double quotes. Just know that whenever you see parentheses after a word, think method. A method is being called right now. Okay, a named block of code is being called so that it can execute. All right, so now let's talk about this little semicolon that may have caused some problems for some of you if you're not used to typing in C# code. You can see that it exists throughout the program here at the very top with some code that we haven't talked about, these little using statements. We'll get to those a little bit later, and then in the lines of code that we typed in. The semicolon is similar to the period at the end of an English sentence. It completes a thought in C#. Some programming languages like Visual Basic, for example, they allow one thought per line of code, but with C# you can organize multiple complete thoughts on a single line by just adding the the semicolon between them. So we could do this and our application would still execute, all right? But it's harder to read that way, so we generally put these on two separate lines. It's also possible to take a single thought and to break it up into multiple lines. Now, these lines of code are so short that it really doesn't make sense to do that. But as we get to some longer lines of code later on in this series, you're going to see me break up one single line of code into multiple lines so that it's easier to read. And so, as you can kind of see, the line breaks and the white space, you know, here we can add all this white space here. They really don't matter to C#. It's really the semicolons and the curly braces that matter, okay? So notice that there is some indentation to our code. Kind of by default. I mean, Visual Studio's IDE, the text editor will kind of lead you in that direction. I mean, if you try to like write a line of code way out here, console.write line, and then if I hit, notice that it automatically indented it all the way over to several tabs over. This is completely optional in C#, but it's so important that the Visual Studio IDE will try to add it by default. Why do you suppose that is? Doesn't it make it a little bit more readable this way to see kind of the indentation level and see what code belongs to what container, whether it be a method, a class, or a namespace? Well, most people think so. I certainly do. So that's why Visual Studio does that automatically for you. Along those same lines, Visual Studio color codes the text that you typed into the code window. As you can see, class names are kind of in this aqua color, maybe green on your screen. Special reserved C# words are in blue, like static and class and void, and we'll talk about those later. String literals, like the word hello world in the double quotes, you can see those are in red. And so this makes your code more human readable. Okay, so expanding out from here, you can see that we're working inside of a file called program.cs. It's the label that we see on the tab at the top of this main area that we're working in. Now, if we look over here on the right-hand side, in this little window in the upper right-hand corner, we see it called the Solution Explorer. And it has a tree-like view of the items in our project or in our solution. So at the very top here, we have something called a solution hello world. And inside of that, we have another entry called hello world. This is actually the project itself. And beneath that, you can see that there are several icons here. If you were to expand those out, you would see other files and little icons and things of that nature. We're going to learn more about the Solution Explorer and the other windows that are available to us in Visual Studio a little bit later. But simply put, the Solution Explorer is our main navigational device to the other files and settings that once compiled together will make up our finished program, our finished .NET assembly that we can execute or put on somebody else's computer. Right? And so you can see here's that program.cs. If I were to close this window after saving the changes I made, I can open it up again by finding its entry here in the Solution Explorer and double-clicking it to open it back up in the main area. All right. So files and important settings are organized into projects, which are compiled into a single .NET assembly, an executable application. Or not. We'll talk about that later. Furthermore, one or more projects are organized into solutions. In many cases, as you're getting started, you're only going to have one project inside of the solution, but as you come to build more complex applications over time, it's highly likely that you're going to need multiple, to manage multiple projects that are related somehow, okay? Again, the reason might not be obvious at this point, but as you continue learning C# and building more complex business-oriented applications for large companies, this becomes a crucial code management strategy. All right. So just for now, accept that there's this extra layer of solution owning projects, and trust me, it's important, but and it'll become more important as we move past the basics. All right. The big question at this point should be, where are all these files stored? I mean, I can see them in the Solution Explorer. Where are they on my hard drive? So when you rely on the IDE to create a project, you have to live with the conventions that they use for setting up the solutions in the projects. And you do have the option to change it. We had the option, I ignored it in the previous lesson. Okay, so if you're using Windows 7, you'll see something under Libraries here on the left-hand side. And when you select Libraries, you'll see an entry for Documents here in the middle. In Windows 8 and later in Windows Explorer, you'll want to go to this PC and drill down and go to Documents, which is one of the options. And then you're going to see a folder called Visual Studio and then the year, or rather the version. In this case, I'm using Visual Studio 2013. You might be using something called Visual Studio 2075, like, 57 years from now, or whatever the case might be. That's fine. Just go ahead and click on whatever the latest one is that you're currently working with, so that you can see inside of it. And there are a number of folders here that allow you to extend the ID's functionality, but the most important folder is the projects folder here in the middle. So let's double click that to view its contents. And since this is the first time I've created a project, I only see one folder, the Hello World folder. And as I add more projects, they're going to be listed here and they're going to fill up this whole area. Let's double click this Hello World folder to view its contents. And inside, you're going to see another Hello World folder, as well as a couple of files that are named hello world dot something, like in this case, hello world.sln, hello world.v12.suo. So the second Hello World folder actually contains the project itself. What this file is, this hello world.sln file, is the solution file, which is simply an XML file that contains settings that were stored by Visual Studio. So let's dive deeper. We're going to click the Hello World folder, the project folder, to view its contents. And so you can see a number of folders and files inside of the project. Some of these might look familiar if you compare them to the Solution Explorer. That's because you saw them in the Solution Explorer. Additionally, you're going to see a file called hello world.csproj, or a C# project file. It too is an XML file, and it contains important settings that are used by Visual Studio and eventually by the C# compiler to actually create a .NET assembly, an executable version of our application. All right, so just out of curiosity, what I want to do is open up this hello world.csproj file in Notepad, and I just want to view its contents. I certainly don't want to make any changes to it. I just want to open it up and take a look at it. So what I'm going to do is I'm going to right-click the Hello World project file and then click Open With. And when I do that, you're going to see this little dialog box. First of all, and this is so important, and please don't miss this, deselect this, because you do not want Notepad to open up, to be the default application that opens up CS project files from now on. You will curse me if you forget this step, okay? I'm going to click More Options and find Notepad. It's usually listed there, More Options. And now I can open up this Notepad, this Hello World project file in Notepad. Notice that what we see inside is a bunch of XML, and XML stands for Extensible Markup Language. It looks a lot like HTML because it's tag-based language. It's frequently used in the software development industry as a means of adding configuration settings to an application, or in this case, to a project file. So this is sometimes known as metadata. This file contains file paths, the previous state of the project, for example, which windows were open the last time we had it open in Visual Studio, and a lot of other important settings. And I can't emphasize this enough, do not make any changes in this file. Doing so might corrupt the project beyond repair. All right, truth be told, this Hello World app, we could throw it away, but never mess with this unless you know what you're doing. And at this point, I don't even know what I'm doing, so I don't touch these sorts of things, and you shouldn't either. I just wanted to demonstrate that there's no magic really going on here. It's just a bunch of configuration settings that comprise a project. And the same is true for a solution. It's just at a little bit higher level in the hierarchy, a collection of projects that work together. Okay, so what I want to do is close Notepad. Do not save any changes you may have accidentally made if you put your elbow on the keyboard or your cat ran across it while you were looking at this file. Don't save those changes. Okay. All right, so back in Windows Explorer, the Hello World project folder contains this bin directory. And the word bin is short for binary, denoting the binary executable output that was created by the compilation process. If you open that folder up like I did, it'll reveal its contents, and you should see a debug folder, a debug directory inside of it. So when you click the debug button, or the start running button rather, here on the toolbar, behind the scenes, Visual Studio compiled your application into what's called a debug version. The debug version contains additional information that allows the Visual Studio IDE to keep track of what's currently happening inside of that program as it's running. And as you'll see, this is one of the most powerful features of the Visual Studio IDE. It's the integrated debugging environment that allows us to watch code execute line by line as a means of determining where problems with our code might reside. We'll talk about that more later. Very cool and important feature, all right? So at some point, I want to create a released version of our .NET assembly that I can put on other people's computers and let them run my Hello World application too. And we don't want that released version of the application to be bloated with all of the extra information that Visual Studio needs when trying to do that debug choreography between Visual Studio and the running application. So therefore, we create a release version of our code, like we'll do in just a moment. But for now, what I want to do, go back here and click this, double-click the debug folder to see its contents. All right. So inside, we see quite a few files. The most important one is this helloworld.exe program. Now, depending on your configuration of Windows 8 and the Windows Explorer, you might not see file extensions like I have here. I think what did I do here? I viewed options. I don't know what I did. All right, but there's a way in Windows Explorer to change the options, the view options. It's here it is. And so I made sure to deselect hide extension for known file types and clicked OK. All right, so and then make sure you do that for all files or all folders in your in Windows if you want to see it this way. If not, take a look at the type column over on the right-hand side. Make sure that you're looking at the application, not one of these other files that are named almost identically, except they have another little word like .config on the end of it. All right, just a little tip there. But these other files have various jobs, mostly related to that process of debugging. In other words, to keep the Visual Studio IDE in sync with the code that's currently being executed inside of that assembly. And we'll see that in action in the next lesson. Hang on. Okay. But the key idea, however, is that this is the debug version. It's not optimized to be released to an end user's computer because it contains all this extra stuff that's used by Visual Studio for debugging purposes. Ultimately, we're going to want to create a release version of the application to distribute to our end users. More on that in just a moment. So let's do this. I'm just going to double click this helloworld.exe, making sure I'm clicking the one that says type application. So double click it, and whoa, there it is. It's running again. So even though this is the debug version of the application, you can see that the application can be run independent of Visual Studio. So just press the Enter key on your keyboard to allow it to continue and to exit. So again, when we run from Visual Studio will be able to keep in sync and even peek inside the execution of the application and allow us to see which lines of code are currently executing and perform debugging. Again, more later. Okay, so what if we wanted to create a standalone version of our application that we could give away to somebody else? Well, once we've finished writing and debugging and making sure that our application works just right, then we can create a release version of our app. So back in Visual Studio, there's a little drop-down box containing 3 entries here. Whoops. Yes, here we go. There is the debug, the release, and the configuration manager. All right, so clearly the debug creates a debug version of the application. We saw the folder that it creates in Windows Explorer. Here's the release option. It creates the release version of the application. And then this configuration manager option, let's go ahead and click it. It opens up this dialog that allows you to create different configurations. And this is applicable whenever you have multiple projects in the solution and you want to mix and match between debug and release versions for each project, or you're targeting different platforms. For example, the x86 platform versus the x64, 64-bit platform. That's a bit advanced for right now, so let's just ignore that. Let's close that window and get out of here. So what we want to do is choose release, okay? And then what I want to do in the build menu is select build solution. And so this will create an executable for the configuration that you selected, in our case, the release configuration here. You see, without actually running the application afterwards. All right, so in the lower right-hand corner, you can see these words, build succeeded, assuming that you've introduced no new errors into your code since we last talked. So now, back in the Windows Explorer, let's go back up a level, and you see a new folder called release. Let's go ahead and open up that folder, and whoa, you might be surprised to see that many, if not all, of the same files are here. I thought we were building a streamlined version for distribution on other people's computers without all that extra stuff that Visual Studio needs to keep the debug version in check. Well, the truth of the matter is that in these simple examples for the console window applications, the output will be identical between the release and debug versions. When you get into advanced scenarios, you have the option as a developer to conditionally compile certain code based on the configuration that you've chosen. How and why you would choose to do that, again, sorry, a little bit more advanced topic. Let's just not talk about that for now. Just be aware of the difference between the debug and the release versions of the applications for now, and you know how to create each of them. Okay, whew, we covered a lot of ground in this lesson. So I just want to recap what we talked about. First of all, we talked about the code that we wrote in our previous lesson. We talked about the organization of the code, how code is organized within curly braces. Those curly braces represent a block of code, a code block. We added code to a method code block called main, which is executed automatically whenever the user runs our application. Methods are organized into classes, and classes are organized into namespaces. And we also saw how we used methods written by Microsoft to work with the console window or the command window. In fact, both methods that we used, the writeLine and the readLine method, were organized into the same class, the same console class. And we access the console class's methods by using the period or the member accessor operator to access the member methods of that console class, at least two of them here. Okay. We also passed in a literal string, the hello world string, enclosed in double quotation marks, as an argument to the writeLine method. Now, we don't care how the writeLine method works its magic. We just care that it can display in a console command window whatever we tell it to display, in this case, hello world. And we talked about the syntax of C#, specifically the need for the semicolon as an end of thought punctuation mark for a C# statement. We also talked about about lines and spacing and indentation and how these don't really affect the code per se. However, they make it easier for we humans to read the code and understand what's going on. And likewise, we noted how the IDE's code editor uses color to further assist in the readability of our code. Then we used the Solution Explorer to understand the organization of the code files. We talked about projects as a means of collecting all the files and other settings required to generate a compiled .NET assembly. And we briefly explained how multiple projects can be managed under a single umbrella of a solution, thus the Solution Explorer window that we looked at as well. Finally, we talked about where you can find all the files for your project, as well as the file structure for the compiled versions of the debug and the release versions of the .NET assembly. So the good news is that you're well on your way to learning .NET and C#. Some of the more tedious aspects, honestly, are already behind you. And now it just gets a lot more exciting from here. So next we're going to review the basic features of the Visual Studio IDE that we've been using. And then we're going to move on to expressing more logic that we can add to our programs in C#. All right, great. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, we're going to spend a little more time investigating some of the additional features of Visual Studio. In order to be productive, you're going to need to know a bit about how to maneuver around within Visual Studio. So I'm simply going to highlight a few of the major features, but we're going to cover more throughout the remainder of the series. So in this lesson, I want to demonstrate, first of all, how to open up a project that we were working on, but we shut down, maybe we rebooted our computer or whatever the case might be. We'll also look at how to set breakpoints and step through our application's code line by line in order to debug the application, like we talked about in the previous lesson. I'm also going to explain how to benefit from IntelliSense, that little window that pops up whenever we were typing in our code a couple of lessons ago. And then how to customize the IDE's interface. I'm going to show you how to turn on line numbering. I already have that turned on, but I'll show you how I did that, and much, much more. So a lot to cover. Let's go ahead and get started. Actually, let's start this lesson by closing Visual Studio. And what I want to do is, if you haven't already done so, close it. I want to show you how to open up Visual Studio and get back to the projects that you were working on. And there's a couple of different ways to do this. You see by default the Start page appears whenever you open up Visual Studio. And there are a couple of options here on the Start page that you can use to get back to the projects that you were working on. For example, a list of the most recent projects here in the lower left-hand corner. The Open Project link here on the page will open up the Open Project dialog, as will File, Open Project. You notice there's also a keyboard shortcut, Control-Shift-O, in case you're one of those people who love keyboard shortcuts. And then finally, there's this Recent Projects and Solutions. This is the one I'm going to choose. You can use any of these options to get back to your Hello World application. Okay, great. Okay, so you probably have noticed by now, since we created our application and ran it, that there are a number of different windows and panes that pop open at different moments in time in Visual Studio. And some of them are hidden by default. For example, if you hover your mouse cursor, you actually go over here and you click on this little toolbox that's spelled, what is that, vertically, okay? The toolbox window will appear. And if I were to then move my cursor away and click away from it, it disappears. And so it has this feature turned on called Auto Hide. And I can turn off Auto Hide by clicking the little pin icon. It's next to the X in the upper right-hand corner of that little window. And when I click it, and now it looks like it's pinned down, Auto Hide is turned off. And as you can see, almost all these windows off to the right and left side, and also the ones that will appear from the bottom, also have this Auto Hide feature. So I can make it available or I can hide it. And so there are, as you can see, several major areas that you will see in Visual Studio when you're working with it, in screenshots and books and things of that nature. So for example, there's this main area that has a series of tabs. Now we only have one tab open right now, but there could be multiple tabs open here at the same time, and as we add more files to our projects, you'll see how that works. But this is the main area that houses the code editor. It houses a design surface for designing graphical user interfaces. It has different types of panes for designing database tables and things of that nature that we won't get into in this series, but that all kind of happens in that main central area of Visual Studio. And then we've already seen and talked about the use of the Solution Explorer here in the upper right-hand corner. This lower left-hand corner is the Properties window where we can set the properties of various visual objects selected in the main area. I'll talk about that in just a moment. There's also this this toolbar area here in the menu at the top that we've used several times already. And then there's also this area at the very bottom, and we noticed how it gives us status updates about the current state of Visual Studio. It's currently ready for us to do something. We saw what happened whenever we built the release version of our application. It told us that the build succeeded. Okay, so information like that, it'll put in this little area at the very bottom. It'll tell us when we're in the code window, what line, column, character we're on, and so on, whether we're in insertion mode or whatever the case might be. All right, and then there's this toolbox off to the left-hand side. So the toolbox area and the properties window, you might wonder, well, what are these for? For console window applications like we're going to be writing to learn the C# language itself, we're not going to have much of a use for the toolbox and the properties windows, quite frankly. They're more suited for creating and working with project types that create graphical user interfaces like Windows applications or web-based applications. So the idea is that you drag something like a button or a text box from the toolbox and you drop it into a designer surface area that looks like the window that you're actually building, and then you can move it around, you can resize a button or a text box, or you can select it and then make changes about some of its properties here in the properties window in the lower right-hand corner. And so actually at the very end of this series of lessons, we're going to do exactly that when we talk about programming events and things of that nature. We're going to create a graphical user interface, a web and a Windows-based application, just very briefly, but we'll use those two windows. They'll be key to our understanding of how to build them much later in the series. Okay. You'll remember that whenever we actually started our application in debug mode, and we encountered an error with our code, that a little error list popped up, and it gave us a list of the problems with our source code. So we're already kind of familiar with that window. There's also some other windows that we'll see that will appear from the bottom or the right side or the left side in different situations. For example, in just a moment, we're going to see some new windows whenever we get into debugging our applications. There's a locals and a watch window and a few others that become available to us in certain contexts. So what are these contexts I'm speaking of? Well, I'm talking about the different types of activities that we perform while we're building an application. So for example, there is the design time context. It's the context that we're in right now. It's where we're actually writing code and designing our application. Whenever we then selected the Start button on the toolbar, we were in a new context called debug time, also known as debug mode. We're running the application within the IDE, potentially stopping and watching the execution of individual lines of code, observing the values of the variables and the objects, and so forth, like I'm going to demonstrate here in just a moment. Then there's also a compile time context whenever we're compiling our applications. So there are certain actions that are being performed by the compiler. And admittedly, it's a very short period of time relative to the amount of time we spend in design and debug mode, but it's obviously a crucial context for our application where our C# code is turned into something else, into an executable version of our app, okay? So Visual Studio will display different sets of windows depending on the given context that we're currently in. Windows that will support the activities of that current context. So what context pops to my mind first is the debugging context. We've been talking about it. Let's go ahead and take a look at what that means. It's actually one of the most important features of the IDE, the ability to help you find problems with the code you've written. And there are several different ways to accomplish this. However, to begin this debugging process, what you do is you set a breakpoint in your code, which is like a stop sign for your code. So as your application is executing, Visual Studio will be watching, and then it sees that you've hit a certain line of code that's executing, and it will stop the execution of the application on that line of code and allow you, the developer, to take over from there. So while execution is paused, you, the developer, can investigate aspects about how your application is performing. You can even take control of the execution from that point on by stepping through your code line by line, jumping from one line of code to a whole different line of code to kind of change the order of the lines of code that are to be executed, changing the values inside of variables. And I know you don't know what that means yet, but there's a lot of flexibility with regards to debugging your applications using Visual Studio. So let's see how to do that. Let's set a breakpoint on our console.writeLine line of code that we wrote. So what I'm going to do is just put my mouse cursor over here in this column. Let's go ahead and get rid of the toolbox. I'm going to deselect the auto hide. Okay. So I'm going to put my mouse cursor in the gray column kind of along this line of code, console.writeLine. I'm just going to click, and you'll notice when I do that, it creates this red dot, and then it highlights the entire line of code in a red highlight. And if you've followed along this series, there's a chance that we were still in release configuration. What we want to do is change that to the debug configuration for this project. So make sure you change this back before you hit the Start button on the toolbar, which we're going to do next. And I want you to understand the order of what's going on here. I hit the Start button, and then you saw the console window pop open for a split second, and then immediately we were returned to Visual Studio. That red line of code is now highlighted in yellow. That indicates it's the very next line of code that will be executed in the execution path for our application. Also, you see a little yellow arrow off to the left-hand side imposed on top of that red dot. Great. You can also see that there are several windows that appear at the bottom, namely this locals window, and behind it the watch window. It's on kind of a separate tab here. And then over in the middle there's the call stack tab, and then there's the intermediate window tab behind it. So they're kind of paired together. That doesn't infer a relationship, it's just how they happen to be laid out, okay? And so I just want to acknowledge at this point that these windows exist and that they appear during debug time. I'm not really ready to use them in any meaningful way just yet, though. So now if I want to step through each line of code line by line, all I need to do is either use a keyboard shortcut or one of the three icons that appear here on the toolbar. So if I hover my mouse cursor over, and don't click yet, just hover your mouse cursor, you can see a little helper window pop open. There's the step into, the step over, and the step out. Understand that for now we need to use this middle step over button or the F10 key on your keyboard. And watch what happens to that yellow line. It moves down one line of code. It reveals the breakpoint. And also, if we were to switch over to our console window, the words hello world were printed to screen. And now we are on the next line of code that will be executed is this read line. So I'm going to click it one more time. And when I do that, notice that the console window pops back open. It's actually waiting here per the instruction of the read line method for the end user, me in this particular case, since I'm debugging the application, to hit the enter key on my keyboard, which will then allow us to continue walking through. You can see it's exited off of the read line and now moving on to some of these other lines of code, which are kind of completing the code blocks that have been defined. I'm just going to click this start button, but wait, it's changed names. It's now the continue button. That's fine. It will continue execution throughout and end the program. Okay, so now that we're done with the breakpoint, there's a few different ways to remove it. We don't need it anymore. We don't want to stop on this line of code any longer. We want to remove the breakpoint, so we can do one of three things. We can either click the red dot. Again, notice that it goes away, so I can turn it on and turn it off. Or I can use the F9 button on my keyboard when this line of code is selected. So when I have the caret on that line of code, I can hit F9 to make it disappear. It'll toggle the breakpoint for the current line of code. Or I can select the debug menu option, toggle breakpoint, and it will remove it as well, as long as we're on that line of code with the caret with our text cursor. Okay. All right. So several times in this series of videos, I'm going to comment out a line of code and replace it with a different line of code. Or I'm going to create a code comment to make a note to myself or somebody else who may work on the project in the future about what it was that I was intending to do, or explain why I did what I actually wound up doing. So a comment is denoted by a double forward slash, so // and then I can type anything here, like for example this is a comment. All right. And comments are not compiled into the application. So simply put, it's an instruction to ignore a line of code. And we can simply type 2 forward slashes in front of an existing line of code in order to comment it out, which is a phrase I'll use often throughout the series. However, if we have multiple lines of code, we might want to use a more convenient technique. So I can use my mouse cursor to kind of just start the last line of code that I want to highlight, and then drag it to the lines of code that I want to comment out. And then I can use this little button on my toolbar, comment out the selected lines. And when I do that, notice that it's commented out both lines of code. And I can do the opposite as well. I can select both lines of code and then click the button that's right next to it, the uncomment the selected lines button, and it will uncomment out those lines of code, and they'll be compiled back into our application. And finally, there's a multi-line comment. What you do is you begin with a forward slash and you put an asterisk next to it, and then you move to the bottom or the last line that you want to comment out, and then do the opposite, an asterisk forward slash. And now, as you can see, it's kind of highlighted there. It will comment out multiple lines without having just a bunch of double forward slashes prefixed to everything. Okay? And so this is actually my preferred technique whenever I comment out multiple lines of code, is to use that /* //. Okay. So as you were typing that first line of code, you may have noticed that window that appeared beneath the caret as you typed. Well, this window is called IntelliSense, and once you master it, it can perform several really helpful tasks. First of all, it lets you know your contextual options, and it will actually finish your typing for you, or autocomplete what you're typing. So let's do this. In this case, I'm going to type in the word con, and notice that it pops up console, but it will probably put you close to any of those, in this case, classes or any identifiers that really would make sense in this context. Okay, it just happened to pop up console this time, but it would probably get you close no matter what it selected first, maybe some of these other options, right? But at this point now, what I can do is I can use the up and down arrows to move through the list of options, or I can continue typing to filter the list. Furthermore, what I can do next is I can hit the space bar. So let's go down to console and hit the space bar, and notice that it typed out the entire word. This actually works with any delimiter. So for example, console dot, and so I used the dot because I knew I wanted to go console dot right line, and when I did that, it finished typing the word console, and it popped me to what it thought I wanted next, which is the right line. Because I used it previously, chances are I might want to use it again. IntelliSense, okay? And so here again, I can use, if I've already started typing right or right line or whatever the case might be, all I need to do is type a few letters and then hit the next logical delimiter operator, whatever the case might be. And so in this case, parentheses, and it will type the rest of that method name for me. Awesome. So frankly, I rarely type more than just a few letters of any given class or method name or variable name or whatever the case might be, and I rely on IntelliSense heavily. In many cases, I may not even really know what I need when I get started. I just type a few letters and then I use the up and down arrows to find what I'm looking for, and then I select whatever the next logical delimiter is, whether it's a space, period, parentheses, whatever the case might be. So the second cool thing that that IntelliSense does for you is that it gives you a brief window containing help for the current property, method, class, or keyword in .NET. So in many cases, this will be just enough information to help you navigate through unfamiliar territory as you type your code. So here, let's back up a little bit here and let's get to the point where we can let it do its magic again. I'm going to type in WR right line, and about a second goes by, and then see that little window that pops up, and it gives me a little explanation about what this method does. It writes the text representation of the specified array of objects followed by the current line terminator to the standard output stream, blah, 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 blah. All right, you're saying, well, all it really did was just print a screen. I know, it's just being very specific. This is developer speak, okay? But essentially, it will prompt you, for example, what's the difference between right and right line? Well, I can compare the two. This one writes to the standard output stream. This one writes to the output stream with a current line terminator, which means it'll give us, you know, that one line that'll move to the next line and print out the rest of whatever we have below that. Okay, so it helps me to narrow down what my options are and select the right thing, the right option based on what I'm trying to accomplish. Awesome. It helps me refamiliarize myself with the options, these two similar options, and which one I should select. Great. And then third, it provides information about the input parameters for methods. So we haven't talked about methods or input parameters, but we did send hello world into our right line method, and notice when I hit the open parenthesis on my keyboard, it automatically typed the closing parenthesis for me. It put my cursor in between the two, and then it pops open another IntelliSense window, this time showing me what can I pass into this method. And there's a bunch of different things I could potentially pass into this method. In fact, there's 19 different kinds of things. What are these things? We'll talk about those later. Don't want to get into that right now. But, you know, I just wanted to say that nobody memorizes all this stuff, all right? We look for visual cues, and Visual Studio gives us these cues that we can rely on. One of the secrets to programming is to rely on IntelliSense to learn in real time and to help prompt you along to make the next correct action. And then let it type things for you so that you don't mistype them, forget a capital letter here, or you misspell something there, okay? By relying on IntelliSense, you get a lot of magic kind of baked in, and you don't have to do all the heavy lifting yourself. Okay, so let's go ahead and remove this line. I don't want that here. So additionally, the code window features that same helper window with a brief help message as you hover your mouse cursor over just about any expression or keyword in the code window. So in this case, what I want to do is hover my mouse cursor over read line, and you can see that it gives me that little explanation that it reads the next line of characters from the standard input stream. So this helps whenever I'm looking at code that I might not be familiar with. Finally, with regards to the code editor, it's going to give you different types of clues as to what could be wrong with your code. You may have seen this already. You definitely saw it if you watched the very, lesson number 3 in this series. So let's do this. What I'll do is I will intentionally misspell the word line. And when I do that, it takes about a second, but I see the little red squiggly line underneath the right method, okay? And so this indicates that something might be missing. In this case, the I in right line, or perhaps I'm missing the end of line terminator, so I'm missing that semicolon there, okay? And so then also, I want you to notice that you can hover your mouse cursor over the red squiggly line and it will tell you what's wrong. In this case, a semicolon is expected. Gotcha. We can do that. Awesome. And so there are other colors of squiggly lines for different types of warnings or errors, ranging from things that are critical to simply things that you should be aware of, or simple warnings that you could possibly ignore. All right, let's move on. Visual Studio is highly customizable. And there are 2 different configurations that we're going to modify in this lesson, but feel free to customize the environment to your liking so that you can be more productive. Whenever you encounter some annoyance, chances are you can change the default behavior somehow. So what I want to do is make 2 modifications. First, what I want to do is show you how I turned on line numbering. Now, you never saw me actually do this in the lesson. If you recall, when I signed into Visual Studio, it actually pulled my preferred settings from Microsoft servers. So it saw that Bob Tabor's logging into a new edition of Visual Studio. He loves line numbers. Let's go ahead and turn those on for him. Very cool. So let me show you how to turn these on for yourself. First of all, what we want to do is go to Tools, Menu, and then select Options, usually near the bottom. And then what I want to do is scroll down on this left-hand side until I find the text editor. And then I'm going to drill down in the text editor and select C#. All right, and you can see in the C# text editor, I already have line number selected. But if I were to turn that off, you'll notice that that column goes away. When I go back, Tools, Options, Text Editor, C#, I can turn them back on like so. And so this is helpful because it allows me to say, hey, take a look at line number 13 there, and I can call your attention to it, or I can make a note to myself of the particular line, or if there's an error and it tells me what line it's on, I can go and visually see which line of code that was affected by that. So let's do this now. I want to go back to Tools, Options, and this time what I want to do is change the colors in the code editor window. Now, some people prefer dark colors whenever they're working with Visual Studio all day, every day. They claim that it's easier on the eyes. Okay, so what we want to do is go to Environment, and then I'm going to drill down there and go to Fonts and Colors there. And what I want to do is just simply flip around these colors. So what was white, I'll make black, and what was black, I will make white. And I'll click OK. And you can see that I've dramatically changed the look of that window. All right. Honestly, that's a little bit too much for me personally. I'm much more of I just like the default settings typically. So I'm going to go back and change those back to automatic and automatic. However, there are a number of themes that you can use, you can download, that will change the entire IDE's color scheme and so on, and fonts that are used and so on. All right, next up I want to talk about the code rollup feature, which allows us to show and hide passages, or rather blocks of code. And the reason for this is to reduce the clutter as we search through the code that we've written visually. So we can roll up all blocks of code that we want to temporarily hide by clicking the little you can see this little minus sign in kind of next to our number column here. If I click that, notice that is rolled up all those lines. So instead of going 11, 12, 13, 14, 15, 16, it just goes from line 11 to line 18. So we've rolled up static void main, and over here on the right hand side there's a little box with an ellipsis. If I hover my mouse cursor over that, it will show me the code that's inside of that window, or at least a snapshot of that code, letting me know what was rolled up there. So it allows me to visually hide it, but I can get back to whatever information is inside of it. I can do multiple roll-ups. I'm not sure how helpful that is, but you can certainly roll up any block of code and then be able to hover over and see what's inside of that if you want to. All right, so the next thing that I want to talk about is visual feedback regarding the state of your code and whether it's been saved or not. So when you have code that's yet to be saved, you can see it in one of two ways. First of all, you'll notice in the tab next to the name program.cs, the file name, there's a little asterisk. So that suggests that this file needs to be saved. There's also a little yellow vertical stripe that appears next to the numbers, the line numbers for the code. And so this tells me that this code has not yet been saved. So what I can do is click the Save All button, and when I do that, notice that those lines that were formerly yellow, they are now green, indicating that they've recently been changed and recently been saved. Now, let's do this. I want to close this tab by clicking the little X in the right-hand corner of the tab, and then I'm going to open it again by going to the Solution Explorer and double-clicking program.cs. Notice when I do that, it gives me a little preview window over here because the tab is in the right-hand side. If I want to work with this window, I can double-click the program.cs, and then it will be opened on the left-hand side. So when it's on the right, here, we'll just do this. It's just a preview. If I make any edits to this whatsoever, like when I hit the spacebar on my keyboard, or if I double-click program.cs in the Solution Explorer, then it will open it up in edit mode, essentially, all right? And now, notice here, I kind of messed up what I was going to show you here. Let's go ahead and close it, open it up again, and notice that there are no lines, no yellow or green lines here in this area between the line numbers and the roll-up region areas. And that indicates that this is a fresh file that has not been changed since the last time we've opened it up into the main area of the IDE. Okay? All right, so this was a very small collection of information about the IDE. We could spend hours talking about all the little cool features that Visual Studio has tucked away, but you're going to learn enough to be able to be competent with it by the end of the series. So just hang in there, you're doing great. See you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development jobs building Windows and web apps at some of the world's best companies as quickly as possible. In this lesson, I want to get back into the C# programming language itself and talk about declaring variables. So just to begin with, let me throw an algebra problem at you, and hopefully you can see where I'm going with this. You've probably seen a simple algebra problem at some point in your education that looks something like this. 5 plus 7 equals x. And it would ask you to solve for the value of x. And without a lot of thought, you can easily figure out the right answer. So using that same thought process, take a look at this. X equals 7, y equals x plus 3, console.writeLine y. What would you expect to be displayed in the console window? The value 10, of course. You just read C# on your own without any of my help. It's common sense, right? It's pretty easy. Now, okay, honestly, there's a little bit more to it than just that. First, the X and the Y, as far as C# is concerned, are called variables. And a variable is simply a bucket in your computer's memory that's capable of storing a value. So you can put stuff, values, into the bucket. You can retrieve stuff, values, out of the bucket. You can put new stuff to cover up the old stuff in the bucket. And in this particular case, these buckets are just holding numeric values, but we could create buckets that are just the right size for dates and times, for strings or passages of text, for really, really big numbers, or numbers that have values after the decimal places, and a lot more. So in the case of this little code snippet on screen right now, we would expect both x and y to hold numeric values. Now we know that, but we have to use C# to express that to the .NET Framework runtime. So remember, the runtime is what does the hard work of managing the execution of our application. And part of its responsibilities is to allocate memory for our variables that will hold data. So here we have two data items, x and y, and we have to tell the runtime to allocate some space and memory sufficiently large enough to hold numeric data like that. Okay, so let's begin by creating a new application to learn a little bit more about variables. So I'm going to write a little code, and then we'll talk about it, we'll break it down, explain what's going on, and we'll add some more code after that. But as we move forward in this lesson, the big takeaway is that a variable is simply a bucket in memory that you can put data into and retrieve data out of. All right, if we get that accomplished by the end of this lesson, we will have done quite a bit. Okay, so to get started in this lesson, I want to create a new project. There's a lot of different ways to do this. In the past, we've used File, New Project, and this time I'm going to just go to the Start page and click the New Project link on the home page. Either way, you're going to come to this New Project dialog. And so we want to make sure that, again, C#, templates selected, filtered on the left, console application selected in the middle. That's the template we want to use. And then we're going to change the default name to variables and then click the OK button. All right, and so what we're going to do next is type a bunch of code right here. Great. Now, before I do that, two little quick things I would really like to tell you about. First of all, watching a screencast tutorial is different than watching your favorite sitcom or watching a sci-fi movie. You need to be an active learner. The only way that you're really going to learn how to code is to actually get your hands dirty, get your fingers on the keyboard, and start typing. You need to follow along with me and actually type the code in yourself. It builds muscle memory. It gets you comfortable and familiar with the code editor. It builds your understanding and your familiarity with IntelliSense like we talked about previously. So do this. Pause. Rewind a few times if you must, but actually typing the code into Visual Studio is the single best way to learn. Secondly, all the same rules apply here that applied in lesson number 3. You have to type the code exactly. If you don't, you're going to experience some errors. You'll see those little red squiggly lines, or if you try to run the application, we'll get those error messages that'll pop up. And if you do run into problems, please refer back to the end of the third video where when we created the hello world and then I showed you some of the possible things that could go wrong, like if you didn't put the code in the right place or you forgot a semicolon at the end of the line. Use that as a reference. Okay, and let me say this. If you see me getting it working in this video and you can't get it to work, here's what people always tell me, and I had a college professor say this to my son in his previous semester in college. If you say to me, I did exactly what you did and I'm not getting the same result, I don't know how to put this nicely, but it's you, it's not me. You made a mistake typing in. Pay close attention to every single character that you type in. And at first, it's going to be difficult to ferret out where the problem is at. But over time, as you begin to think in C#, things will pop out at you. Oh, duh, I missed a semicolon. Read line is, it needs a capital R, capital L, and those sorts of things. Okay? All right, so let's go ahead and get started with those caveats, and we'll begin like so. And there we go. Okay. So the first two lines of code here, in lines number 13 and 14, are where we declare our variable. So to borrow from the explanation earlier in the lesson, we are officially asking the .NET runtime to allocate space in the computer's memory sufficiently large enough to store numeric values. We're asking it to create two buckets that will each hold values that eventually we're going to drop into them. After we've created those buckets, or those variables, we can begin to assign values into those variables. And most importantly, we're going to assign integer values into those variables. How do I know they're going to be integer values? Well, take a look at the keyword that we used in line 13 and 14. We use the keyword int. Int is the C# term for integer, a mathematical term that refers to a number that has no fractions or decimal values. It can contain very large numbers in C# from a negative 2,147,000,000 to a positive 2,147,000,000. Now, if you need to store a number that's larger than that range of numbers, then you're going to need to use a different data type. Or to continue our bucket analogy, you're going to need a bigger bucket to hold all those numbers. And there are many different kinds of data types. There are simple data types, complex data types, and then even later on in this series of lessons, you're going to learn how to create your own custom data types. But because I don't want you to be overwhelmed just yet, let's keep it simple for the moment. We're just going to talk about integer data types for now. In a moment, we're going to talk about the string data type, and then we'll add a few more data types along the way as you continue through this course. So after we've declared the variables, we can access our variables. We can assign values to the variables or read values from the variables that are already in the variable. And so we did all of that in the following lines of code, in lines number 16 and 17. We assign x equals 7, and then we read the value of x, append 3 to it or add 3 to it, and assign that new value, 10, to our variable y, and then we read the value of y in console.writeLine, passing in the value of y, okay? So the equal sign is an assignment operator. In English, that line of code is basically saying, set the integer called x to the value 7. And then we do the same thing in the next line of code. Set the value of, retrieve the value of x, 7, add 3 to it, and then assign that to the value of y, and then finally console.writeLine, retrieve the value of y from a variable, the variable y, which should be 10, and then print that to screen using console.writeLine, okay? So will it work? Let's go ahead and give it a whirl, and we can see that indeed we get the value 10 as we would expect in our console window. Okay. So now what we want to do is just comment all of this out. So I'm going to use that format for commenting multiple lines of code like I talked about in one of the previous videos by using the / asterisk at the top, asterisk / at the bottom of the section of code that I want to comment out. So now, just to kind of drive that idea home, I run the application. The only thing that happens is the read line. I hit the enter key on my keyboard to continue on. Okay. So just as a side note, I want to leave this code here for you to reference if you were to download the code that's associated with these videos. However, I often take this approach whenever I'm writing code. I'll comment out some old code and I'll keep it around for a little while. I'll reference it while I'm writing new code that I intend to replace it. And then after I'm 100% sure that the new code actually works, then I'm going to go back and I'll remove that old commented out code. This is just one of the many little habits that I've developed through the years. This particular habit allows me to get back to the original code in case I make a mistake with the new code and I got to start all over again. Okay. So let's create another example. This time let's work with a different data type. So below this code that I've commented out here, I'm going to start in line 22 on my screen. I'm going to add the following before this console.readLine and after this commented out section, okay? Okay, extremely simple code example. Notice that in line number 22, that string is the keyword for creating a bucket in memory that can hold textual information. Think alphanumeric characters. Also notice that I can name my variables anything that I want within certain limits. Now as a convention, because most programmers do this, I use a lowercase m in my first name followed by a capital letter at the beginning of each additional word. So this is called camel case. And you should get into the practice of doing this too, because most programmers do this, especially for locally scoped variables. We'll talk about scope in a little while. So for now, let's just use strings and integers within our examples here and in the next couple of videos. But there are probably a dozen other data types that you'll eventually want to know, and we'll come across more, like I said, later on in this series of videos. And then obviously as you continue on in your C# education. All right, so let's go ahead and start debugging the application, and you should see the name that you typed in. I typed in Bob. At this point, our code example is really just a glorified variation on the hello world example that we created back in lesson number 3. The only difference here is that I used a variable to hold the literal string Bob as opposed to the literal string hello world that we typed directly into the console.write line. Okay, so before we move along, I want to re-emphasize from an earlier video that C# is a case-sensitive language, meaning that we can possibly add this line of code below the previous lines of code that we added. So let's just do this right here. String my first name, all right? And even though these two variables are spelled exactly the same, by virtue of the fact that the second variable declaration uses no capitalization, it means that these are two different variables. So this can be pretty tricky, and you should be cognizant of what you are typing. Be consistent and cautious whenever you're declaring and using variables. Now the good news is that Visual Studio will try to help you out as much as possible by correcting any capitalization mistakes that it can. However, the bad news is that there might be situations where you're on your own, just like this situation where you declare two variables with very similar names, spelled the same with different capitalization. So the best advice is always to be aware of what you're typing and why you're typing it, and to try and avoid using two variables with the same spelling but different capitalization. Of course, every rule is meant to be broken. There is a reason why you might want to do this. We won't talk about it in the series of lessons. I felt compelled to say that though. Okay, so let's move on. So let's comment out that line of code. We don't need that. One thing I do want to point out though is that I can condense these two lines of code into a single line of code. So let me comment these two out like so, and then I'm going to rewrite it like this: my first name equals Bob. So we can both declare the variable and initialize its value in one line of code. So experienced developers like to write less code. So they're always looking for a convenient way to reduce the number of keystrokes that they have to type and reduce the amount of code that they need to look at and to understand. So you should get into that practice as well. Now let me take this example one step further. Let me comment this out, and I'm going to go var my first name equals Bob. All right, and let's just run it to make sure it works, and it does. Okay, what is this var keyword? Is it a variable type? No, it's not. Several years after C# was created, a few innovations were added to the programming language to reduce the amount of code that you had to type. Now, while there's a long story behind why the var keyword exists, I imagine that you're probably going to see some code examples out on the internet or out on MSDN that use the var keyword instead of this longer format that we've been using, like int x or string my first name. So the idea is this: the C# compiler, you know, what takes your code and actually then turns it into a .NET assembly that will then be executed inside of the .NET runtime. So it creates that .exe file in our bin debug directory or our bin release directory. So the compiler, it's smart enough to see what you're initializing the new variable to contain. So why not just let it figure it out? Now it's important to know that in this case, the variable my first name is of data type string. It's not an unknown data type. And once we declare the my first name variable using the var keyword and initializing it to this literal string Bob, it can never hold any other data type, such as a number or a date time or anything else. So admittedly, in this mundane example, you may wonder what all the fuss is about. Why am I even talking about the var keyword? When we get into some more advanced examples later on in this series, you're going to begin to discover how important this new var keyword is. But it'll probably be like in lesson 20. So hang in there with me. Just wanted to introduce it here at the very beginning. It's important to note that you must supply a value to initialize your new var to. So if you don't, if we just did this, for example, let's comment that out and just go var my first name, and then I go to actually, I see a red squiggly line, I hover over, implicitly typed local variables must be initialized, okay? So, okay, again, you have to set it equal to something, even if it's just an empty string, okay? That will then tell the compiler, I know this variable is of type string. It can create the bucket in memory sufficient to hold a string, and then you can move on happily. And I'll have more to say about the var keyword near the end of the series, like I said before. I just wanted to introduce it here early on because it has become used so often in blogs and books and even examples in Microsoft's own documentation that if you didn't know that it exists, I think you might get a little bit lost the first time you see it. So just think of it as a shortcut to declare a variable, and that's it, at least at this point. All right, so let's move on and talk about how to convert one data type to another. When you convert one data type, like for example, my home address is 4110. Now I can put that in a string, but what if I wanted to convert that into the number 4110 so I can do some algorithm to see how many house numbers are in my town? I don't know. Okay, but that type of conversion where you're taking something from one data type and you're converting it to another data type, it's called data conversion. And so you might need, and you often will need, to know how to change a numeric value into a string value and back. All right. So we already know that you can't simply treat a string variable as an integer or an integer variable as a string, because those buckets are sized differently based on the kind of data that they hold. So therefore you have to perform a conversion of the data. So let's do this. Let's comment out everything up to this point. There we go. All right, so now I'm going to add the following code. Okay, so int x equals 7, got it. String y equals Bob, okay. String my first try equals x plus y. So I'm going to try to take a bucket that holds a number and a bucket that holds a string and pour them together into a new bucket that holds a string. How is that possible? How is it possible for our application to treat the integer 7 as if it were a string that it could concatenate together with another string to create a third string? Okay. Well, .NET allows us to implicitly convert x into a string so that it can combine, or rather concatenate, x and y together. This is an example of an implicit data conversion, a data type conversion that just works, and we don't need to do anything special. .NET is smart enough to treat the integer 7 as an alphanumeric 7 to be used as part of a string. So what's going on behind the scenes is this. We'll take and call a toString method. All right. And you're like, whoa, where did this method toString come from? Okay, so most types in the .NET framework have methods defined that perform certain basic tasks like type conversion. So as a result of declaring a variable to be an int data type, we get a bunch of add-on features for free, whether we need them or not. They're baked into variables. More about this later, but you've got to admit that's pretty convenient, right? Okay, so notice that plus operator in line number 37. It's used here as a string concatenation operator. Now, if we're adding two integers together, it would change the meaning of this operator based on the context to be an addition operator. Just something to be aware of. Depending on what we're trying to do, it'll either concatenate or add two integers together. So we can rely on .NET to perform some implicit conversions. However, I recommend against this. You should never rely on implicit data conversions. I encourage you to always take control of your code and perform explicit data conversions. Otherwise, you're likely to introduce subtle bugs that are hard to find inside of your applications. So, how do you perform an explicit data conversion? Well, let's take this example and go one step further with it by adding this next line of code. All right, so immediately notice that there's a red squiggly line under x plus y. So do you want to take any guesses as to why that might be? It seemed to work the first time when we used my first try, Well, the reason is because .NET cannot reliably figure out a data conversion from a string into an integer. If it knew that the string was always something like 7 or 4110, then perhaps it could do it. But in our case, how is it going to convert Bob into an integer and add that to the number 7 mathematically? It can't. So in this case, we're going to have to explicitly convert data types. Explicit conversion means that we will have to write the code to perform the data conversion ourselves. Unfortunately, we can use some built-in features of the .NET framework, as we're going to do in a moment, but still, the onus is on us as developers to perform the conversion. Okay, so C# is a strongly typed language, meaning that data types must be declared and they must be honored. Therefore, when a situation arises where you need to use an integer where only a string will fit, then you need to perform the data conversion. It's the equivalent of cutting the corners off of a square peg so that it will fit into the round hole. So I'm going to demonstrate two data conversions in this lesson, from int to string and then from string to int. So let's comment out this line of code here. And below it, I want to write this line of code. Int my second try. Okay, so if you attempt to use the start button, you're going to get an unhandled exception dialog, and unfortunately the error message, if we were to hit break, we take a look at the error message, it says that the input string was not in a correct format. Now translating that into human speak, basically the application compiled correctly, however when the program was running, the value Bob could not be converted into an integer. So int.parse was expecting a value in the input parameter that it could convert from a string to an integer. Now in this case, as we said, Bob can't be converted into a number. As a side note, notice that the data type int has methods. Just like we saw earlier with the toString, it also has this parse method. And there's a really good reason why this is, which you may not appreciate until later, so I want to hold off on that until a little bit later. More importantly for our purposes in this lesson, by calling int.parse, we are explicitly telling the .NET runtime that we want to convert a string into an integer. And there are many different ways to explicitly convert one data type into another, and we're going to cover another one later on in this lesson. Usually it's preferable to explicitly convert data types rather than to allow them to be implicitly converted, like I said before. This makes your application less brittle and subject to special circumstances that you didn't foresee. All right, so let's stop running this application. And so to remedy this, what I want to do is comment out this line of code, string y equals Bob, and below it, I'm going to add string y equals the string 5. All right, so 5 surrounded with double quotes, which will make it a literal string. Also, what I want to do is go console.writeLine my second try so that we're printing out that new variable there. Great, and now let's run it. And we get the number 12. Great. Now let's do this. Let's comment out line number 44 and let's see what happens whenever we do the explicit data conversion on x. It occurred to me that we never actually ran this example now that we have x equals 7 and y equals 5. Now remember, when we attempted to add those together and set them to my second try, we were able to print out the sum of those two values. Let's see what happens whenever we try to concatenate x, the integer of 7, and converting it to a string, and then concatenating it to the value of y, which is now 5. All right, we get 75, the string 775, but those are just two alphanumeric characters, not really adding those two values together, okay? So the key idea in this lesson is how to declare, initialize, and work with variables and data types. In the .NET framework, even simple data types like the int have some powerful helper features, some methods that we're able to call to convert one data type into another data type whenever we need it. All right, see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps for some of the world's best companies as quickly as possible. In this lesson, things are going to start getting more interesting. First off, I'm going to demonstrate how to accept input into a console window application. And then based on the user's input, we're going to write logic to execute different blocks of code. And I'll demonstrate two different ways in C# of accomplishing this. But let's get started by creating a new project. So using one of the techniques that we learned about earlier, I'm going to use File, New Project, open up the New Project dialog. I want to make sure I'm in the C# templates, make sure that console application is selected, and I'm just going to call this Decisions, and then click OK. All right, and then next I want to type in a bunch of code, so make sure you follow along closely with what I do. Okay, remember, pause, rewind if you have to catch up, but make sure that you have on your screen what I've got on my screen. All right, so the key to this example is line number, let's see what line number it is, number 15 here, where we've previously used console.readline to stop the execution of a Windows console application, so we actually see the results before the application just flashes and we can no longer see the output. However, as you can see, this line of code, we're using it to actually retrieve whatever the user types into the console window. And then next, we're merely in line number 16, concatenating or appending a literal string you typed with the value that we retrieved that the user typed in. So let's go ahead and run the application, start debugging it to watch it in action. So it's prompting me to type something and then press the enter key. So I'll just type something and then hit enter, and it just repeats it back out to me. Awesome. So what we want to do is use this technique to add logic to our application. So first of all, let's get rid of everything we've done here except readline, because we're going to start over again, and I'll just use this little comment out the selected lines button after I've selected all 4 lines of code here to comment it all out, and I'm going to start over and I'm going to do the following. And let me just grab this console line here and move it up into that if code block. Great. Move that over a little bit. Okay. All right. So as you're, if you're still typing this, pause the video. Make sure you have what I have on my screen before you continue on. So what does this code do? Well, when the user types in the value at the command prompt and then presses the enter key on the keyboard, whatever the user typed in will be evaluated. If it is the number 1 on the keyboard, then we're going to display a literal string in the console window. So the most important lesson for our purposes is the syntax of the if statement. It's called a decision statement because based on the conditions that we set up, we decide whether to execute the block of code immediately following that if statement or not. So in line number 21, you can see if user value equals the number 1. So that's the condition that will be evaluated. The condition is surrounded with an opening and closing parentheses. So we're evaluating the string username. It is a variable that I created in the previous line of code to retrieve the value that's returned from console.readline. So if that value is the string 1, then the next line of code will be executed, which calls the console.writeLine method to display the message to the user. So the use of that double equal sign operator, it's different than the single equal sign operator. The single equal sign is used for assignment. So I wanted to set the value of a variable, user value, to the value 1, then we would have used a single equal sign instead of the double equal sign, and we wouldn't have put it in the condition area of this if statement. However, the double equal sign says that we want to determine whether this expression is true or false. So if that expression, user value equal literal string 1, if that expression evaluates to true, then perform the code block that's immediately following that if statement. If that expression evaluates to false, then the code block beneath the if statement is completely ignored. All right, so let's go ahead and see this in action. I'm going to hit the start button on my keyboard, and I get the question, would you prefer what is behind door number 1, 2, or 3? Tell you what, let's start off by typing the word something and hit enter, and you can see that the application exits immediately. Why do you suppose that is? Well, the problem is that we only handled one possible outcome with our if statement. So if we don't enter that code block, the if statement code block, then the application is free to exit, moving outside of the main method's code block. So let's go ahead and see what happens though when we hit the number 1 on our keyboard and then hit the enter key. It says, hey, you want a new car, and then we hit enter key again, and it ends. All right, it's probably the lamest game ever created, but hopefully you can see the purpose of the if statement in all of this. So I'll tell you what, let's expand our application and learn more about the if statement. So we're going to revisit all of this code that we wrote, and actually we're going to write a bunch more. So here, let's keep moving on like this. Okay, so let's take a note of a few things here. First of all, you can see that in line number 26 and line number 31, I use the else if statement, which allows us to evaluate additional conditions. So while we could simply use individual if statements instead of using the else if, this keeps everything together and makes it obvious that we're still evaluating the same types of conditions. And then finally, in line number 36, I use the else statement by itself. If no other conditions are satisfied, then execute that block of code, all right? So this time, whenever you start the application and you enter a value other than the number 1, you should see a different message. So I'm going to test the 2 condition, hey, you want a new boat. I'm going to run it again, test the 3 condition, hey, you want a new cat. And then let's go ahead and run this one more time, and I'm going to type just anything in here, something in here. Sorry, we didn't understand, you lose. So that's kind of the catch-all, right? The catch-all code block. All right, but we're not done here. Often, developers want to write concise code. This often improves readability by removing extraneous characters. So developers have learned that if they find themselves writing the same code more than once, it might be a good idea to take a look at that code and see how they can refactor the code. So refactoring is a more advanced topic. Entire books have been written about improving the quality of your code by applying some rules designed to improve its quality. And some of these refactorings even have names, and people will memorize these, and there are tools that are sold that help you do them automatically and things like that. But in this case, we can see that each code block in our if statement has essentially the same commands. It has a console.writeLine and a console.readLine. So we simply need to extract what's common and focus on what's different in each of these code blocks. So let's rewrite this code now to simplify and make this code block a little bit more compact. All right, so I'm going to do the following here. Start here and go string message. And then okay, so you can see what I did here. Let's move up here. In fact, I'm actually going to take this one step further. I'm going to get rid of all these code blocks. I'm going to say, oh my, what is he doing? I'll explain in a minute. Phew. Look how I compacted that. Awesome. All right, so I started off in line number 22 by creating a new variable called message and setting it to an empty string. So secondly, each code block sets the value of message accordingly. All I'm doing here is just, depending on which condition is true, I just changed the value of message. And then finally, in line number 33, I call console.writeLine and I display whatever is the value inside the variable message. And then obviously call the console.readLine to pause the execution. Let's see if it works still. Type in 3, awesome. Okay, great. Now, one other item that might be slightly confusing, in this case I used the shortened form of the if statement and excluded the opening and closing curly braces. I deleted them out and said, what's he doing? You can only omit the curly braces when the if statement is followed by a single line of code. This is merely a shortcut. We could have just as easily surrounded that in an opening and closing curly brace like I originally had here, just like this, and it would have worked exactly the same. But by making these changes, I've significantly cleaned up the if statement and made it clearer what this code is trying to accomplish, at least in my opinion. So of course, when I change the code, I want to test to make sure my application still works. So in this case, when I run it, we already tested this once, it seems to work just fine. I strongly recommend that you avoid writing long passages of code before you test your work. So keep your additions small and tidy and then test them often before moving on. If you only write a few lines of code before testing, then you're more likely to remember what you just introduced to the application that now may throw an exception. You go back and fix, I only changed 4 lines of code. It has to be one of these 4 things, right? Just makes it a little bit easier. All right, so you need to memorize this whole if, else if, and else syntax, including the evaluation operator, the double equal sign, and when to use the curly braces and when not to use the curly braces. It's simply too fundamental to constantly be looking at a cheat sheet or on MSDN. It needs to be as familiar to you as typing any combination of words that make up a sentence in the English language. You'll only memorize, however, if you actually get your hands dirty and type in these examples like I'm doing. And you have to, and you need to do that often with these examples and with other examples that you find around the internet. So before we conclude this lesson, let's take a quick look one more time at another way to perform this if, then, else type of syntax. So whenever you need just a simple either or comparison, the conditional operator may work well and fit our write concise code advice. So let's do this, comment out everything we've done up to this point. Let's make this real quick and easy here. In fact, let's do that. Comment it all out. Great. All right, and I'm going to type the following. And actually, I want to keep this. All right. So console.writeLine, would you prefer what's behind door number 1, 2, or 3? We're going to grab the user value, and then we're going to evaluate user value. If it's equal to 1, if that's true, then set message equal to boat. If, however, it's anything else except this, so if this is false, then set message equal to strand of lint. And then you can see that we have some really interesting syntax here at the very bottom. It uses the string replacement syntax, and we'll be using this quite a bit. This is an optional version of the console.writeLine. If you hover over, you can see that there are 18 different or 19 different versions. Off to the right-hand side there, it says plus 18 overloads. We'll talk about what an overload method is later, but there's several different versions, and this is one of the versions of the WriteLine method that we can use. We can pass in a number of different values that can be replaced inside of the literal string by using this open and close curly brace syntax with the 0. We could do another one like this and put user value there to add a second value to replace or insert inside of our string. So let's see what this looks like. And I'm just going to type in 1. You want a boat and then 1. Okay, and so boat came from this line of code. The number 1 comes from whatever I typed in, and it gets replaced here. So let's go ahead and remove this and remove that. So just be familiar with this string replacement syntax. It's a 0-based number that you can add to your literal string in a console.writeLine and insert values into. Okay, and this replacement syntax has some special features that we're going to see in an upcoming lesson as well that allows you to format things like currency and dates and things of that nature that you might send to it here as an argument to this literal string. Okay? Okay, so the key idea from this lesson is how to write logic using 2 C# constructs, and there's others as well. I just wanted to keep this simple to start off with. So you use the if statement to evaluate conditions and add to its utility by adding else if statements and an else statement to account for additional scenarios that you need to handle inside of your code. And then secondly, we just looked at this conditional operator for simple scenarios like we just demonstrated, where something's true or false, and based on true or false, we're going to either assign a variable this value or that value. Okay? We also talked about that string formatting syntax, the string replacement syntax. And as I alluded to a moment ago, there's actually another way to write conditional logic, the C# switch statement, and we're going to cover that in a much later lesson in the series. All right, so we'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, I want to spend a bit more time talking about some smaller syntax elements in the C# language that you need to master to understand how a properly formed line of code is constructed. So in the previous lesson, I said something to the effect that just like you use a period at the end of a properly formed English sentence, you use a semicolon in C# to denote that you want to end a complete thought. And I may have even briefly referred to C# syntax as having nouns and verbs and so forth to extend that analogy. Well, I want to elaborate on that just a little bit here and clarify what I meant in this lesson. So let's start off by describing the basic building blocks. Statements are complete thoughts in C#, or complete sentences. Statements are made up of one or more expressions, and expressions are made up of operators and operands. And we've seen several expressions already. We've seen expressions like the ones on this slide that as we've been working through these lessons. Console.writeLine hello world. If user value equals 1, y equals x plus 7, my first string equals Bob, and there are many others. But each of these expressions have two things in common. They consist of operators and operands. Operands are things like objects, or for now, just think of classes like the console class. They're also things like variables or literal strings, and I suppose you could call these our nouns. Operators are things like the plus operator, which when working with numeric data was the addition operator. It could also be used with strings for the concatenation operator, and I suppose you could call them the verbs. And so there's the equal sign, which we already noted means variable assignment. Also, whenever we worked with the if statement, we noted that the double equal sign tests for equality. So there are other operators that we've seen, but you may not think of typically as an operator. For example, the opening and closing parentheses is the operator for method invocation. Like whenever you see this line of code, console.writeLine open and close parentheses, we are actually invoking the readline method through the use of the opening and closing parentheses. So what happens if you leave those off, if you ignore those parentheses? Well, then it changes the meaning of the code, and the C# compiler may not understand and will possibly raise a compilation exception. Another operator that you may not think of as an operator is that little dot or the period, which is the member access operator. Using the console object, we were able to access the members, or in other words, the methods that belong to the console class by using the dot operator. As we learn more about classes and objects and object-oriented programming, we'll be using the dot operator a lot. I'm going to have a whole lot more to say about object-oriented programming in a couple lessons from now, but in these lessons the key idea is that the dot operator is in fact an operator. And there are quite a few operators, but as you start out you probably need to know a couple of them. So let's focus on just a few that I think you're going to use 90% of the time. And these will come rapid fire, but we're also going to add them to our memorization work, and hopefully you'll recall these whenever you need them. If not, you can refer back to this lesson for a quick reminder. So I've created a nonsensical project called Operators, Expressions, and Statements, and I call it nonsensical because it really doesn't do anything. You can download this if you'd like from wherever you're currently watching the video or where you originally downloaded it from. It really just demonstrates the use of the various operators. So at the very beginning here, I do want to point out something interesting that I've done that I haven't done up to this point, and that's when I declared the variables that I'm going to use throughout this main method. I did it like so: int x, y, a, and b, separating them each with commas. So this is just a real quick, easy way to create or declare several variables all in one line of code. I typically don't recommend that you do this, but you can, and you might see examples of this in use. We've already seen the assignment operator, the single equal sign. There are other mathematical operators, obviously the addition operator we're already familiar with, but then there's also the subtraction operator, which you would guess would be the minus sign or the single dash on your keyboard. The asterisk is the multiplication operator. The forward slash between two numeric values is the division operator. And then there are many operators used to evaluate values. We already looked at the two equal signs next to each other to evaluate for equality, but there's also the greater than operator, so make sure that x is greater than y. If so, then execute that block of code. There's the less than operator, which is the arrow pointed in the opposite direction. The greater or equal to operator, the less than or equal to operator. So things that you would come to expect if you've taken any kind of simple math class. Well, they're in use here in C# as well. And then there are conditional operators that can be used to enhance an evaluation, so you can kind of put them together. So for example, there's the conditional and operator. So I can use the double ampersand to say it must pass this condition and must pass this condition. If both of those are true, then execute this block of code. There's also below it, you can see the conditional or operator, which is just two single pipes. On my keyboard, that pipe symbol is over the backslash character on my keyboard above the enter key, but somewhere in that vicinity. And so that will say basically if x is greater than y or a is greater than b, then go ahead and execute this block of code. All right. And we've already taken a look at that inline conditional operator in a previous lesson. We saw that we could assign a value to message based on this condition. Is X in fact equal to 1? If it is, and you can see here is the question mark, if that's true, then set message to car, otherwise set the variable message to the value boat. And then finally, the member access and method invocation operators like you see there. Okay, and again, this is not an exhaustive list, but you probably should memorize the ones in this little code example at a minimum. You really need these about, like I said, 90, maybe as much as 99% of the time. You can expand your vocabulary of other operators and keywords and so forth over time. All right, so in each of these cases that we just saw, an expression is made up of a combination of operands like literal strings, variables, objects like the console class, and so on, and operators like those we just looked at, the addition operators, string concatenation operators, conditional and or operators, and so on. And so you use expressions to form statements, which are how the actions or the instructions of an application are expressed. And we've already seen several great examples of statements so far when we've written our applications. And you might say, well, where have I seen a statement before? Well, think about the projects that we created up to this point. For example, there are declaration statements like int x. In that case, that's all it takes to make a complete thought in C#. And then there are expression statements like my string equals then my first name plus my last name. Again, a complete thought. We're adding two values together and taking the new value and setting it as the value of my string. Or something like this, some value equals 3 times x divided by 100. In this case, notice that the parentheses operator is used for the order of operations, just like you would in any mathematical formula. So first, take 3 times x and then divide by 100. All right, so in each of these cases, the expression is evaluated and then assigned. And there are decision statements. We've already seen one example so far. If x is greater than y, then z equals Bob. And this might look a little foreign at first, but if I separate it out into individual lines and wrap some curly braces around it, you might recognize it in this form. Basically the exact same thing. So all we needed to do in this case was to add the curly braces, but essentially the same line of code. Again, new lines in white space don't matter to the compiler. They're just there for our own readability. And there are iteration statements, which I'm going to show you in a later lesson, and there are a couple of others. But basically, these are the syntax rules of C#. Now, why am I telling you all of this? Because the syntax rules matter. For example, you can't just do this, x plus y, and expect it to work. The C# compiler will look at you and say, what are you trying to do? Have you lost your mind? What do you want me to do with this? In situations like this, the IDE can actually catch these syntactical mistakes as compilation errors even before you attempt to compile or run the application. So we would expect this to give us a red squiggly line. And now we can hover our mouse cursor over and it'll say only assignment, call, increment, decrement, await, and new object expressions can be used as a statement. Okay, so again, that is developer speak for basically saying that you don't have a properly formed statement. It doesn't have the right set of expressions and filled with operators and operands. We're not really doing anything here. All right, there's no assignment going on. All right, so for beginners, understand that there's a proper syntax, just like there's proper grammar in the English language, and just understanding that is a big step to solving your own problems whenever you're phrasing C# instructions that the C# compiler will accept. Okay, so let's recap the things that we talked about in this lesson. First of all, statements are complete instructions in C#, and they consist of expressions. A statement is like a sentence in the English language, and the expressions are things like nouns and verbs. Actually, expressions are made up of operands and operators. So an operand is a thing, something like an object or a variable or a literal string. For now, just think of objects like the console class. That's an object. I suppose you could call these our nouns. Operators are like verbs. They act on the operands. And we spend a lot of time looking at examples of different operators that we'll come in contact with. And we've already been using these operators for all sorts of purposes up until now. Even if we didn't identify them as operators, we were still using them. And you have to memorize the operators. To start off, you might use a cheat sheet. However, in most cases, I think you'll be able to just think, what do I need to do here? And then, and think and reason your way through the operators that you'll need in order to complete that statement, that complete thought in C#. So you might be thinking to yourself, next I need to add these two variables together and set them equal to this other variable. So I'm going to need the addition operator and the equality operator. I probably need a plus and an equal sign, right? Or something like, I need to evaluate whether this variable is greater than 100. I wonder if I can use if I could just use the greater than symbol, or if I need the greater than equal to symbol, just like I used in my math class. Right. So here again, you would be able to just reason your way through, think through what is the logical type of operator on my keyboard that I could use to do something, and generally it will work. And so operands are like variables and classes and strings, and they're easy to remember the names of because you create those names yourself. You have to memorize the operators because they are the way that you do something meaningful with your operands that you define the names of. And so I just wanted to make those distinctions and help you get a firmer grasp on the language, the fact that there is a syntax, and there are syntax rules, just like there are syntax rules in the English language, other languages of the world, and they do dictate what's possible and why you get error messages sometimes when you type in an improperly formed line of code. Okay, so great. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, we're going to focus on iteration statements. We're actually going to focus on a single iteration statement called a for loop. Sometimes you're going to need to loop through or iterate through a sequence of items and perform a series of checks until you find a successful match. Actually, you're going to do this a lot more than you might anticipate. So while it might not seem all that useful at first, trust me, you're going to need this in your toolbox. So what I want to do is start up with a new project. We're going to call this for iterations. So using one of the techniques that we saw earlier, we want to make sure that we create a new project. The new project dialog pops up. We're going to make sure that we're in the C# templates, choosing the console application template, and we want to call this for iterations. And click OK. Okay, so the syntax itself that we're going to write here in just a moment is probably the most cryptic of anything that you've seen yet. If I had to admit it, sometimes I get things a little bit mixed up myself. So later, after we've struggled through writing this all by hand, I'm going to share with you the little secret that I use to cheat my way into writing it correctly every single time. So having warned you about the complexity of this syntax, I'm still betting that you could figure it out and read it even before we run the application and I take the time to explain what each little bit is doing. So let me do this. I'm going to be quiet, I'm going to write the code, and then we'll come back and delve into it a little bit more. So let's get started with this. Alrighty, what do you think that this does? Well, first of all, I'm betting that the most difficult part was the little pieces here at the very top in line number 13. So let's break them up. First of all, if we were to write these as 3 different statements, they might make a little bit more sense. So the first one, clearly, we're creating a variable called I, and we're initializing that variable to the value 0. And then next we're going to, in this middle part, we're going to evaluate and ask, is it true that I is less than 10? All right, so we'll come back to that in just a moment. Finally, there's this strange operator that's next to the letter I, and we didn't talk about that in an earlier lesson. That's actually the increment operator. So it's basically the equivalent of writing I equals I plus 1. You're just basically incrementing the value of I by 1 every time that that statement is executed. All right. So we're instructing C# to execute this block of code beneath the for statement until the condition I less than 10 is no longer true. So each time you finish iterating through the block of code, increment I by 1 and try it again, and then try it again, and then try it again. And when I is no longer less than 10, when that's no longer true, then don't execute this block of code. Instead, skip it and move on to the next line, which in this case is just our console.read line. So let's see what happens whenever we run this application. We get a progression of numbers from 0 to 9, and then we hit our console.read line. We'll hit the enter key on our keyboard to end it. So we get a listing of 0 through 9. We keep iterating through that block of code until I is no longer less than 10. And then we continue on to the console read line. Great. Okay, so let's create a slightly more advanced version of this. Let's comment out this line of code right here. And I want to add the following lines of code. Okay, so what did I do here? Well, I simply added a very, very simple if statement. What do you suppose it's going to do when I run it this time? Well, we're inserting the if statement to circumvent the natural flow of the code. Not only will we print a message to screen once I is equal to 7, but we're also going to use the break statement below it in line number 20 to break out of code. So I equals 8, I equals 9, I equals 10 will not be evaluated. We will break out of that for statement completely. So what I want to do, let's go ahead and run it real quick and you'll see that it works. And it's not very exciting because all we see is the message found 7. To really see this at work, what we need to do is set a breakpoint and then watch how the code is actually executing behind the scenes. So we're going to witness the flow of code as it executes, and we're also going to exercise some of the debugging skills that we learned earlier in this series, as well as the lesson specifically about debugging that you may have watched about Visual Studio. So what I want to do is set a breakpoint on if I is equal to 7, and then I want to start debugging. And so when the execution of code reaches line 17, the execution will halt, and it will allow us to take control and to inspect values. So here's what I want to do is hover my mouse cursor over I, and you can see here that the little, and this is the first time that we've reached this breakpoint, so the value of I is 0. So I want to kind of slowly hover my mouse cursor over that little window, and I want to get to that little thumbtack, and I'm going to tack it down, and when I do, notice that it puts a little window off to the right hand side, and now I can see that window each time I step through my code. So I'm going to go ahead and step over and then come back through, and now you can see that I equals 1. And now watch this time when I go through it. I'm going to execute that line of code. Notice what happens. Well, hold on, I made a mistake. There we go. Okay, notice that whenever we hit this iteration, I that I incremented from 2 to 3, and now notice that the little window, the I and the 3 are in red. So visually you can see what just changed in the previous line of code, what variable values changed with that little Q that the value turned red. Not only here in this little window, but then also in the locals window as well. You can see I turned to 3, and now it is red, and when we execute one more line of code, it's no longer red, it's just black because the previous line of code did not change anything else. All right? So what I want to do is just hit the continue button until I see that I equals 7 on my breakpoint. All right, so it's 4, 5, 6, and then one more time, that'll put it at 7. And now I want to take control of the debugging experience again. So I use the continue button to go ahead and do all of the increments, the checks, and so on until I got to the point where I wanted to stop and take control and watch as I step into the if statement, print found 7 to screen, and then hit break. Now this is the important part. Let's watch what happens whenever we hit the break statement. Notice it jumps out immediately from break to console.readLine. You might say, well, what's the significance of that? Well, it didn't touch these other lines of code that are merely the ending curly braces, but that just shows you how it will jump outside of the iteration statement to the next line of code after the iteration statement. All right, so I'm just going to hit the continue one more time now, and we see the console window found 7, and we'll just go ahead and hit the enter key on the keyboard to finish out that execution. All right, so admittedly, this is a nonsensical example because it really doesn't do anything meaningful, right? It's just a pithy example to demonstrate how to use the use of and the flow of the for statement, and how to interrupt the flow by adding a conditional statement and the break keyword. Great. Okay, now I promised you a little cheat at the very beginning of the lesson. So instead of having to memorize this syntax for int I equals 0 or whatever the number is, I less than 10, I plus plus, and so on, you can use this little feature of Visual Studio called code snippets. We're going to use code snippets throughout this entire series to save keystrokes and to write code more accurately. And so what I'm going to do is go below all of this here, and I'm going to just type in the word for, and then I'm going to hit tab twice on my keyboard, so the tab key twice. And notice that Visual Studio automatically inserts this entire structure for the for iteration statement. And also notice that it puts my mouse cursor and highlights the letter I. So what I can do now is replace the variable I with a variable name I want to use. So I'm going to type in my value, all right? And everywhere, now when I use the tab key one more time, everywhere the letter I was, it replaced it with the new variable name, my value, and then it goes to the next location where I need to change the value. So I can just type in whatever the length is. So in this case, I'll type in the number 12, or I could get anything that would generate an integer at this point. I could use here. And then when I'm finished, I'll hit the enter key on my keyboard to move inside of the curly braces to the first line of code where I can begin typing the code that I want to create. So in this case, console.writeLine my value, and then obviously we'll get the expectation, what we expect here. Let's just go ahead and continue. I'll get rid of the breakpoint. Okay, so after it found 7, it went ahead and iterated from 0 to 11 and then exited out. Great. Okay, so in this lesson, we learned, first of all, how to use the for statement to iterate through a code block a number of times until a particular set of criteria are satisfied. And we demonstrated a simple condition in our code examples, but we can expand on this, and we will expand on this in future lessons. We also learned how to combine an if statement inside of the for iteration statement to add some logic to evaluate certain conditions. And then we learned how to use the break keyword in order to jump out of a code block, jump out of the for iteration code block. We also learned the use of several built-in debugging features in the IDE, like the ability to pin down the little variable so that we can watch it as we continue debugging within our code. The use of the color of the fonts to indicate something just changed. We also learned how to use a code snippet to save keystrokes and to write code more precisely. So that's great. So we're doing awesome. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, we're going to talk about arrays. Now, previously, I compared a variable to a bucket in the computer's memory that holds a value. Now, to extend that analogy a little bit further, you can think of an array as a bucket that contains other buckets, okay? Another way to think of an array is that it's a sequence of data. Now, I hesitate to use the word collection or sequence. Those have a certain connotation. Collections have a definite meaning to .NET developers, but you can think of an array as a grouping or a collection of data. So you declare an array just like you would any other variable, starting with a data type. And then you say how many elements or how many sub buckets, how many buckets you want inside of the bigger bucket, okay? How large of the array you want to hold, or your array to hold or to contain. So you can access then any single item in the array inside of that sequence by using its index, or rather its ordinal position inside of the sequence that you want to access. So what I want to do is create a quick example of an array in action, and we'll visit this example a couple of times. The first time we're going to use kind of the longhand format, and then I want to show you a new shortcut as well. All right, so what I want to do is create a new project. So I'm going to, this time we'll change it up, go File, New Project. Make sure I'm working with C# templates, console application template, and we'll call this Understanding Arrays. Click OK. Okay, now take note that this time I'm going to use the square brackets whenever I work with arrays, not the curly braces. On your keyboard, it would be right below the curly braces, the square brackets. Okay, so here we go. All right, so let's examine the declaration and the assignment of values inside of our array. First of all, you can see in line number 13, we're defining an array of integers. The square brackets are used in the declaration to declare an array of type int called numbers. Then on that same line of code, we're going to define the array of integers, or ints, to have 5 values, or rather 5 elements. Again, using the square brackets to define the number of elements that'll be in our array. So then in lines number 15 through 19, we're going to be setting the individual elements of the array to an integer value. So for example, let's take a look at line number 16. I would verbalize this in one of two or three ways. I would say number sub 1 equals the value 8, or the numbers array at index 1 equals the value 8. Or possibly even the second element of the numbers array is set to the value 8. Okay, so you get the idea. Any of these are acceptable nomenclature to use. It's extremely important to remember that arrays are zero-based, meaning that you count the element of the array starting with 0 as the first element. So the first element is 0, the second element is 1, third element is 2. You've got to remember that. That is the source of so many problems for new developers, and it caught me so many times when I was first getting started writing software. It's just a little bit of confusion up front, but we're going to see what happens if you forget that in just a moment. Also, by the way, whenever we use the square brackets in this capacity, we refer to them as the array or index access operator. It's what we're going to use throughout to access a specific element of the array. All right, so then in line number 21, we're retrieving the value that we placed into a specific element of the array. And in this case, we are going to access position 1, or in other words, the second element, and we're displaying it using a console write line statement. All right, as we learned earlier, the toString is superfluous here. We don't need it because console.writeLine can accept an integer value. It'll perform the implicit data conversion necessary to print the screen. I just wanted to show that we can use the toString method because what's returned from number sub 1, or the second element of the array, is an integer, just like any other integer. There's nothing special about it per se. So we can use or call the toString method, which we know integers have baked into it, okay? So if we run the application, what would we expect to see? Well, the number 8, because it's the second item in the array that we created. Great. All right, so what happens if we add a line of code that references a 6th element like so? Let's go ahead. Equals 42. All right, and let's try to run the application, and whoa, we get the error message. System.index out of range exception occurred in understandingarrays.exe. So let's go ahead and continue this. In other words, the index was outside the bounds of the array. We're trying to stuff 6 items into a variable that was only designed to hold 5 items. So we are outside of the array. It's important to note that you cannot expand or shrink the array once it has been defined. It is immutable, all right? If you need that functionality, there are fancier alternatives to arrays that we're going to look at later in this course called collections. Also, you can declare and initialize the array in a single line of code. So we don't have to dimension the upper boundary of the array because the initialization will define that up front. So let's take a look at how to do that. I'm actually going to code, let's just do that, and we'll do this, and here I'm going to do the following. All right, so in this case, the upper boundary would be 5 because there are 6 items initialized, all right? And so we're able to, again, create a new array of type integer, and instead of declaring how many items there are, we'll just say, I don't care how many items there are. How about I just give you the list and let you figure out how many there are? And then we proceed to give it the list. When we run the application, we'll get the same result because they're still in the same order. 8 is the second value, so it's number sub 1 will get us to the second item in the array, just like before. But you know, we didn't have to take this longhand form in order to initialize it. All right, so let's take this one step further. We can create arrays to hold virtually any data type, not just integers. So let's create an array to store some names. So let me comment this out. I'll go ahead and get rid of, I'll go ahead and get rid of it all. And I'm going to do the following. Okay, and now this time I'm going to do something a little bit more interesting. We used the for iteration statement in the previous lesson. I got another one for you here. Check this out. Great. Okay, so this is virtually identical to the previous work that we've done with integers, but we're simply using string and initializing it with literal strings of names. And instead of using the for iteration statement like we used previously, we're using the for each. It's much simpler, and frankly, I use this much more often because it works so well in this particular scenario. For each simply iterates through the code block once for each element in the array. So for each string inside of the names array, retrieve the value, store it in a new variable that I'm going to call name, a temporary variable called name, of type string, and then execute this line of code. Easy. All right, so let's go ahead and see it in action. We would just anticipate seeing our names, the four names listed from top to bottom, and we do. Great. All right, so now we've seen how we can use for and for each iteration statements to loop through arrays. But back to the topic of arrays, whenever you store data inside of an array, you can perform many different built-in tasks using one of the methods that are available to arrays. So just like integers or ints have built-in superpowers like the toString or the parse method like we saw earlier, arrays have some of their own powers as well. So let's comment this out. And we'll create one more example here. All right. All right, and that's one really, really long line of code, so watch what I'm going to do. All right, one line of code, one string literal, but I broke it up into two pieces and used the plus operator to concatenate it back together, but put it on two different lines, and now I can just stay within a pretty narrow column of code, which I prefer. And it doesn't run off to the right-hand side of the screen. Again, easy for me to read. The indentation level lets me know that it's associated with the line above it. And so it's just something I wanted to demonstrate can be done. And now we'll continue on. That wasn't really the point of this. All right, so here I'm using a new data type called char, which can store a single alphanumeric character as opposed to a string, which can hold an almost infinite number of characters. And then we're defining an array of chars, okay? But first we need to convert our string variable zig, which contains a famous quote from one of my favorite people of all time, Zig Ziglar, into an array of char. So we're going to take one big long string and we're going to chop it up into each individual letter. Each individual letter will be an element of the char array, okay? How do we chop it up and convert it? By using the string has this built-in superpower, this built-in method called toCharArray. So take the full string, chop it up into individual letters. Each letter would be an element of the array and assign it to my new char array, okay? And then what we want to do is we're going to call array.reverse and pass in this char array. What do you think that does? Well, it's going to take each element in the array and reverse its ordinal position, okay? So the first shall be last and the last shall be first, if you will. And then we're going to use the for each iteration statement to iterate through each char in the char array. And since I only need one line of code, I didn't need to use those curly braces to define a code block. It just has one line, okay? And then also, I want to make one small change here. Instead of using right line, because I don't want each of those on a separate line, I want them to line up next to each other, I'm going to get rid of the line. So I'm just going to use the right method this time so we can see the difference between right line and right, okay? We don't want a line break in between each character, fundamentally. And so now when we run the application, we can see if we're successful, that it prints out Zig Ziglar's famous quote backwards. You can get what you want out of life if you help enough other people get what they want. Awesome. Let's go ahead and end that. Okay, so in this lesson we were primarily concerned about arrays, and we learned that arrays are basically a means of storing groups of data like numbers or strings or even individual characters. And along the way you learned about a few other concepts and techniques. First of all, you declare arrays by defining the data type and adding a pair of opening and closing square brackets. You then can either declare the size of the array like we did at the very beginning here, like that, or we can just give it the actual items that will be in the array in order to initialize its size and assign its values, all right? And so then you use square brackets to access individual elements of the array, either to assign a value or to retrieve a value out of the array. And remember, we said that arrays are always zero-based, and attempting to access an array element outside of that boundary, like we did here, outside of the boundary of the array's length, or rather the number of elements contained inside of the array, will cause an exception to be thrown. We're trying to shove too much data into the bucket, so to speak. All right? And you know, we didn't do this, but we can use the length property to find out just how many elements are inside of a given array. So let me do this real quick here. Just have a little fun. I'm going off the script a little bit because I didn't show this originally. So say I wanted to find out how many items are in my numbers array. I can print that out to screen by using the array's length property, which will give me the number of items in the array. So let me comment this out too. And we would expect to see how many elements? Pretty sure 5, right? Yep, 5. Great. Okay, moving on. If you prefer, you can use the for each iteration statement like we did here to iterate through each element in the array, which also extracts the value of each element into its own variable like we did here. Okay. We can also call the array.reverse method to reverse the order of all the elements inside of a given array, like we did there. It allows us to basically switch the ordinal position from first to last and last to first. Okay, so at any rate, hopefully this was pretty enlightening. Arrays are great, collections are better, and we'll talk about those much later, but we'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, I want to show you how to create simple methods, which allows us to split up our C# code into multiple code blocks. Now, simply put, a method is a block of code that's given a name so that you can call that name, you can execute that block of code from somewhere else. It's one of the basic building blocks for creating larger applications. We'll look at other building blocks a little bit later on, like classes and object-oriented programming a little bit later. Okay, so why would you ever want to split your code up into multiple methods? Actually, there's many reasons why. First of all, it's a good idea to never write the same code twice. Cut and paste is the sworn enemy of the software developer. It's a necessary evil at best, and at worst it will steal your soul, okay? You should stop yourself dead in your tracks whenever you realize that you need the same code you wrote up here in a second spot and think, whoa, wait a second, my tendency would be to copy and paste it, but I know better than that. I need to create a method instead and then call that method from both of those places. And so when you write a method and you call that method from each place where you need that functionality, you are limiting the amount of code that you need to change should a new requirement come up or you need to fix a bug or whatever the case might be. All right. So we've already worked with methods quite a few times already in this series. For example, we work with the main method every single time that we've written a new application. And that's just a very special kind of method that's triggered to execute when an application first starts up. We've also been calling or using methods that were written by Microsoft. Every single time that we called the write line method or the read line method or the write method or a bunch of others, okay? So let's just exercise this idea. Let's create some of our own methods and learn what we can do with methods and get a good feel for it. So I'm going to actually use a new technique to create a new project. There's this little button on the toolbar by default, unless you changed your buttons on your toolbar, that will allow you to create a new project. So there's a third way to do it. And make sure you're in the Visual C# templates. Make sure that you have selected the console application template. This time we're going to create a helper method project. So helper methods, and then click OK. First, I'll create some space beneath the static void main method. Notice that I'm not inside of static void main. I'm going to start by creating a method, kind of a brother or sister to the main method. Below it, inside of class program. Okay, and here we go. All right, now I'm going to call that method. Notice that IntelliSense did not pop up for me. I'll tell you why that is in a minute. Okay, so as you can see, the example is flawed. We get this red squiggly line. The error says an object reference is required for the non-static field method or property super secret formula. Okay, so I'll fix that issue in just a moment, but let me first explain what I intend for the code to do. So I want to create a custom method and then trigger, or rather call that method in my C# code. It's important to be careful where you write that code, as you see on my screen. As I pointed out and try to make you aware of it right away, you should position the caret before the final two ending curly braces after the ending curly brace for our static void main. I'm going to explain why that's important in an upcoming lesson, but for now just know that you'll get an error if you attempt to run this application. If you were to put that method we created anywhere else in code except inside the program class, okay? So make sure it's in the correct position. So let's deconstruct the code that you see here on my screen. On line number 18, let's start with the word private. It means that it can only be called from within this class. So it's a method, and it can be called, but it can only be called by other methods inside of this class. And that's opposed to public, which will allow it to be called from outside the class. Now, we're encroaching on a discussion of object-oriented programming. I really don't want to do that. That'll take us off in a whole other direction. For now, let's just stick with the keyword private as we create new helper methods. Then the next part, as you can see next to it, is the word string. We know that string is the data type. It's actually the return type for this method. So in other words, when I call this method, I can be guaranteed that it will return back to me a data type of string. All right, more about this in a moment. The next part is the name itself, which I named super secret formula. I could have called it anything. And in the next step, we're going to talk about how to execute this method by using the name that we just gave it. Now notice that I use a lowercase s in the word super, but every other word is capitalized. Again, this is a naming convention. We've seen this naming convention before. And a naming convention is simply just a way of writing code that gives a clue to everybody who follows that same naming convention what's going on here. This form of capitalization is called, do you remember? Camel case, right. And it's called camel case because it looks like it has humps like a camel, because every other word after the first word will be lowercase, every other word will have a capital letter. So capital S in secret, capital F in formula, right? And you use camel case to indicate that a method or a variable is private in scope. Again, I don't want to talk about what private and public mean. just follow this whenever you name your helper methods that are private in scope, and you'll be in good shape, okay? So then let's see, in line number, looks like 21, I use the keyword return, and this is the command to deliver the results back out to the method to call the code, to the code that actually called it. So in this case, we're returning back a literal string, hello world. Now, admittedly, this is a very simple example. Ideally, we would have really done some super secret formulas, some really cool stuff in this method. I wanted to keep it simple. But imagine having, a dozen lines, 2 dozen lines that perform some calculation. I have a friend I'm doing some work with that actually a client who is creating application for finance, and he has dozens and hundreds of methods that do different financial calculations. Okay, so that would be a good example of being able to encapsulate or put that logic in one spot and then be able to call it from a lot of different places. In this case, it's a little bit puny. We're only returning a string. Okay, enough apologies. So again, a method is just a code block with a name, and we're going to use that name, super secret formula, to tell that code block to execute. And since this method returns a string, we would expect one of the last lines of code to use the return keyword. In this case, the return keyword sends back the literal string hello world to the code that called this method by name. So back in the main event, we're going to call our new helper method. And when we do, we would expect to receive that string hello world and set that my value variable to the value hello world. That's returned by calling super secret formula, right? So as you can see, I'm declaring and initializing that value or that variable in one line of code. So line 14, let's see, line 14 then simply takes that value from the variable, my value, and passes it to the console.writeLine method. But as you can see, as I mentioned before, we're simply not finished because the red squiggly line prompts us to look at the error list. I guess we can bring that up by going here, like so, or I think we can just view it from the view menu, but we'll just find it this way. An object reference is required for the non-static field method or property helper method.program that super secret formula. Okay, so what is the problem? Admittedly, that error message isn't very beginner friendly. Rather than explain the problem and the solution at this very moment, what I'm going to do is just go back to my code. Let's get rid of the error. Okay, and what I'll do is just add the keyword static here. All right, so I'm going to explain the static keyword and its importance later in the series of lessons. I'm afraid it would be lost on you at this moment. We'll talk about classes and creating objects and creating instances versus static a little bit later. All right, so now if we start the application, we should see the phrase hello world pop open in our console window. All right, the example again is super simple, but the concept is powerful. We can offload certain operations to other methods to organize and reuse our code or our logic. Furthermore, these helper methods can in turn call other helper methods and so on. Again, this example is simple, but the concept behind it is very powerful, and it's a crucial step towards building more complex applications. All right, so let's improve our helper method to make it a little bit more flexible and useful by allowing it to accept an input parameter. So when we create our methods, we can choose to accept 0 input parameters or 1 or many input parameters. And then in the body of the method, we would use the values that are passed into the input parameters to do something meaningful. In our case, again, we're going to keep it simple because this is a short video. We'll just accept a single input parameter, and then we'll use that to append to the end of that literal string hello world. So it'll be real simple, and we'll just do this. In fact, I'm not even going to comment out this first one. I'm just going to go private static string super secret formula. And I'm going to create an input parameter called name. It'll be of type string. And here I'm going to return, oh, what is this? String.format hello. And then we've seen this string replacement code before. That shouldn't be new. Great. now let's go up here to where we call super secret formula, and I'm going to pass in the literal string world. Okay, back here, exclamation mark there. Okay, so hopefully you can see what this is going to do. It accepts an input parameter of type name, and we're going to pass the string world into our super secret formula method so that it can be combined with the word hello and the exclamation mark and returned back and assigned to my value. Okay? Now it's a little convoluted, and again, this is a really absurd example, but I just wanted to show you how you can create an input or define an input parameter and then send data into the input parameter. All right. And admittedly, I got pretty fancy here with this replacement stuff and with the string.format and all that business. I could have simply done return hello plus name semicolon. All right, just a different way to do things. We'll look at that string.format a little bit later. All right, so let's go ahead and run the application, and we can see we get the results hello world again. All right, so furthermore, we can reuse this method anytime that we need this functionality. In this mundane example, I doubt we'd really ever find much benefit from it. But again, the concept is that we can send new inputs and reuse the functionality of that method throughout the application. So let's just to prove this, let's just go ahead and show that. Now, if I wanted to, in another part of my code, say hello sunshine, now I don't have to rewrite all of this code that I wrote, just one line, but what if it was a dozen lines or 24 lines of code? I wouldn't need to repeat it. I can just call super secret formula, pass in a new input variable, an input parameter to change or modify what happens in the body of that method. Okay, great. All right, so now to push this idea forward, you can see that we have created two methods with exactly the same name. And Visual Studio didn't complain about that. We didn't get a compilation error. And furthermore, we were able to use both versions. So for example, now if I just wanted to use the first version, I would just remove the input parameter to see hello world, and then I can add sunshine back in to use the second version of the method. All right? And the reason is because when I added a second method with the same name but a different method signature, I created an overloaded version of the method. So simply put, you can create multiple versions of the same method, each accepting a different number and or a different data type of parameters. As long as either the data type or the number of parameters is different, they can coexist. What you can't do is this. In this case, we will get an error when we try to call it. This call is ambiguous between the following methods. Why? Because it doesn't know which one is different. But if I were to do this instead, because the data type is different, it would be just fine. Okay, so that's what I mean by the method signature. The name, the number, and the data type of the input parameters have to be different in order to create overloaded versions of the same method. So as you can see, let's go here, console.writeLine. Now watch, open it up. There are 19 different overloaded versions of console.writeLine, and as I use the down arrow on my keyboard, you can see they take in different things, like it'll take a Boolean, which is another data type, true, false, the char, which as we know is just a single character. It'll take an array of chars, a decimal, which is a data type, which is like an integer, except it has values after the decimal place. Similar, double, similar with float. It'll take an int and a string and so on. All right, so there are all these different overloaded versions of the WriteLine method that we've been relying on up to this point. All right, so now you can remember just one method name and search through the different ways that it can be called to find the most convenient version of the method based on the data that you have available to you at the time, based on what the output you want is from that given method. So And as you can see, the internal implementation of that method can be different in each case. Before I wrap up this lesson, we talked about methods that return a value. We define the data type of the return value in the method signature. So for example, we promise to return a string from our super secret formula method. But what if we don't want to return anything from the method? What if we just want to perform some action and that action doesn't need to send back a return value? Well, in that case, we would use the keyword void. When a method returns void, we're saying the method doesn't return anything. It does its work and quietly exits, and the code that calls it will just continue executing. So we have an example of this in the static void main. Main doesn't need to return anything because it's the entry point of the entire application. So typically, I create void methods when I want to delegate some responsibility and I expect it to work unless there's some problem, in which case I would expect an exception to be thrown. However, we're going to talk about that scenario much later in this series of lessons. For now, void means don't expect me to return anything to you. Okay, so the key takeaway in this lesson is the use of methods. And we're going to be using methods often in the coming videos for various purposes, and I just wanted to make sure that you have some exposure and explanation to them as we get started. As I said at the outset, a method is just one building block. We need to understand a little bit about classes as well, which you can think of as named blocks of code that are containers for our methods and some other stuff. And we'll talk about this at length in an upcoming lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps for the world's best companies as quickly as possible. In this lesson, I'm going to take another roundabout way of showing you another iteration statement, the while statement. And to demonstrate this, we're going to actually open up a text file off the hard drive and read each line of the text file, displaying it in a console window, of course, until we get to the end of the file. So beyond the specifics of using a while iteration statement and reading data from a text file, there are several key ideas, and we're going to cover things like how to add other files to our project, how to work with null values, how to change the properties of things using that properties window, and a lot more. All right, so let's get started by creating a new project. Make sure Visual C# console application, and we're going to call this project the read text file while project. Click OK. And the first thing that we want to do is start with the Solution Explorer, and what I want to do in with the project selected, I'm going to right click the project and select add new item, and there's several ways to add a new item to your project. This is just one that I prefer. Right click on the project file, on the project name, select add new item. That'll bring up the add new item dialog, and what I want to do is scroll down to near the bottom where we have a text file option, and I want to change the default name from text file 1 to simply values.txt, and then click the add button. And then notice what happens. We get a new file in our project, and the values.txt file is open in the main area. So now I have two tabs open, the program.cs file where we've been doing all of our work up to this point, and then the values.txt file. And in this file, what I want to do is put some numbers or just some values in each line. So 4, 8, 15, 16, 23, and 42. All right, and I'm going to click Save All. So the next thing I want to do is open up the program.cs, and recall if it's not already open in a tab, you can just double click it and it will open it up in the main area. And what I want to do is type in some code, and so make sure you follow along with me. Okay, so as you see on my screen, I have a problem. The code will not run. We can see that the stream reader has a red squiggly line indicating that we're going to be unable to compile this application until we fix it. The problem is that C# cannot resolve the word stream reader. In other words, it has no idea what we're referring to here. The problem is that stream reader doesn't live in any of the default namespaces in our project. In fact, it lives in a namespace called system.io, and we don't currently have that. We haven't told our application where to look for this class name of stream reader. We haven't told it to look in a namespace called system.io. And I'll explain what namespaces are in a future lesson, but for now just know that we're going to need to fix this before we can continue. So before we fix this, let me explain what each line of code is trying to do. So in line number 13, we're using the stream reader object to open up the values.txt file. And we create a new variable called myReader of type stream reader. So a stream reader kind of works like a straw. Little by little, line by line, it will suck in data out of the values.txt file into our program where it can be processed, or in our case, simply print screen. So then in line 14, we declare an empty string called line, the line variable. And then beginning in line 16, we'll iterate through that code block defined between line 16 and 20. We'll iterate through it as long as that line variable is not set to null. Now, null is a difficult concept for beginners to remember. A null value means that it has an unknown or indeterminate value. However, an empty string is not unknown and it's not indeterminable. So these are not the same, and therefore we would expect line number 15 to continue to execute until we reach the very end of the values.txt file, at which point our line variable will be set to null and we will exit out of the while loop. All right. So the while iteration statement will continue to execute that block of code until the statement inside of it, its open and close parentheses, evaluates to false. Unlike the for and the for each, what happens inside of the code block directly affects the flow of the code in the while iteration statement. So if you recall, in the for each, we just said once for every item in our array. Or with the for iteration statement, we had a preset number of times, whether it be 10 or 12 or the length of an array. We would go through a preset number of times, but not so with a while statement. What happens inside the while statement, in this case the read line, will dictate whether we continue another loop or whether we exit out. All right? All right, so then in line number 18, we set our line variable to the value that's contained in one entire line of the values.txt file. So since we typed a single value in each line, 4, 8, 15, 16, etc., each of those values are retrieved using the stream reader's readline method and then stored into the line variable. So once again, we'll ensure that the line is not null. If it is, that means we've reached the end of the file and there's no value to process. As we've alluded to a couple of times already, the while code block will continue to execute until readline retrieves the end of the file and sets the line to a null value. So then after the while statement, we need to close the file, and failure to close the file can leave a reference to the file open and prevent other users or application processes from accessing that file, at least until the computer is rebooted or some similar drastic action is performed. And then line number 22 accomplishes this by simply calling the stream reader's close method, which says close off all ties that you have to any files. It'll release its hold on the file, and then you can continue on. So, but before we execute this application, we obviously need to resolve that little red squiggly line under stream reader. As I mentioned earlier, the problem is that the C# compiler can't resolve the word stream reader to its full name. Its full name is system.io.streamreader. So to easily fix this problem, place your mouse cursor anywhere on inside that word, or you can hover your mouse cursor over there for a little bit and you see a little window pop up underneath of the S in stream reader. And then when I put my mouse cursor down on that little window, a little arrow appears. And when I click that little arrow, you can see we get a little contextual menu that offers to add a using statement. So I'm going to go ahead and select that. Now notice that there are some other things that we can do here. For example, I can choose to have it type out system.io.streamReader, or it can even generate a new class for StreamReader. Definitely don't want to do that just yet. So I can, for example, let me choose the second option first, just to kind of show you what it looks like. Okay, so I've resolved this first StreamReader because I've used its full name. It's essentially beginning, middle, and last name. And I'll do the same over here as well to resolve that red squiggly line. And now the application should execute. So let me go ahead and run the app. And I'll get another error. So before I talk about that error, what I want to do is show the other option that we can use. So I'm going to go back, get that little contextual menu to pop up. There we go. And then I'm going to choose using system.io. Now watch the first 5 lines of code at the very top. When I choose that, notice that it added this in line 3, and it adds them in alphabetical order, so it kind of reordered things here. And now it resolved both of the red squiggly lines. And there's a lot more I could say about a using statement. I could say a lot more about namespaces. I don't want to talk about them at length just yet. Know that we can use that little contextual menu that pops up in order to add a using statement to resolve references to classes that have not already been added by our console application project template. All right. So at any rate, now this should work, but we already noted that there was another problem. And we get a new unhandled exception of type file not found exception. All right, so what could that possibly be? Well, the problem is that the file is in our project directory. The values.txt file is in our project directory, but it was never copied to the bin.debug directory. And to prove that, let's go to the documents. Let's go to Visual Studio 2013 projects folder, read text file while, and we'll go into the project folder, and we can see here's our values.txt file. We're going to look in our bin debug folder, but we don't see that values.txt file anywhere in there. All right, so we have to explicitly tell Visual Studio to copy the values.txt file into the target directory, the bin debug folder, and we'll do that using the Solution Explorer and the Properties window. All right, so if you don't already have it selected in the Solution Explorer, make sure you select it. And then look below. The properties are now in reference to this selection that we have in the Solution Explorer. So all these properties apply to values.txt. All right, and you can see that there's this little copy to output directory property. And currently for the file, it's set to do not copy. Now, if we were to look at the options by clicking to the right-hand side, there's a drop-down list of do not copy, copy always, or copy only if newer. There's really no reason in this particular situation not to choose copy always. So in other words, we will copy it every time we recompile the application into the debug folder. We want to also copy the values.txt file into that debug folder as well. All right. So what's the difference between copy always and copy if newer? Well, copy if newer will only be copied over if there has been a change to the file. Either one of those will work in this situation. Since I have it in the textual version of this lesson, I'm going to go ahead and use the copy if newer option there as well. Okay. So now whenever we run the application, it should have copied that values.txt file. It should have then looked for it in its directory, in the same directory where the executable is at, found it, read in each of the values, and then printed them to screen and then exited out correctly. And as you can see, it's done that. Awesome. Okay, so that pretty much wraps up this lesson. I know there's some mysteries surrounding that using statement, some mystery surrounding namespaces. Trust me, we're going to get to all of that a little bit later. At least for the moment, you know how to resolve these types of namespace issues that might pop up in future code examples. Why it happens, well, we'll explain that in a little bit. Okay, so we covered a couple of important concepts here. First of all, hopefully you've got another iteration statement under your belt. You'll use the while iteration statement when there's an indeterminate number of times that you'll need to iterate through a block of code. And that's unlike the for statement, where we knew for sure up front how many times that we were going to loop through the block of code based on the conditions that we were going to check. So that's really the difference between the two. You can see that there's a need for both of those situations, and therefore that's why you have 2 or 3 different types of iteration statements. We learned about the stream reader class. I compared it to a straw that allows us to suck in data line by line from a text file using its read line method. And then we closed our connection, our hold of the text file using the close method to release it. And while we were talking about the stream reader class, we saw how we need to help the C# compiler resolve references to classes by providing a using statement for the class's namespace, or at least providing it the entire name of the class, not just its casual name or its the class name. We need to provide it the full namespace, like system.io.streamReader in this case. Okay, and I haven't told you the full story about all that yet, and we are not going to be able to put it off much longer. We're getting really close to it. We also talked about null values. We said that they were an indeterminate or unknown value, and how that's different from an empty string. An empty string is empty. We know that. But a null value, we just don't know what the value is. Okay. And then we saw how we can add additional items to our projects. In this case, we added a text file. We learned how to set properties for something, anything, in this case, that text file in the properties window. And in that particular case, we set the copy operation to always or only copy whenever that file is newer into the debug or release folder. Okay, so that wraps up this lesson. You're doing great. Let's continue on. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps for some of the world's best companies as quickly as possible. Many types of applications involve managing text, whether it be a customer relationship management application where fields of data and notes are stored about customers and sales opportunities, or a content management system where entire paragraphs of text are published to a blog or some other web-based presentation application. So mastering string manipulation is a vital skill in C#. In this lesson, I'm going to demonstrate several common string manipulations that are made easy by both C# and the .NET Framework class library's string class. So let's go ahead and start off by creating a new project. And this time I'm going to call it strings. And click OK. And so let's start off by saying that we want to write a simple string to the console window, perhaps some instructions to the end user about where to find a file on their hard drive. And so let's say that this particular string has a backslash. So we'll do something like this. To your C drive. And then just a console. This particular string, as you can see, has a backslash, and it's typically used to denote some folder or subfolder on a file system. And curiously, as you can see here, it has a little red squiggly line next to that backslash. You might wonder what could possibly be the problem with this seemingly innocuous looking code. However, even if you start debugging the application, it's not going to let you. It says that there's an unrecognized escaped sequence. The reason is because the backslash has a special meaning in strings in C#. It's an escape character that's used to produce other special characters in commands. So to produce the desired result here of your C:/drive, we'll have to use 2 backslashes together, and this will produce a single backslash whenever it's displayed to screen. So let's go ahead and now run the application, and you can see it displays correctly. Again, the backslash character is an escape character within strings in C#. So let's go ahead and reforce that and show you how deep this rabbit hole goes. So how would you produce like a double quotation mark? Because obviously we're using double quotation marks to surround and create a literal string. But what if you wanted to embed a double quotation mark inside of a literal string? So let's do this next code example here. Okay, you can see I'm kind of fighting the IntelliSense here. It wants to put something and I want something else. Okay, so that's what I was intending to get to, and I had to undo what IntelliSense automatically spat out for me. But here again, I'm trying to use double quotation marks inside of a literal string, and I'm not having a whole lot of luck. You can see that the words so-called are in black, and they're not considered to be part of the literal string, and I've got errors all over the place. So to remedy this, you use the escape character, which is the backslash before each of the double quotes. And so to fix this, we'll just put a backslash there and a backslash there. You can see now the entire phrase is surrounded by the double quotes, and it's all in red, and it gives me the visual cue that the C# compiler will be okay with this string. So this time, whenever we print it out to screen, it will print out correctly with double quotes around the word so-called. Great. All right, and so you can extend this into other types of characters and formatting, like, for example, a line return. So let me do another line of code here. String my string equals what if I need \n a new line. All right, notice the \n character that says format the string when it's displayed so that it will move to the next line, kind of like a carriage feed, I guess they used to call it. Let's go ahead and start, and you can see we get the desired output. Awesome. So for more information, see this blog post by the C# team. What character escape sequences are available? And you can see a comprehensive list of all of them. Awesome. But the key idea is that an escape sequence involving the backslash plus another character is required to create some of the characters that otherwise would be difficult to reproduce inside of a literal string. All right, moving on. The string.format, as we saw a couple of lessons ago, allows you to substitute or rather merge strings inside of other strings, sort of like a boilerplate template. So in the simple example here, notice what I do. So notice the curly braces with the 0 between them. This sequence of characters tells the string.format method to substitute this second parameter, bonsai, in place of this replacement sequence of characters, okay? And we've seen this before with console.writeLine. That's because console.writeLine also has this same functionality, the format functionality built into it, all right? So let's go ahead and run the application, and you'll see bonsai. Awesome. It's a simple substitution. But let's move on to a slightly more complicated example that shows how to substitute two values into a string. So let's comment this out. And string, my string, equals string.format. Okay, so you can see it's 0 base, so I start with 0, and this replacement code will be matched up with the first argument after our boilerplate, our string, which will be BMW, and then we will substitute the next replacement code sequence with what comes after that, 760 Li. And let's go ahead and run that, and we see our desired output. Awesome. But string.format can do more than just simply replace characters. For example, we can use it to format numbers in the various ways that we use numbers all around us, like telephone numbers, zip codes, money, dates, and so forth. So let's give you a quick example of that. So I start off with the 0 replacement code, but then I use the colon, and then the letter C, and then I'm going to do 123.45. All right, and let's go ahead and run it. And so as you can see, this formats the number, the C, colon C, formats the number as US dollars and cents, since that is the language preference on my computer. You can set the language preference programmatically as well. However, that's a little bit of an advanced topic. But otherwise, the runtime will use the language preferences on your computer to properly format the numbers for a given country. Formatting a number with commas and decimal points can be achieved using a similar type of syntax. So let's do this. MyString equals string.format, and then we'll go 0 and then colon n, and then we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, and that. All right, so let's go ahead and run. And you can see now we were able to format the number, the very long number, in such a way that we have the thousands, comma, and the millions, comma, as well as a period for you know, any values that come afterwards after the decimal point. All right. So if you need a percentage, you use another similar code like so. All right, let's go ahead and run it. So you can see that our 0.123 has been essentially multiplied by 100 and formatted with a percentage sign at the very end. And finally, what if we needed to format a series of numbers into a string, such as a phone number or maybe a social security number here in the United States? Well, you can create custom formats using the pound sign to represent the next number in the sequence. So I'm going to do this. I'm actually going to mangle this the first time through just to show what would happen if you don't have the sufficient number of pound symbols or numeric symbols in place. So we'll do it wrong the first time, and then I'll fix it by just adding one more. Okay, so here we go. And I'll just say phone number. And there should be 4 characters here, but I'm only going to put 3. That's how I'm intentionally hurting this. Okay, and so then I add 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And now let's see what the output is. Whoops. It says the string input was not in a correct format. Let's see, what did I do wrong here? Oh, I forgot the ending curly brace. Okay, so let's go ahead and do that one again. Okay, so notice that we have too many numbers, and it begins on the right-hand side and moves towards the left. And so it starts with 0, 9, 8, 7, 6, 5, 4, 3, 2, and because we have one extra value, it puts it here at the very beginning. And that's clearly not what we want, because area code should only have 3 values. If anything, we would have wanted it at the very end. So to fix this, I'm just going to add one more pound symbol there, and then run it again, and it'll be formatted correctly. Great. So this is actually a small set of examples for a very large topic. For more information, I'd refer you to the MSDN help article. It'll give you several jumping off points. Make sure you look at like this composite format string and some of the other the links on this page to learn more format options for string.format. Okay, moving on. Previously, we showed examples of the string concatenation operator using the plus symbol. Okay, the plus symbol, we said in the correct context, is the string concatenation operator. So take a look at this example that I'm going to build. And let's run this little application to see what it does. It merely loops through 100 times and appends the current value of I to the string and adds some dashes to format each of the values in between. Okay, so we can actually do this in a smaller line of code like so by using the plus equal operator. I.toString. And that should give us the same result. So I just wanted to throw out the plus equal operator, which means take whatever I already had in my string and then append these items to it, whatever is on the right-hand side. Okay? So while using the string concatenation operator, the plus symbol, especially so many times works in small applications, there is actually a little bit of an issue here with taking this tack. When a string is declared and initialized, it takes up a fixed area in the computer's memory. When you concatenate the string and then reassign it to contain a new value, then there's some behind-the-scenes work that the .NET runtime has to do to create a new space in memory large enough to hold the new length of the new string. So it has to do that essentially 100 times. So here's the original string. Oh, you want to add all this together? Well, I got to create another area to combine them all together. Oh, you want to do that again? Well, then we're going to have to create another area in memory and then take it and put it up, and it has to do that little dance like 100 times in this particular instance. So if you're working with a lot of strings and string concatenation, as we're doing in this example, this could impact the performance, or at the very least, it could cause our application to consume more resources on the computer than it really should. So it's generally preferred in this scenario to use a class that's built in to handle concatenation tasks like this. It's called the string builder class. So let's take a look at, and let's go ahead and rebuild this example. So let me just go ahead and comment all of this out. Here I'll go string builder, my string equals new string builder. For tab, and then I'll use the tab key one more time to go 100, hit the enter key to get inside of the curly braces. We'll go my string dot append, and then so I'll append the two dashes and then my string dot append the value of I. All right. And now really what I should do here is a toString. You don't have to do that, but I'm going to go ahead to in this example and do that. And you can see we get the exact same results, but because we're using the string builder, the performance should be improved because the string builder was built with these sorts of operations in mind, where you're constantly manipulating and concatenating strings together. So it's generally preferred to use a string builder rather than a string whenever you have to do a lot of string concatenation. Okay. All right, finally, let's take a look at how to work with some of the built-in string methods to manipulate strings. Again, there are many more than what I'm going to demonstrate here, but at least these will get you started, get you familiar with what's actually possible. So let's do this. Let's comment all of that out and move below it. And so string my string, and I'll just type in the opening line to one of my favorite songs. And then I'm going to go my string equals my string dot substring, and then I'm going to give it the start index, so start at position 5, and then substring 14 characters. All right, and then let's go ahead and print my string, and we don't need this anymore. Like so, and let's go ahead and run. So notice what happened here. We were able to use the substring method, and notice that was baked into strings. So it's one of the superpowers of strings. It's just automatically there no matter whether you want to use it or not. Every string has this function, as well as some others we're going to look at, so that we can say start at this position in the string and then return so many characters to me. So in this case we just took 14 characters out to print out somewhere we took from that longer string. So we can pull from inside of the string, and notice that it's the 5th index is actually the 6th character. It is 0 based, just like arrays are. Okay. All right. So let's do this now. Let's comment this out, and this time I'm going to go my string equals my string dot to upper. What do you suppose this will do? Let's go ahead and run it and see. Notice that it took the entire string and it put it in all uppercase. And so this is particularly useful whenever you're comparing text that a user typed in to text that you're anticipating, and you need to evaluate the two. So did he really type the word yes? And if so, we don't want capitalization to be a problem here. So we capitalize both, whatever the user typed in, whatever value we're expecting, and then evaluate the two in an if statement, for example. So it's just making sure that we're comparing apples to apples. All right. One other thing we want to do here. Let's use the replace. Whoops. Replace. And so what we want to do is replace all empty strings, and we'll replace them with 2 dashes. All right. So now let's run the application. So the replace method allows you to search through an entire string for one or more characters and then replace each instance with one or more characters. So in this example, I'm simply replacing all the blank spaces with double dashes. And I'm doing this for no good reason other than to demonstrate the utility of the replace method. Now, I use this replace method often whenever I'm massaging data from one source and I need to save it into a different target, and I need to change some things. I need to look through and see if there's any special encodings that were in that string, whether it be from a text file, an HTML file, or whatever, and I want to change the values inside of it. So I'll do some searches. I'll remove maybe things that are not useful for the new purpose, but replace allows you to do that. All right, and then let's do this, and this will be my last little trick. I'm actually going to add some characters to the beginning and the end of the string, of the literal string. Okay, and then what I want to do is this: my string equals string.format. We're going to kind of tie a bunch of these things in together all in one example. Okay, and because I don't like long lines of code running off the end of the edge of my visual area, I'm going to actually separate these to the next line. And this is something common I'll do. In fact, sometimes I'll just go ahead and separate all of the arguments, the input arguments, onto their own lines. I may even take this first argument to be consistent and do that as well. It's really just kind of depends on what you want to do. But at any rate, notice what I'm doing here. I'm going to print out the length of the string. So I'm simply going to use the length property of my string. And then I'm going to use this trim method and then look at the length. And the trim method will trim off any extra spaces at the very beginning of the string and at the end of the string. And so what we're doing is I want to show a before and after. How many characters did we have before we chose the trim method, and then how many after we executed the trim method on our string. So let's go ahead and run it, and then I want to point some things out. Okay, so we eliminated 3 extra characters, one before the string and then 2 at the very end of the string. We trimmed them off and we got 43 characters instead of the original 46. Okay, and so one of the things that I want to point out here is notice the syntax, how I'm able to call the trim method. Now, because the trim method actually will return back a string, you can see that string.trim. It removes all the leading and trailing white space characters from the current system.string object. And it'll return back to you the string without those leading and trailing white space characters. Since it returns a string, I can chain it together with the next property of a string, which is length. And so I can use this chaining, and I will do this throughout the remainder of the series. I can chain these commands together in order to be very expressive and do things more compactly in a single line of code, where it may have taken several lines of code and some manipulation of copying this, copying that to a new variable, and now putting it to screen. Okay, I'm just doing it all in one shot here. So don't let that throw you. As long as the method that we're calling returns the same value or some data type, that we can still operate on it by chaining the next method or wherever the case might be together. We'll see it again. Don't worry if you don't get it in this first pass. Just wanted you to see this for the first time. Let's see it in action. I think we already did this, right? Okay, yeah, we did. Great. Okay, so as I said earlier, these are but a smattering of all possible string manipulations. However, this short list that we've gone through should serve you well. I would encourage you, before you go off and start writing a lot of lines of code, working with strings, manipulating strings, to take a few moments and review the methods of the string class. Chances are there's already a method or two that can, at the very least, speed you along your way. I've seen people write some elaborate code to perform some string manipulations when all they needed to do was call a single method on the string class, just because they weren't familiar with what was available. Okay, so we're doing great. We're going to do the same sort of treatment to the date time data type in the very next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In our previous lesson, we looked at string manipulation. Often you're going to be working with dates and times in your applications, and so this lesson is going to look at both the basics of working with the date-time class, as well as doing date-time math, formatting the date time to be represented as a string, and much more. So let's get started by creating a new project. We're going to want to make sure that we are working with Visual C# templates. Make sure you're working with the console application template. We're going to call this dates and times. All right, and so I'm going to begin by writing just a very simple application. We'll use this as a launch pad to move forward. So here we go. Okay, so I'm betting that you could probably figure out what's going to be output here whenever we run this application. First of all, I'm using a class called datetime. I'm actually creating a new instance of datetime called myValue. And then I initialize my new datetime class instance to datetime.now. Now is a static property that will just return the current date and time. Awesome. And now that I have a object of type datetime, I can call its toString method to simply print it to screen. The default, no fancy formatting, just want to take the date and time and print it out in a console window. So let's go ahead and run the application. And as you can see, it is the result of datetime.toString, just gives us the full date and time. So the datetime class actually gives us quite a few ways to format, helper methods to format the string. So let's just look at a few of these really quick. In fact, I'll go through all of the major ones. myValue. And so all these to whatever string methods, helper methods for the datetime class give us some interesting formatting. Already looked at toString, gives us the entire thing. We can also do to short date string, which I use often, and this will just return the current date, so just the date part, not the time. And you'll also notice here that that this is localized to the United States date format. Now, if you live in different parts of the world, you're likely going to see a day / month / year formatting instead. So .NET will utilize the settings on your computer to accurately represent dates, or as we've seen previously, monetary values, and even other data formatting differences between locales. Okay, so let's go ahead and take a look at the corollary to this, which is console.writeLine my value dot to short time string, and so we see just the time part. Awesome. 3:15 in the afternoon. Great. Now, console.writeLine my value dot to long date string. All right, let's see what we get there. So here we get it nicely formatted and printed out. Monday, December 30th, 2013. Okay, and let's see the time version of this as well. Console.writeLine my value dot to long time string, and we will see not only the hours and minutes but also the seconds. That's really the only difference there. Okay, so in addition to formatting how the date time is displayed as a string, we can also modify dates by performing what I call date math. All right, I'm not sure if everybody calls it that, but essentially we can add and subtract days, hours, months, years. Okay, pretty much any part of the date we can add or subtract values to and from it. Okay, so let's go ahead and do the following here and just take a look at my value. And what we can do, if you take a look at the very top here, there's an add days, add hours, add milliseconds, add minutes, add months, add seconds, add ticks, all right, add years, and so on. Great. So let's basically just do something simple, and so we're going to do an add days, and we'll just add 3 days, and then I'll just call it to long date string, all right, like so. Now let's see what it will look like 3 days from now. 3 days from now will be Thursday, January 2nd, 2014, and I can vouch for the .NET framework. That is indeed going to be the date in 3 days. All right, so let's move on. And the next thing that we'll want to do is, well, first of all, let me point something out that hopefully you saw, and I didn't really say much about it, is that you can often chain together multiple methods to save a considerable amount of typing. We've already talked about this, right? So all you need to do is just be aware of the data type that's being returned by each of the helper methods. In this case, what's being returned from add days? Well, if we hover our mouse cursor over it, we can see what's being returned from the add days method is a new date time, a new instance of date time. And so once that's returned, then I can use that and operate on that by calling the toLong date string. All right, so just be aware of the data type that's being returned by each method in the chain in order to get the desired results. And you can see as I was typing that IntelliSense really plays a big role in this. And you will often see this style of coding whenever you're writing applications or looking at somebody else's code because it's so compact. Let's take a look at another example of this just to kind of drive this home. Console.writeLine my value add hours, we'll add 3 hours to it, and then to short time string. And let's see, when we run this, you can see that it's about 3 hours from now will be about 6:20 in the afternoon. Very good. So this technique of chaining the results of a previous method call and using it as the input for a second and subsequent method call is popular in .NET, and it's popular in programming at large. It makes the statement more human readable and more compact. All right. So back to the date math operations. What if you need to subtract hours or years or whatever the case might be? Well, you can simply do something like this. So console.writeLine add days, whoops, my value dot add days, and then I'm just going to use -3, and that will allow us to subtract 3 days, and then we'll just do a 2 short date string, like so. Awesome. All right, 3 days ago it was indeed the 27th. All right, and so next let's talk about helper methods that will allow you to retrieve certain parts of the date or time. And so by this, I mean that you can just grab off console.writeLine, my value, and I want to grab just the month and display that in a string. All right, and again, this will be just the number, 12 December, okay? However, this sometimes is helpful whenever you're trying to do some more complex math, and we're going to show you how to determine the time between two points in time, but there might be instances where you need to work with big chunks of time at one time and work at a high level rather than at such a low level. So I can just see the number of months that have elapsed by comparing 2 times, grabbing the first date times month and the second date times month, and then doing a subtraction or whatever the case might be. Okay, great. Notice that before we leave this idea of grabbing different parts of the current date time, that we can grab things like, oh, the day of the week, which would be like Monday, Tuesday, Wednesday, so on. The day of the year, so in other words, if today were December 9th, I happen to know that that's the 343rd day of the year, okay? And then other things like obviously the hour, let's see, the day, the minute, month, second, and so on. Okay. I think the end of the year. Great. Okay. All right, so let's talk about creating and initializing date objects. We saw how to do that here at the very outset, where we actually set it to datetime.now. That created a new instance of the datetime class and initialized it to right this second whenever your application is executing. All right. The first way is through an overloaded constructor instead of doing it the way that we did it here. So let's go ahead and just go date time my birthday equals new date time, and then there are a number of overloaded constructors. Now, we've not talked about this idea yet. We'll talk about it here in a couple of lessons, but just know that I can pass in some date at the time that I'm creating a new instance of the date time. For example, I can just pass in the year, the month, and the day, like so, and then console.writeLine, my birthday, .to short date string. And so let's run that. All right, and so this, you'll say, well, all we did was just give it a string and it just spit it back out. However, what we gave it was just the numbers, and it converted those integer values into a date time that now allows us to work with that data type and all that implies with its add hours, add minutes, add days, add months, all the to whatever string formatting, and so on. All right, so that's the first way to create an instance of a new date, is to pass it a series of integers. The other way to do it is like so. And actually, I'm going to go ahead and flesh out this example so that you can see how to compare two different dates. So I'm going to determine the difference between two datetime objects. That difference requires a different type of object called a time span. It's not a date time, but it does represent the amount of time between two specific points in time, okay? So how much has elapsed between any two dates in time? So what I want to use is the subtract method in order to determine the amount of time between now and my birthday when I was born, lo those many years ago, in order to determine exactly how long I've lived on Earth, okay? So it's simple. All we need to do is this. First, we'll start by creating a new instance of my date and time called my birthday equals date time. And so the first method we used was by passing in something to the constructor. In this case, I'm going to call the built-in parse method of date and time and pass it in a literal string in order to get a date time that represents December 7, 1969. All right, so now time span, this will tell us the difference between two periods of time, and we're going to call this my age equals date time dot now dot subtract, and we'll send in my birthday. All right, so we'll take now, which gives us back a date time object, and we'll call subtract, which will return back, as you can see in IntelliSense, a time span object. Awesome. And now, once we use the subtract method of time span to, of the date time to get a time span, then we can simply go right line, and we're going to go my age. And now we look at the various ways to format a time span object. So we can do a toString, but more interestingly is total days. And you can see in IntelliSense it says it gets the value of the current system.timespan structure expressed in whole and fractional days. So this will tell me how many days, as well as hours, minutes, seconds, using a fractional day, okay, that I've been alive, assuming that, you know, I started on midnight. I was born on midnight, which I wasn't. So total days, and now we want to print that out to screen. Oh, we already did. Great. There we go. All right, so 16,094 and some odd days that I've been alive, and man, I'm feeling pretty old. I've wasted most of those. All right, so, but I could use some combination of properties and methods on the time span object to determine exactly how that translates into years, months, and days, given the possibility of leap years and so on. All right, so there's a lot that we didn't cover. I mean, you saw that long list of methods and properties available in IntelliSense that we didn't even talk about. But I felt that the ones we did look at, they were common uses of the date time and time span objects. And I'll give you the same encouragement that I gave you at the end of the previous lesson. If you find yourself writing a lot of code to manipulate dates and times, then you might want to stop, look through MSDN or search online, because chances are the .NET Framework Base Class Library has something for you already built into it, okay? So writing applications involves working with data, and we've learned in this lesson and in the previous lessons that the .NET Framework Base Class Library can help you with all types of manipulations on all types of data, simple types that we've seen so far. So beginning in the next lesson, we're going to talk about custom complex types, and we'll look at that, and we'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So near the beginning of this series, I said that classes were a container of related methods. And we saw how the console class contained methods related to working with the console window. We talked about how you access a method by using its class name and the period, or rather the member access operator, to access the methods in that class. We also looked at creating simple helper methods. At that time, I was emphatic that about where the method definition should be positioned inside of your code. The method needed to be contained within the correct code block, the class code block, in order to work properly. Now, truth be told, I intentionally oversimplified my explanation about classes and helper methods and all of that stuff because I knew that we'd want to talk about it, give it its full treatment in this lesson. I've also found that object-oriented programming and classes are kind of the entry to that thought process, is one of the most challenging things that a new developer will encounter first. There will be other challenges along the road, but this will be one of the most challenging concepts. To get it right will unlock a lot of ideas for you in answering the question, why did they do what they did with the .NET Framework? How do I properly create my applications, and so on? How do I delegate responsibilities to the right classes, and so on? All right, so as you'll come to learn, virtually everything in C# and the .NET framework is a class or it's part of a class. That's really the purpose of this lesson. Not so that you can create your own classes necessarily, although that will be required at some point as we move through these lessons. The intent here is to use the classes that were built by Microsoft and that are available through the .NET Framework class library. Now, the truth of the matter is that I couldn't possibly cover everything that there is to cover about object-oriented programming classes because it's a vast topic. If you really want to learn about the power of classes, then you'll want to learn specifically about object-oriented programming. But that's a topic for another day. I just want to present enough for you to get you comfortable with the basics of how to use the existing .NET Framework class library classes, as well as how to create super simple classes of your own. All right, so using the techniques that we have used up to this point, let's go ahead and create a new project called Simple Classes. Make sure it is a C# console window application. All right, and we'll begin by creating a class of our own. Suppose that I want to create an application that works with cars. I might have a car lot and I need to keep an inventory of all the cars that are there for sale. Okay, so to keep all the related information about a single car in one container, I might want to create a car class. So what we want to do is position the caret before the final curly brace right here, somewhere between this curly brace, the final one, and the second to last one that defines the class program. And I'm going to make some space for myself between lines 16 and 20. And I'm going to type the following. All right. So first of all, the keyword class tells the compiler what type of code block we're attempting to create. We're going to give this code block, this class code block, a name. We'll call it the car class. All right. And we'll see how that's used in a later step. What we define between the curly braces in our new car class will be the members of this class, including properties and methods. Classes can contain other kinds of members too, but properties and methods are the most popular, and they'll help us create just a simple class to start off with. And so in this lesson, we're going to create 4 properties. We're going to create a property called make, model, year, and color. And then later we'll create a method. So a property defines an attribute of a class. We can set their attributes in code or retrieve their attributes in code like we're going to do in just a moment. But we set and we get properties or the values of properties that we define in our car class. So that's a property. A method defines a name body of code that typically represents something that the class can do. So we created helper methods in some of the previous lessons to do something meaningful, like perform some super secret formula calculation that wasn't all that super secret, okay? But we could pretend. So let's begin by creating some simple properties here. And there are several ways to do this, several ways to define a property. However, I'm going to show you the easiest way to do it. The technique combines a shortcut in the Visual Studio IDE called a code snippet and with a shortcut in the C# programming language called auto-implemented properties. All right. So what we want to do is make sure our caret of our mouse is positioned between the opening and closing curly brace of our car class. And then what I want to do is type the word prop. You can see it finds it in IntelliSense. And then I'm going to hit tab on my keyboard. So I hit the tab key twice. And when I do that, you can see that this sequence, the prop tab sequence, fires off a macro, I guess you could call it in Visual Studio, called code snippet. And it creates that line of code that you see on screen. So notice that the word int is highlighted in a bluish green color. This indicates that you can currently replace that part of the code snippet with your own code. So with the int keyword highlighted in the bluish gray color, I'm going to start typing the word string because I want to replace the data type. All right. And now once I've typed in the word string, I'm going to hit the tab key on my keyboard twice again. And you'll see that the blue-green highlight will move to the my property portion of the code. This is what we want to call the new property. I don't want to use the word my property, too generic. We want to use the word make, like the make of a car, as opposed to its model, its color, and so on. All right. So you can use the tab key now to tab back and forth between these two replaceable parts. Pretty cool. Between the data type and the property name. So once you finish editing the code snippet, then you can press the Enter key twice on your keyboard. Enter puts you to the end of the line of code, and then Enter again puts you on the next line. Awesome. All right, so let's use this code snippet plus auto-implemented property technique in the previous step to create property definitions for model, year, and color, like so. Prop, tab, tab, string, tab, tab, model, enter, enter, prop, tab, tab, int, so I'll just leave that alone, tab, year, enter, enter, prop, tab, tab, string, tab, tab, color, enter, enter. Awesome. All right, so since this application that we're building will keep an inventory of all the cars on our car lot, as the developer, I'm going to need to collect some basic information about each new car. Now, to make this a real application, I might need to create a graphical user interface, maybe like a Windows Forms application or a Windows Presentation Foundation application type from the project templates available in Visual Studio, or I could create a web page that would help me collect data from an ASP.NET web form, and so on. But for now, we're going to keep this really simple, and we're just going to use our static void main to create a new instance of this class and to fill in the details about each new car that we need on our car lot. So that process, to begin that process in our program, I'm going to want to create a new instance of this class for each car on my car lot. And so you create a new instance of a class using the keyword new, like so. Let's go here in our static void main between the opening and closing curly braces, and we're going to go car. And notice that it recognized the word car now in IntelliSense. Car, my new car equals new car. All right. So an instance of a class is known as an object. So my new car is now an object. Again, an object is not a class, and a class is not an object, although you'll sometimes hear people confuse those two terms. I even do it accidentally on occasion. The class is the blueprint. An object is instantiated or created from the blueprint or the pattern. And then we can manipulate the object in the computer's memory. So in the real world, you can use the same blueprint to create many new houses, right? They call them cookie cutter houses, all right? You could use the same pattern to create the same clothing over and over. Or you could use a recipe to create the same cake or casserole and get the same results each time. So each time you want to build a new house, it'll be at a new address. Each time you follow the pattern, you'll create a new instance of clothing that can be sold to a different customer. Each time you follow the recipe, a new instance of the recipe can be offered during the same meal or a different meal. The same is true with classes. Each time you create a new instance of the class, you have a new object that's distinct and separate from the other instances of that class. All right, it lives by itself. So a class is like a cookie cutter. You can't eat the cookie cutter. You can eat the cookies that you made in the shape of the cookie cutter. So when you instantiate a class, you create a cookie or the instance based on the shape of the cookie cutter or the class, okay? So think of the new keyword that you see here as the factory. It uses the blueprint or the pattern or the recipe or the cookie cutter in order to create a new instance of that blueprint or pattern or recipe or cookie cutter, or rather a new instance of the class. It brings the class to life in the computer's memory, and it makes it usable by your application. So you can create many instances of the class, or you can create many objects, all based on the same class, but each one is distinct from the others. So what I want to do is I'm going to set the properties of this new instance of car called my new car to their appropriate values. So in this case, I'm going to merely hard code the values here in my static void main. But in a real application, I could present a graphical user interface to the user, and I would ask them, like a web page or a Windows form, whatever the case might be, to collect this information and then create a new instance of this object, and then work with it somehow, do something meaningful with it, okay? So as I type out this example, I want you to notice that the dot, the period, the member access operator, is the way that you get to the properties of an object. And it actually will even recognize what you built here in your class. It'll open up IntelliSense to show you the members of the class that are currently available. All right, so here we go. We're going to set the properties of my new car. Notice IntelliSense sees all. Okay, so let's take a moment to dissect this code and really understand what's going on here. First of all, I use the name of the instance of the car class, my new car, to access each of the properties of the car class that I'm going to set. Notice I'm setting it by using the equal operator. I'm setting the property make to the value Oldsmobile, for example. So I use the equal sign as the assignment operator. I'm assigning a new value to each of the properties. These new values for each property are maintained in memory for this instance of the car class, and as long as I have a reference to this instance of the car class, I can retrieve those values back out, or I can change them again. This is called get and set. As long as I'm using it, it stays in memory. When I stop using it, it goes away. All right, we'll talk about that more in a little while. Now, once I have a new instance of my car, of the my car class, and have set its properties, I can do some useful things with this instance of the car that I've named my new car. For one thing, it's a nice collection of all the related properties or all the related variables that define the car in one container. I can get to every related thing about the car by using the my new car moniker or identifier. All right. So next, what I want to do then is print out certain properties to the console window like so. And this will show you how to get the values out of the properties for the instance of my car, my new car. Here we go. We'll use that fancy formatting that we've used in the past. All right, and although this is on a second line of code, it's still the same basic executable line of code. All right, just putting it here for readability's sake. That ends that line of code. And now let's read the line. Like so. In lines number 15 through 18, I'm setting the properties. In lines number 20 through 23, I'm getting the properties. Remember that nomenclature, setting versus getting. Okay, that's important as you move forward past this series of lessons and talk about properties, more properly formed properties in the world of object-oriented programming. Okay, so in this example, I've been creating the simplest version of properties, which I called auto-implemented properties. However, there's a longer form which allows me to write code logic that will execute every time one of these set or get operations is performed in your code. So when you write code that handles either the setting of a property or the getting of a property, they are sometimes called setters and getters. Again, that topic is a bit advanced for now, why you'd even want to do such a thing. Just remember that we're creating very, very simple properties for now, and you can learn more later. All right, secondly, whenever I create a custom class, like the car class here, in other words, a class that I created as opposed to a class that's from the .NET Framework Class Library, I've really created a custom data type, just like any other data type that we've been using in our applications, such as the string or int, or actually more like the date time like we used in the previous lesson. Therefore, I can define method input parameters or return values from methods using that new custom data type. All right, so let's do this. I want to demonstrate how that works. We're going to create a new method, a private helper method called determine market value. I'm going to allow the user to pass in an instance of the car class. And we'll just hard code a value. And then someday I'm going to write some code to go online and look up the car's value and retrieve its value into the car value variable. And then I'm going to return the car value. All right. Okay, so here I created a helper method that allowed me to accept an instance of the car class called car. And I've merely mocked up the functionality as I kind of wrote this little comment here for the sake of brevity. But the key idea here is that you can use your new class as a data type anywhere that you would typically use data types in your code, such as input parameters. All right? Okay, so now you might think that it's strange that I called the input parameter car the same as the name of the type car. All right, capital C in the type, lowercase c in the actual variable that I could then utilize throughout the body of my helper method. The first, again, this car, as you can see, it's highlighted in that aqua color. That means Visual Studio recognizes it as the data type car, the one that we've defined here. Whereas the second car, the lowercase car, is the input parameter name. And so then I can, reference it down here. If car equals, Buick, then something, all right? So we can use the lowercase c car in order to work with whatever was passed into this helper method. Now, I've cautioned against using the same name for two variables in the past. This is just a common convention. I've also seen people use something like this with an underscore just to make sure it's obvious in everybody's mind that we're working with something that's an input parameter as opposed to the class, the type, car. Okay. So now whenever I want to call this new helper method that I've created, I would pass an instance of the car class like so. So here I would go double market value of car, because I expect a return value, because I expect a double to be passed back, this value 100, which is hard-coded. I expect that to be passed back from calling the helper method. But here I'm going to call determine market value. I'm going to pass in my new car. All right, like so. So that's how you would work with the car data type. You can use it now anywhere in your application where data types are accepted. Great. Let's talk about creating class methods. We've created a helper method, but what if we wanted to create a method on our car class here? So I said that classes are comprised of both properties and methods. And let's create a new version of that determine market value method, this time as a member of the car class. And what I want to do is simply copy the body of the determine market value method into a new method, a member method called determine market value. So I'll go public double determine market value. I'm going to paste in that code I just copied. Okay. I'm just going to change the body of this to be a little bit more meaningful this time around. So let's go ahead and get rid of this. So we'll do if this dot year is greater than 1999, or actually 1990, then car value equals 10,000. Else car value equals 2,000. Okay, so we'll give you money for your trade-in as long as it's newer than 1990. Otherwise, we'll just give you a flat rate of $2,000. Great. Notice here that I use this keyword called this. The this keyword allows you to access all the private and public members for an instance of the class. So when I type the word this and I hit the period on my keyboard, IntelliSense knew that I'm talking about the car class because that we're dealing with the current instance of the car class, whatever that might be when we create a new instance. And so we want to take all of the values of that instance and make them available inside the body of our method. So I can get to this dot year or this dot model or this dot make, and it will return back, in this case, you know, Oldsmobile or Cutlass Supreme or 1986 or silver, you know, based on whichever property. And so admittedly that this keyword is optional. I could get to the year for this instance of the class without using the this keyword. However, my personal preference is to use the this keyword because it's expressive and it helps you and everybody else know that where the identifier, this year, came from. I mean, if you have a large body of code, you're going to say, well, what is this year thing? Where did they get that from? Oh, it's part of the car. Oh, I see it. It's up here, car. All right, by using the keyword this, it's obvious to me what, you know, where that came from. It's part of the class definition, all right? Okay, so finally, what I want to do is call this new method and I want to display the car's value. So let me clean this up here. And I'm going to go up here to the top. I'm going to get rid of this. And I'll just do a console.writeLine. I'm going to do it all in one line of code. So cars, value, and remember how we formatted a currency value, like so. So then we'll call my new car dot determine market value, and there we have it. So I'm using that string formatting code that we learned about from a previous lesson to display the return type, the double that's returned from this, as a dollar amount using that :C formatting code. All right, so now let's go ahead and run the application. Now, what will my car be worth? It'll be worth only $2,000 because it was before 1990. Awesome. All right, so in this lesson we used a very concrete example, the example of a car. A car is easy to conceptualize and represent in a class because it's tangible and there's a real world equivalent. As you begin to build applications, especially in this series of lessons, you will not be responsible for creating your own custom classes. For now, I think your main exposure to classes will be those classes that are created by Microsoft in the .NET Framework class library. In most of those cases, the kind of classes that have been defined in the .NET Framework class library do not have real-world equivalents. In other words, they're more conceptual in nature. For example, I might work with a class that represents the connection to the internet or a stream of data, which is sort of like a pipeline of data flowing from one place to the other, or a span of time like we saw in the previous lesson. In these cases, we're not working with something tangible that we can touch and feel, but rather we're working with something that's conceptual in nature. So as you mature as a software developer, you might want to invest more time in learning how to create your own library of classes that interact with each other as a means of breaking down real-world problems that are conceptual in nature into code. This process is called object-oriented analysis and design. Again, that's not something that we're going to cover in this series of lessons, but you can learn more about on either Channel 9 or Microsoft Virtual Academy or on my own website, www.learnvisualstudio.net, where I spend a lot of time talking about these things. All right, so to recap, a class is a data type in .NET that's similar to those basic data types that you've been using up to this point, like string and int, and datetime, and so on. You can define a custom class with properties and methods, and then create instances of the class, or rather create an instance, create an object using the new operator. Then you can access that object's properties and methods using the dot operator, the member access operator. So there's still quite a bit to say about classes. Don't worry if you don't understand everything about classes, why you even need them. Just make sure you understand the process we went through to create a new class, how we created properties using that prop tab technique, how we created a method that allowed us to pass in the type car, right? And then we created a method that was part of the class itself that we could call on our instance of the car, like we did for this example right here, and how we were able to get results and print them to screen. If you just understand that much, then you're doing all the right things. We'll fill in more details in the coming lessons. You're doing great. Hang in there. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, we're going to talk about the lifetime of object references and how the .NET runtime manages the memory that your objects use. And we'll talk about constructors, which are special methods that fire off whenever you create a new instance of a class. And finally, we're going to talk about static methods and properties. So first of all, let's create a new console application called Object Lifetime. And so I want to recreate part of the car example that we used in the previous lesson. So I actually have it on my clipboard. I'm going to just paste it in here and pause the video if you need to catch up, but make sure that you've created the car class. You can practice that prop tab tab, enter technique in order to create the properties if you like to. Just go ahead and pause the video, and before long you should have what you see here on my screen. And then the next thing we'll want to do is create a new instance of the car class like we learned about in the previous lesson. So let's put car, my car equals new car, like so. Great. Okay, so let me ask you, what is happening whenever this line of code is actually executed? The car, my car equals new car. Well, the .NET Framework runtime has to go and create a spot in the computer's memory large enough to hold a new instance of the car class. So the computer's memory has addresses similar to street addresses of your home, where it temporarily stores values during the lifetime of a variable, or in this case, of an object. So the .NET Framework creates a place in memory large enough for the particular data type, in this case, an instance of this class, of the car class. It takes note of the address where it put that new instance of the car class, and then it serves that address back to you, the programmer, so that you can get back to that information in memory. And you store that reference in your variable, in this case called my car. Okay? So my car simply holds an address, a reference to the instance of the car class in the computer's memory. Whenever you need to work with that instance of the car class, you just use the my car identifier, and the .NET Framework takes care of the rest for you. It gives you the illusion that you're actually working with the object itself, but in reality, you're just holding on to a reference to an address in the computer's memory. Okay? So an analogy that helps me understand references to objects in memory is kind of the handle of a bucket. We've used the bucket analogy several times up to now. When you store an object in memory, .NET gives you, the developer, a handle so that you can hold on to the bucket. If you let go of the handle, you'll no longer be able to retrieve the bucket. The bucket will no longer be accessible. But why will it no longer be accessible? Well, the .NET Framework runtime goes through and cleans up memory every once in a while by counting references. If we're no longer holding on to a reference to that instance of the car class, then it will remove the data that's stored in that spot in the computer's memory and frees it up so that other programs can use that address in the computer's memory for their own needs. And this process is called garbage collection. So you can do something like this, like we've already done here, where car, my car equals new car. And then, you'd set properties and do all kinds of stuff like that here. And then you could do my other car equals my car. Okay, and so now you have two references to the same object in memory. Notice that in this second case, I didn't create a new instance of car. I just set it equal to the instance of car that we created previously in line number 13. So now you have two references to the same object in memory. We essentially attached a second handle onto that same bucket so that we can use either one to retrieve data in the bucket, so to speak. So another analogy, it's like the string to a balloon. After you cut the last string holding the balloon, it floats off in outer space and you never hear from it anymore. You never see it again, okay? Well, as the references go out of scope, in other words, when the current thread of execution leaves the code block where the variable or object's in scope, or those object references are set to null intentionally by you, the programmer, then the number of references to the object, the number of handles in the bucket, go to 0, and that's known as a reference count. And then at some indeterminate time in the future, the .NET Runtime's garbage collector feature will go around and it will look at each object in memory and it will remove those objects from memory that no longer have anything pointing to it, any references to those objects in memory. They, in essence, empty the garbage buckets out, and that memory can then be used for some other purpose. So in this case, we could explicitly set our object references to null like so. So my other car equals null, and then my car equals null. And then at some point, the object references, once it hits those lines of code, at some point in the future, the object that those variables reference will be removed from memory. When does it happen? Well, whenever the .NET Framework gets around to it, okay? In some situations, this indeterminate period of time can pose a problem, especially when the object in memory is holding on to a system resource like a reference to a network connection or a file on the file system, or holding on to a handle to access the database. In these cases, you want to take a more deterministic approach to requesting that .NET removes the object from memory and, if necessary, finalizes any cleanup procedures that might be required. So in these cases, you want to learn about a term called deterministic finalization. However, that's a little bit more advanced, and we're not going to cover that in depth here. However, a quick search on the internet will provide plenty of discussion about what it is and the scenarios where it'll be important. All right, so let's talk about that first line of code, line number 13, once again. My car equals new car. So there's something subtle about this that might not jump out at you right at first. Notice that there's parentheses on the end of that second car. So we call that a set of parentheses is the method invocation operator. Whether you realize it or not, you're calling a method whenever you create a new instance of this class. This method is referred to as a constructor, and it allows you, the developer, the option to write some code at the moment of instantiation, that moment when a new instance of your class has been created. So constructors can be used for any purpose, but they're typically used to put that new object that you just created an instance of into a valid state, meaning that you can use it to initialize the values of properties of the object. So a quick example here. Let's say that you want to create a constructor that would set the properties of car whenever it's created, so to some default values, so that it's ready to be used right after you create a new instance. So we can do something like this here. In fact, let me go ahead and add one more property here. Prop tab double original price. All right. All right, and so here what we can do is go public car, and then you could load this from a configuration file, database, or whatever you have. I'm just going to hard code it in this instance. Great. So I'm going to do something like this dot, and we remember what the this keyword does, gives you access to the new instance, or to the instance that you're currently working with. So this dot make equals Nissan. So whenever you create a new instance of the car class, automatically it's going to set the make property to a Nissan. Admittedly, that doesn't make a whole lot of sense right here, but I'm just showing you the technique that you would use, not the rationale in this case why you would want to do that. All right? Okay. The next thing I want to talk about is overloaded constructors. Just like you created an overloaded method by changing the method's signature, in other words, the number of and the data type of the input parameters, you can do the same with the constructor method. You can create an overloaded constructor. So let's add an overloaded constructor to our car class. And I'm just going to create a second method like so. Notice I'm not using the this keyword this time. Okay. So now whenever we attempt to create a new instance of car, Let's do that here. Notice that I get two versions of the method. I'm using my up and down arrows on my keyboard. So the first method signature takes no parameters, and the second takes 4 input parameters. So this helps us put the new instance of the class into a valid state to begin with. All right, so let's go ahead and create using this. So we'll just do forward, escape, 2005, white, like so. Great. All right, so what if we were to create an overloaded version of the method that conflicts with our existing overloaded constructors? So let me do this. I'm going to take this, I'm going to copy it, and I'm going to paste it here. And I'm going to say, call this some other input parameter, like so. Okay, and we'll even go some other input parameter, like so. Okay. All right. Well, whenever we attempt to actually build our project or run it, the compiler will stop and say that this version of the method conflicts with our existing overloaded constructors. So type object lifetime.car already defines a member called car with the same parameter types. All right, so it fails because the car class already defines a member called car with the same parameter types. The method signature has to be different. The name of the first parameter changed, but its data type did not change, and that caused the compilation error that you see on screen. So the parameter names don't affect the method signature, just the data types and the number of parameters. All right. So again, we used an overloaded constructor to initialize values of our new instance. Let me get rid of this. Right here. We could create as many different overloaded versions of our constructor, or any method for that matter, that we wanted to make it more convenient to call by the consumer of that method. All right. So what happens if you don't create a constructor? I mean, in our previous example, in the previous lesson, we didn't have any constructors. We didn't even talk about them. So what happens when you don't create a constructor? Well, nothing really happens. Basically, a default constructor with no input parameters and no body will be created automatically for you. So it'll be essentially the equivalent of doing that, okay? And it'll be created for you, and it'll do nothing, right? So let me paste back in what I just stole. All right, like so. Great. All right, so you still, no matter what, will have a constructor, just won't do anything. The implicit default constructor has no input parameters and no method body. It's actually just generated for you at compile time. Of course, as we've just seen, by defining one or more constructors, you're merely taking control of the process of instantiation. All right, so let's move on from constructors. Let's move on from talking about overloading. Let's talk about the keyword static for just a moment. We've seen this at play in every application that we've built here in the static void main, for example. So many times classes that we're going to work with related to building .NET applications don't require you to create a new instance of them to actually work with them. So you might recall seeing the following. Do you remember array.reverse and we passed in myArray? Or remember we used datetime.now and I said it's a static property at that time? Or string.format, how does that work? Okay, or we use console.writeLine. We never created an instance of console, but we're able to use the write line all over the place. Well, how is that even possible? They just kind of pop out of nowhere, and we're instantly able to use them and work with them and utilize them. Well, it's only possible because when Microsoft created those methods and those properties, they defined them as static, or they defined the entire classes as static classes. And you can create your own static methods and classes as well. So again, our objective here at the outset is just to help you utilize the .NET Framework class library. So just know that some classes that you'll want to work with will require you to first create an instance of a class, and others will be available as static members right off the bat. In other words, their static methods will be available to you without requiring you to create an instance of the class first. But just so you can see how this works, it's really simple. You just add the C# keyword static. So in this case, let's go back to the car class here, and let's create public static void my method, all right? And it won't really do anything. And then we can use it in our project like so. Now I'm not going to use any of the existing my car, my other car, my third car, any of those sorts of things. We're just going to call car dot, and notice it shows up, my method shows up as a static method without creating an instance of car, okay? Now what's a bit more complicated is why you might want to create your own static members on your classes. And that might require a longer discussion of design patterns and coding heuristics. Again, I just want you to know what they are for now and how you'll encounter them when working with the .NET Framework Base Class Library. And you can pick up the rest a little bit later on whenever you're designing your own code library. It's not really important why you'd use them just yet. Just know that they're in use and there's a reason, and we're not going to talk about it in this series. Okay, so in this lesson we talked about the lifetime of an object, including what happens when there are no more references to an object in memory, and how the .NET Framework runtime employs the garbage collector feature to remove those objects at some point during the execution of the application. We looked at constructors and overloaded constructors to put the object in a valid state before we use it. We also talked about the static keyword and how to use it to create essentially utility methods that are available anywhere at any time without having to create instances of classes first, like we've seen and used many times up to now with the various utility methods in the .NET Framework Class Library. All right? So if you don't completely understand the notion of static, I'd recommend that you watch that portion of this video again. That will become crucial. Again, it's just available without having to create an instance of the class. We're not going to talk about why. It just is for now. Also, make sure that you understand the notion of overloading. We've seen it at work. And to create it, how do you create an overloaded version of a method? Right, you just make sure that the method signature is different. The method signature is the name, but specifically, it's the number and the data type of each of the input parameters. If you have that under your belt, I think you did really well with this lesson. You can move on. All right, so we'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. As I stated at the outset of this series, half of the battle to learning to develop software is learning the C# syntax itself, and the other half of the battle is learning how to utilize the .NET Framework Class Library. Now, we've seen the .NET Framework Class Library, and we've been talking about it. It actually has a second name that it's known by, the Base Class Library, and I'll explain why that's actually a really interesting way of describing the library as a series of base classes. So we're going to talk about base classes in this lesson, and specifically inheritance, what it is, how to harness it, and so on. Okay, so using the technique that we've learned previously, we're going to create a new console application called Understanding Inheritance. And the very first thing I'm going to do is start with that car class like I've used previously. I'm going to paste it in here. I'm going to add quite a bit to it. Now, if you need to catch up, pause the video. Make sure you follow along, whatever you do, all right? We're going to add a lot of code in this lesson, so get typing. All right, we're also going to create a helper method here. We haven't created this particular one before. This time it's going to be a private, actually, I take that back. It's going to be a public string format me, will be the name of it. And we're simply going to just return a string.format, and we're just going to make a string pretty. So, you know, depends how you define pretty, I guess. We're going to format it. That much I can promise you. And again, same line of code. We're just moving to the next line here. So we'll start with a make. We'll show the model. We'll show the color. And we'll show the year. Great. Awesome. Okay, now that we have a fully fleshed out car class, let's go ahead and create an instance of it. Let's populate its properties, and then I want to print that format me to screen. Okay, so I'm going to actually start off simple. So here we're going to go car, my car equals new car. That much we understand. And then we'll populate all the properties like the make. We'll set it to BMW. I wish my car was a BMW, but it's not. A model. Set to 745 Li. My car dot color. Set that equal to black. And then 2005. All right, now I'm going to create a helper method that belongs to the program class. So it's going to be a private, and we'll talk about private and public later, private static void print car details, and I'm going to allow the user of this helper method to pass in a car, and then we'll do console.writeLine. Here are the car's details. 0, and what will we pass it? Car.formatMe, like so. Awesome. All right, just to make sure that we've typed it all in correctly, I'm going to go ahead and run it real quick. Whoops, something's not quite right. Oh, I forgot one key ingredient, actually 2 pieces. I did this when I was preparing this too. Okay, so let's call the print car details and pass in my car. That's the first part. And then console.readline, like we do in every single application we build. Now let's test it. All right, that's exactly what I wanted to see. Awesome. Hopefully everything that I did here makes sense to you, and we don't need to review any of this. If something didn't make sense, you probably weren't watching the last couple of lessons closely. I'd recommend that you go back and rewatch some things. All right, make sure that you understand what we've done so far. Okay. All right, so let's suppose for a moment that this application works great, and the car class is great for cars, but suppose that we need slightly different functionality whenever we're working with trucks in our application. So in some ways, trucks and cars are the same, and in some ways, trucks and cars are a little bit different. I suppose I could create a second class that's called truck, and I can make it almost identical to the car class in every way except for the properties and methods that are different. I could merely copy and paste and just change the word car to truck, and I could be on my way, right? Well, if I do that, I got a couple of potential problems. First of all, it violates one of our rules to never write the same code twice, and worse, never to copy and paste code, right? But let's suppose we actually typed it in. It's not just a matter of having twice as much code to maintain, although that certainly will be the case. If we copy and paste the code and it's buggy, then we're going to need to fix the problem in 2 or more places. Or if we rewrite the code from scratch, that's essentially performing the same logic. However, we weren't careful and the logic is inconsistent, then we'll need to fix the logic in 1 or more places. And so from experience, I can tell you that that's a bad situation. Second, our application might need to deal with both car objects and truck objects. Will we have to create 2 versions of every single method that accepts car as an input parameter? I mean, look at this. If I had to create a second one of these helper methods that only dealt with trucks, because I've got a car class and I've got a truck class, and now I got to create, and now I create one for motorcycle, and I create one for boat, and I create one for semi-truck, and I create one for submarine. I don't know. Now I've got all these helper methods that are so, specific to one type. There's got to be a better way than that, right? So that'll quickly become unwieldy, again, if we need to add different types like motorcycles or other motorized vehicles. So ideally, we could merely borrow the things about a car that make sense, and then override the parts of the car class that don't make sense for a truck or a motorcycle or whatever the case might be. Things that cars don't really need, like the bed size and the towing capacity and other truck type of things, okay? But we can do this by creating a truck class and then making it inherit from the car, and then adding the properties and methods that specialize the truck. Now, because a truck is different than a car in some small ways, at least in our application, then I'm going to specialize the truck class by adding another property. So here's what we're going to do. let's go outside of the car class, right here, and we're going to create a new class called truck, and then I'm going to use the colon, and then use the word car. That says I'm going to inherit from the car, and now I'm going to use prop tab int towing capacity. Enter, enter. Awesome. Okay, now let's go up here to the very top, right before the read line, and we'll create a new instance of this truck. So truck, my truck, equals new truck. And then I'm going to go my truck dot. Now I want you to notice this in IntelliSense, what you see here. Because truck inherits all the properties and methods of the car, color, make, model, towing capacity, or I'm sorry, year, and our format me method, they all appear as available to the truck. All right? And so, and then also the towing capacity, the new property I added just to the truck, appears here as well. It's awesome. So let's go ahead and finish this code example out by giving the truck some details. So let's set its make equal to the Ford. Let's set my truck dot model equal to an F950. My truck dot year equals a 2006. My truck dot color equals black. My truck dot towing capacity equals 1,200 towing units. I don't know. I don't know what a towing capacity unit is. All right, but so we can access the towing capacity property from the truck. What if I try to access it from my car? Oh, it doesn't exist, at least in IntelliSense. Towing capacity equals 1,200, and I'm going to get the red squiggly line. It says it doesn't contain the car doesn't contain a definition for towing capacity. All right, so can't do that. All right, so specialization means that we get all the features of the car, and we add key features that are unique to the truck. They're not available to the car, only available to the specialized version of the car named truck. All right, so there's a bunch of benefits to inheritance. The most obvious is that you can save a lot of code, right? I mean, all we had to do was just say we're going to inherit from the car, and then we're just going to add one property to it, like so, right? So another one that's not so obvious is that anywhere a car would work, like as an input parameter to a method, truck will work as well. So let's do this. Let's call our print car details, and I'm going to pass in my truck. All right, so let's start running the application. And so you can see that here are the car's details with a BMW, but here's the car's details the second time. It has the Ford F950 Black 2006. All right, so how is this even possible? It's only possible because truck is a type of car. And there's quite a bit of different terminology that I could use between a type of or a version of type syntax to describe that relationship now between the truck and the car. For example, the car class is referred to as the base class, and the truck is referred to as the derived class. Or you might see the terminology that says the car class is the parent class and the truck is the child class. Or you might see the terminology used like this: the car class is the superclass and the truck is the subclass. All of those terminology usages work, and you'll see them commonly throughout writings depending on who's doing the writing and what terminology they prefer. But they all mean basically the same thing, okay? So how does this apply to the .NET Framework class library or the .NET Base class library? Well, our purpose in this lesson, again, is to explain how the .NET Framework class library, the base class library, is just one massive collection of all these base and derived classes. Why? Because it creates this flexible way of working with classes in the framework. One example, and there are many similar examples available, but just picking one, what I want to do is pick on the stream reader class that we saw from the Read Text File WoW project back in lesson number 11, I think. So the stream reader class utilizes functionality that's defined in the file stream class because stream reader derives from file stream. So let's do this. Let's open up Internet Explorer, and I want to go to a page on MSDN. And so every single class in the .NET Framework class library, in the base class library, it gets its own page on MSDN, and it tells us things about that class. Its inheritance hierarchy, which we'll come back to in just a moment, the syntax used to define it so that you can see how it's defined, all of its constructors, its properties, its methods, all right? Things we've already learned about, right? Previously up to this point. Well, that's the file stream class right there. And some remarks, some example code, how to call the file stream class, and other related information. All right. And so as you're looking at this, you can see that we're on msdn.microsoft.com. It's Microsoft's developer network. It stands for the Microsoft Developer Network, which contains many resources for developers. Most importantly for our purposes, it contains a page describing each class in the .NET Framework class library in the standardized format that I just pointed out a moment ago, including a brief explanation of the purpose of the class, along with its inheritance samples and so on. All right. So we see here that the file stream has this inheritance hierarchy here prominently displayed on the page. You can see what a given class derives from, as well as what derives from it. And you can see that it goes back several generations, if you will. So in this case, file stream inherits from system.io.stream. And if we go back far enough, we can see that it inherits from system.object. In fact, every class in the .NET Framework class library ultimately derives from system.object. So if I click on the link to investigate the system.io.stream, as you can see, the stream class provides a generic view of a sequence of bytes. And then it says also that it's an abstract class. So now whenever we're working with the stream reader, we're working with a sequence of bytes that were stored in a file. And if we were to click the More right here, we can see at the very bottom of this page all the classes that derive from or are children of the system.io.stream class. And so we see our file stream class down here, but it has a number of siblings. Each of these derive from the same base class, system.io.stream. In other words, they all work with streams of bytes, even though how they work with those bytes might be dramatically different. Some will work with streams of bytes in database data like Oracle or SQL Server. Some will work with zipped files, so bytes that are stored in zip files. Some with bytes that are streamed over the internet, and much more. You can see just the names that they kind of lead you to understand what those particular classes are used for. So what I understand when I look at all this is that these classes will help you work with bytes of data. They're all similar in how they work because they all derive from the same parent, the system.io.stream class. But the way that they work internally and what they do for you is just a little bit different. So from a practical standpoint, once you learn about how streams work in general, you can expect similar behavior as a user of these various stream classes that you see here. So instead of just memorizing the specifics about each class, you can kind of fumble your way around by associating the things you know about stream classes already to a new usage of a new stream-based class that you see in this list. All right, so inheritance is a core concept in the .NET Framework class library, and it helps those who are consuming the library to get their head around some of the inner workings of similar but different classes, right? All right, so let's move on. Let's go ahead and close this down. Actually, I'll just minimize it for now. So as you can see in my format method right here, in my car class, suppose there's something different about the format me method that simply won't work for trucks. After all, at the moment, its formatting is geared specifically towards cars. There's no understanding of the concept of towing capacity, for example. All right, and we want that whenever we want it printed to screen. So this simply won't work for trucks. After all, at the moment, it's just formatting for cars. So not to worry. What you can do is override the implementation of this format me method by using the override keyword in the derived class, or rather the child class, our truck class in this case, and then using that same method name and signature like so. So let me just go ahead and copy all this. And I'm going to paste it here. I know, copy and paste is bad. Don't use my own words against me here. All right, so let's remove this, and we're going to call this towing units. And then instead of this.color and this.year, we'll change this up to be this.towing capacity, like so. All right. So we're not done at this moment. We actually have two other things we need to do. First of all, we need to say that we want to override this format me method. We want to override the default implementation of format me, number one. And then secondly, to make this work, we're going to need to add the virtual keyword to the car class's format me method declaration. So here we'll go public virtual string format me. So virtual means, hey, if you want to override me, go ahead. I'm fine with that. And if you don't, that's fine too. I've got a basic implementation for you that you can already use. But if you need a specialized version, well, just go ahead and do your own, okay? Which is exactly what we've done here with the override keyword. So virtual says, go ahead, if you want to override me, you can, but you can also just rely on this base implementation. And then the override says, yeah, I'll take you up on that. I want a different version of format me for my own purposes, okay? So now when you run the application, you're going to see the result of two different implementations. Here in the second listing, or the second item, we see the 1,200 towing units now formatted correctly. Great. Okay, let's move on from there. So we can also change the declaration from this virtual keyword to this abstract keyword, which means you must change it. So you're saying, hey, if you want to derive from me, that's cool, but you have to change this method to suit your needs. I'm not going to support anything that you come up with. You got to do it on your own, all right? So now using abstract is not appropriate in this particular context because we still need to define an implementation for the car class itself. But that does bring up a bigger issue. I mean, maybe we shouldn't derive a truck specifically from car. That might make sense in some applications, but in our case, maybe instead it might make sense for both car and truck to derive from a base class at a higher level. So maybe we can rework our code so that they both inherit from a special kind of class, what we're going to call an abstract base class. Okay, so in this case, simply deriving from car might not be quite the right option for the truck class. Some properties and methods available in car might not be applicable to the truck, but we still get those anyway, all right? So admittedly, in this simple example, it really shouldn't matter. But what if we had a more complex scenario? There might be some things about the car that doesn't apply to the truck, all right? So that's what we're trying to work around. So in these cases, the best thing that you can do is just back up a little bit and create a special type of base class called an abstract base class. The difference between a regular base class, like we've demonstrated so far, and an abstract base class is that you cannot create an instance of an abstract base class. The only way that it becomes useful is when there's a concrete version of the class created. This is exactly how the stream class that we just looked at worked. Back in MSDN, scroll up here to the top. Oh yeah, here we go. Notice that I kind of passed over this quickly, but this is an abstract class. So stream is an abstract class. Furthermore, if you continue on and you look at its properties, you will see each of the descriptions for those properties begin with the words when overridden in a derived class. So in this case, a stream is just a concept, and the way that it's defined, it's simply a template. Not something that you create an instance of, but something that you embrace and extend. I don't know if I can use that phrase. It's something that you actually say, I want to be like that, but here's my implementation of it, okay? So if we then scroll down, however, and we look at all of those classes that inherit from system.io.stream, we can see again here, file stream, if we go there, the file stream is concrete in so much that it's an implementation of the stream abstract base class. Just a pattern saying, I promise I'm following, I'm inheriting from that abstract base class. I get all of its functionality, but you can't just create an instance of stream. Stream is meaningless, it's just a concept. But a file stream is something concrete that you can actually do something meaningful with. Okay, that's all we're trying to say here. In the example that we've been using up until now, we might choose to create a vehicle abstract base class and then have both the car and the truck and even other vehicles in the future, such as a motorcycle, boat class, or whatever the case might be, inherit from that vehicle abstract base class. So introducing a new abstract base class is going to cause ripples throughout our entire code base that we've created up until this point. So let's take a few moments and work our way through some of these ripples. So I'm going to start here by creating a new abstract class vehicle. I'm going to take all these properties. I'm going to give them the vehicle. Okay, when you do this, notice you're going to break a lot of stuff. We'll fix it all before we're done, okay? And now I'm also going to create a public abstract string format me. Where's the implementation of format me? It doesn't have an implementation. Again, you can't create an instance of an abstract base class vehicle, but we can say you have to have an implementation of format me whenever you derive from vehicle. Okay, let's move on. Now, car is going to derive from vehicle. And let's see, everything else looks good there. Awesome. Let's move on to truck. Truck no longer implements car, it's going to implement vehicle. It also has a towing capacity. It also has public override string. That reminds me, I'm going to need to change this from abstract to override now, right? Because the abstract format me has already been defined here. Now we're just overriding. All right, so now let's go back up here to the top. Notice that we have a problem with one of our lines of code. The print car details, where we pass in the version that passes in my truck, it no longer seems to work. When I hover my mouse cursor over it, it says the best overloaded method match for print car details has some invalid arguments. Why is that the case? Because truck is no longer a type of car. Truck is a type of vehicle. Car is a type of vehicle. So what are we going to have to do to make this work? Well, the semantics of the relationship have changed from parent-child to sibling, and so to make this work, what we're going to need to do, first of all, is we're going to need to change this from car to vehicle. And I think that at this point, we're going to need to change the name of this because it's denoting that it's only working with cars, and that's not true anymore. So let's change this to print vehicle details. Of course, that's going to break everything now that used to call the car version, so we're going to need to change that in a couple spots too. I was going to show you another feature, but I already went past it. Never mind. Okay, great. All right, finally, I see I have one more problem in my code. I used to refer to the input parameter called car, but now I'm going to have to change that because the input parameter's name is now vehicle. Whew. Also, in the string that's going to print out the details, I'm going to need to change this from saying cars details to the vehicles details, just to make it semantically correct. All right, so now when I run the application, I see here are the vehicles details, BMW, second one is Ford. We're great. Okay, so hopefully you understand why we did that and what the purpose of the abstract base class is. First of all, the abstract base class allows us to say you have to implement these things, and here's even implementation of some properties, and here's some methods that you need to go off and create yourself. So it creates a pattern for us in a sense that we have to then implement in any of the derived classes. And the reason why we want to do that is so that now we can use that vehicle class and create more derived versions of that class, motorcycle, boat, whatever the case might, ski-doo, okay? And yet they'll also work as long as we implement that format me method. Okay, great. Let's move on. So the antithesis, the opposite of the abstract base class is a sealed class, meaning that you cannot inherit from it at all. All right? So you might never want another class to be able to inherit from your class. And so what we can do is mark it as sealed. So in this case, we're going to call this class truck a sealed class truck. Now, nobody can ever, not me, not anybody else, can ever create a new type of truck. So let's say, for example, in the future, I come in here and I want to create a semi. And I'm going to say it's of type truck. And here we go. We're going to specialize truck with something called a semi. We'll give it the number of wheels, like 18, and so forth. But when I try to go and build the solution, I'm going to get an exception. Cannot derive from the sealed type, understanding inheritance truck. All right? Now, why you might want to do that is because you don't want anything to be able to create new versions. You don't want that inheritance tree to go on and on. You want to stop it right there. The reasons why you might want to do that may not be clear at this point. I'm just showing you the tactic, the technique for doing this. The reasons why are going to get back into some of the things that we talked about in our previous lesson with regards to a larger understanding of object-oriented programming. For our purposes, just know that there are sealed classes defined in the .NET Framework class library, and that's why you won't be able to create your own versions of those classes. Okay? So when you work with classes in the .NET Framework class library, be aware that almost every class is part of an inheritance hierarchy. If a class has a method or properties which are not readily apparent, it might be because it's inheriting the method or the properties from a base class or even an abstract base class. You might learn a lot about a given feature of the Framework class library if you simply stop, take a moment to understand a little bit more about its parents or its siblings or even its children that inherit from it. Oh, I'm not supposed to use this class. It's merely a base class for all these other specific implementations. Silly me. Okay? So you can certainly utilize inheritance in your own projects, but frankly, that might be down the road a little bit for you from this point. If this is indeed your first attempt at learning how to program, regardless of the programming language. However, perhaps you'll work on a large project in the future where it makes sense to create some library of business rules and logic that can be applied and shared across the entire application or a family of software applications. In those cases, you'll undoubtedly be in need of a good inheritance strategy. And again, there are good design patterns for properly utilizing inheritance in your application designs, but for now your focus is probably going to be consuming and utilizing libraries that were created by others, like the .NET Framework class library. The other takeaway from this is that there are a number of C# classes and method modifiers that the creators of the Framework class library have used in an effort to guide you whenever you're trying to consume their classes. And by that I mean that they create abstract base classes or sealed classes or even use other modifiers in an effort to help nudge you, the consumer of those classes, in the right direction and prevent you from doing something that would break those classes or use them in an unintended way. All right, that's one of the reasons for the sealed keyword, just so you know. So it forces you to use them in the way that they were intended to be used. It's just a matter of realizing, oh, I can't create an instance of it because it's marked as static, okay? Or, oh, I can't derive from this class because it's marked as sealed, right? So once you understand a few of those key terms and you look them up on MSDN and you're able to interpret whatever MSDN has to say about it, and you understand what you're supposed to do with a given class in the Framework class library, or what your options are, then things will start clicking for you. You'll start being able to understand how to really utilize everything that the Framework class library offers you. Okay? So you're doing great. This is meaty stuff. Don't let anybody fool you. Getting your head wrapped around it is a challenge, but you can do it and you're doing great. As long as you understand the basic concepts here, we'll keep building on those in the next lessons, and we'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at some of the world's best companies as quickly as possible. I've spent quite a bit of time in the past few lessons talking about classes because they're so integral to .NET. In fact, just about everything you do in .NET somehow involves a class. And we talked about the .NET Framework Class Library, which is just a collection of classes that contains functionality that you can use, but you don't have to worry about writing yourself. You didn't have to create any of that. Microsoft already spent tens of thousands of man-hours writing code, and you can just borrow it. And that was really the purpose of learning more about inheritance in the previous lesson. We said that Microsoft has created the classes in such a way that there's this rich inheritance hierarchy. It's a means of specializing and extending base classes. In some cases, it's beneficial to Microsoft because this allows for code reuse and ease of maintenance. In other cases, it's more beneficial to the end users, you and I, because we can leverage knowledge about, for example, how streams work to all types of specialized stream-based classes for working with file data, network data, database data, and so on. So the .NET Framework Class Library is composed of a rich set of inheritance between the classes. But because I really want you to understand how the .NET Framework Class Library was put together and how it works, and most of all, how you can get the most out of it, I want to talk about one final topic related to all this, and that has to do with understanding how code is organized and how to access some code that isn't just added to your project by default. So we're going to talk about namespaces, and we're going to talk about assemblies, and we're going to talk about adding references to external assemblies using the Visual Studio IDE. So what we want to do is create a new project, and it's going to be called Namespaces and Referencing Assemblies. It's kind of a long one. Right. So first of all, within the .NET Framework Base Class Library, or the .NET Framework Class Library, all the classes are organized into namespaces. And you think of a namespace as a last name for classes. So my first name is Bob, but there are literally hundreds, if not thousands of Bobs in the small town that I live in. If somebody were to say, Bob likes coffee. Well, you might ask, okay, but which Bob? There's probably like 10 million Bobs in the world. If they reply with my full name, Robert Theron Tabor, that Robert Theron Tabor likes coffee, well, now you should have a pretty good idea of who they're talking about. I'm pretty sure that the uniqueness of my middle name in combination with my first name and last name are pretty unique, so that might only identify one person in the entire world. The same is true with classes in the .NET Framework Class Library. With tens of thousands of classes in the library, it's possible that a single name is shared by more than one class. However, by using the namespace of the class, it removes the ambiguity. While you might know which version of the class you intended, the C# compiler, as it tries to make sense of your code and tries to create an executable file from all the code that you've written, it tries to resolve any references to the classes that you've used or you've referred to within your code. And we saw that a few lessons ago when I typed in the word stream reader, the Visual Studio IDE let us know that it didn't recognize the class name at all. So when the compiler is confused, it stops immediately. It forces you to explain further what you meant, and we call that a compilation error. So if I wanted to reference the stream reader class, I could do this by using its full name. So system.io.streamreader, my stream reader equals new. And so I could do it like that. So system, as you can see here, its full name, system.io.streamreader. The system part is a top-level namespace that many other namespaces and classes belong to. Secondly then, after system, there's the IO namespace, and it contains other namespaces and classes that deal with in and out, or rather getting data into and presenting data out from, or sending data out of the application. And then third, we see the name stream reader, which is actually the name of the class. So the system.io namespace illustrates that namespaces can, and often do, contain other namespaces. You can use any number of namespaces to keep classes organized and avoid naming collisions. However, the developers at the .NET Framework Class Library realized that too deep of a nesting structure would add complexity. So if you're ever in a position to create libraries of functionality specific to the company that you work for, you want to strive to use as few as necessary in order to help those consuming your code. Again, the creators of the .NET Framework class library try to keep it at 2 namespaces, then a class name. Occasionally that extends to 3 namespaces and then a class name. But they try to keep it pretty short overall. So you're looking at this and you might say to yourself, well, wow, that's one really long line of code. I mean, we were able to do it much more succinctly before, right? So how am I supposed to, first of all, memorize all of this? Well, while IntelliSense helps initially, most developers use a simplification. In fact, you've been using this and you may not have already realized it, and that is the using statement. So most developers rely on using statements to shorten the amount of code that they have to write. A using statement provides access to all of the namespaces and classes that belong to it so that you don't have to type it all out. So you're telling the compiler, hey, I'm using these namespaces, so before you complain and tell me that you can't find a given class name, please check these namespaces first, all right, the ones with the using statements are at the very top of this code file, to ensure that the class that I'm referencing in my code belongs to one of them. If you don't see it in there, then you can complain. So that's what we're telling the compiler by using those using statements there at the very top. So notice that there are this set of using statements were added by default whenever we created our project. The project template that we chose, the console application, adds these as a convenience so that you don't have to add them yourself. Now you could remove the using statements that you know you're not going to need. Like for example, I may know for this particular application I don't need system.collections.generic. I could remove that and there would be no harm done to my application. But honestly, there's no real reason to remove them as far as the compiler is concerned. It'll compile the code the same regardless of whether or not there are extra unused using statements. Some developers prefer to keep this list tidy so that they know when they're looking at the code exactly what's going on. So removing unused using statements helps them comprehend the code a little bit better, and so that's usually the course that many professional developers take. You can decide for yourself if that's something you prefer to do once you get more experience. For our purposes in these tiny little applications, it doesn't matter one way or the other. But when we're maintaining a larger code base and we want to be expressive in the code that we're writing, then we might take more time to manicure those using statements at the top of every file. All right, so let's do this. Let's comment out this line of code. We've taken this next step before, but I just want to revisit it in the context of this conversation. So we want to create stream reader, my stream reader equals new stream stream reader, like so. And the IDE lets us know that it's not able to resolve the name stream reader because we haven't referenced its full name. So we see those little red squiggly lines under the word stream reader. And you know, we've noticed this before. Whenever I put my mouse cursor on that line of code, there's a little glimmer of hope. A blue dash appears underneath the letter S in Stream Reader, and that means a contextual menu is available. And so there's a couple of ways to invoke this contextual menu. The long ways that I could hover my mouse cursor over that little blue dash, it opens up a little contextual menu glyph, and then when I click down on the down arrow, it actually opens up the menu for me. And you've seen me perform this technique the last time that we attempted to work with the Stream Reader back in lesson 11 or 12. Now, the more convenient way to resolve this namespace is to use a keyboard-only shortcut that most professional developers prefer. And so using the mouse technique, once you hover over that blue dash, the context menu appears. The very first option is using system.io. If it's not already highlighted, you can use your down and up arrows to actually then press the enter key on the keyboard. So you can see what it did here. It actually added that system.io. But I'm going to remove that, and we're going to take the other tact, which is to actually use the control key on the keyboard and the period, and that will open up the menu as well. So your hands don't have to leave the keyboard. You just can hit control period on the keyboard, and it pops open that little menu, and then I can just choose the up and down arrows, use the enter key on my keyboard, and it accomplishes the exact same thing. Okay. So the Control plus period is a better approach because your hands, again, don't have to leave the keyboard. It allows you to stay in flow and continue to work without having to move context back and forth between mouse and keyboard. Okay, so occasionally whenever you attempt to use a class in the framework class library, you'll get an error that says something about there being ambiguity. The reason is that you have two using statements that both happen to have a class with the name that you're trying to use. So in that case, where you have two using statements, and both of those using statements have a class that shares the same name, then when you try to use that class name, you'll get the ambiguity error. What you'll merely have to do in that case is use the full name for the class that you're trying to reference, like we've done here. All right, and that will get your code working again. So one last tip, if you need to look for help on a given class name or a method name, sometimes when you search, you might want to add the entire namespace, like what I have highlighted here. Otherwise, you might be looking at the help for a different version of the class that belongs to another namespace. I've made that mistake before. All right, so before we close this discussion of namespaces, let me point out three basic things. First, every class that you write, whether it's part of the program.cs file or a custom class file or in an ASP.NET web page or a Windows form, it'll all be contained within a namespace. Now, we've glossed over the namespace declaration in the file that we're working with until now. Like, for example, in this project, it's namespaces and referencing assemblies. Where did I hear that namespace name before? Oh yeah, it's the name of the project that we typed in ourselves when we created a new project. So the default namespace will be the name of your project. For simple applications, you may never need to modify or add additional namespaces. Secondly, you can set the default namespace in the project's properties if you want to change what that default namespace is. So what you can do is just right-click on the project name and select the Properties option at the very bottom. And then you can see here on the Application tab on the left, there is a text box called Default Namespace where you can see by default it's set to the name of our project. And so the technique is easy. The reason why you'd want to choose to change it from the default is a little bit more advanced. So for the sake of keeping this topic simple, I'm just going to encourage you to revisit this idea after you're more experienced in software development and you're thinking about things like solutions that have multiple projects, the purpose for each project in the solution leading to a larger application architecture. Okay, those are not things we're going to talk about in this series, but they're definitely pertinent whenever you get out and you're building applications, larger scale applications in larger companies, and that's something that will have to be dealt with a little bit later. All right, and then the third thing that I want to say before we leave the topic of namespaces is that you can create new namespaces for your own code. Again, the technique is really simple, but the reasons why you might choose this are maybe a little bit more advanced from where we're at right now. Again, if you set out to build a large software application and you want to organize your code into namespaces, or organize your code, you'll want to do it using namespaces, and it'll become important to you at that point. We don't want to talk about it for now. Okay, but what we do want to talk about is the next important topic related to code organization, and that is, in an effort to keep the .NET Framework class library manageable, the developers broke up all those tens of thousands of classes of code into a few dozen actual files, DLL files. Now, if you had to load one monstrous library of code up in memory every time your application ran, most of these classes, tens of thousands of classes, you're never even going to use in your application, never even going to reference. Then each time you ran a .NET application, it would take up the entire computer's memory, and it would be extremely slow, and they didn't want to do that. So instead, they put related functionality across many different namespaces into a few dozen .NET assemblies, a few of these DLL files. So when you create a new project, the template for that project includes several references. Here we can see them right here. Several references to core assemblies by default. So for example, if I wanted to create a WPF or Windows Presentation Foundation application, and I chose the WPF application template whenever I went file new project and saw the new project dialog in Visual Studio, the template would add references to several important assemblies that are required in order to build WPF applications. So as you can see, I've expanded out that references entry here in the Solution Explorer to see which assemblies have been added by our console application project. And then if you were to click on one of these, for example, just System, you can see in, in the Path property here, and we'll have to expand this out a little bit. Oh, we're going to have to expand it out a lot, aren't we? Oh my goodness. Okay, here we go. Let's hover over it. You can see where that particular assembly is stored. It's stored in this program files x86 reference assemblies, Microsoft Framework, .NET Framework v4.5, system.dll. Okay, and let's take a look at system.core, and it's in that same folder in the system.core.dll file. All right, so you can see where those assemblies live on your hard drive if you want to. So what happens whenever you realize that you need a part of the .NET Framework class library that has not already been added to your project? Simple. You just have to add a reference to that assembly. In fact, this isn't only true for assemblies that were created by Microsoft and are part of the .NET Framework class library, but it's also true of third-party assemblies that you want to use in your applications, whether they're commercial products that you've purchased from some third-party vendor, or they're open-source libraries that you download from, from some source online, or even libraries of business rules that are specific to your company or organization that one of the developers in the next cubicle created. You have to first add a reference to the assembly in the project so that when you reference the namespace and the class name in your code, like we just looked at here, it'll know, the C# compiler will know which files to look in for the actual code implementation. So since I want to keep this example as simple as possible, I've created a very, very, very simple library of my own. It's simply called Tabor, and it's in the file called tabor.dll. And my Tabor class has a single class called Bob, the Bob class, in the Tabor namespace. All right? And so my Bob class has a single method called lookup, which accepts an input parameter of type string that represents a URL from a website, any website you can give it. And then the lookup method will pull down all of the HTML from online for that given web page from that URL. So you can find the tabor.dll file that I created and I distributed with these lessons in a zip file that accompanies this lesson, lesson number 18. And so I've already, if you look in my documents directory, I've unzipped that particular zip file into a directory called lesson 18, and I've already got that tabor.dll file on my hard drive. So make sure that you have unzipped it someplace where you can get to it if you're trying to follow along in this lesson. The documents directory is fine, to your C drive is fine, whatever you feel comfortable with, okay? So now that we've located it, as I was saying earlier, to actually use that assembly, the code that I wrote and I've distributed in my own project now, I have to reference that assembly from within my project. So there's a couple of different ways to accomplish this, but for now I'm just going to, let's close that down, close that up. What I'm going to do is I'm going to right-click the project name in the Solution Explorer, and I'm going to click Add, and over here in the submenu I'm going to select Reference. All right, and that'll pop open the Reference Manager dialog. And so notice that there's some tabs along the left-hand side that change the types of assemblies that are displayed there in the main pane. So for example, by default you're going to see all the assemblies that are available from the .NET Framework class library here. And you can see little check marks next to the ones that are already part of a project. Cool. All right, so since we're referencing a custom assembly that's in the Documents directory, what I'm going to do is click the little Browse here, and it says there's no items found. So I'll click the Browse button at the very bottom of the dialog, and this will pop open another dialog that allows us to select the files to reference. So on the left-hand side, I'm going to look for my Documents directory. There you are. And the Lesson 18 subfolder. There you are. And here's that tabor.dll file that we're looking for. I'm going to make sure to select it and then click Add. And now you can see that it is selected here inside of my Reference Manager dialog, and I'm going to click the OK button. And now if you take a look at our at the Solution Explorer and go to the very bottom, you can see that we have added a reference to the tabor.dll file that was out on our Documents directory. Great. So now that I'm referencing that assembly, I want to use the features of the Tabor assembly, the Tabor.bob class, and I'm going to write the following code like so. Here, let me comment this out, and we'll start afresh below it. Here we go. So Bob, oh, can't find Bob. I'm going to hit Control period on my keyboard, and see, it found it using Tabor. I'm going to add that using statement. Now I can do the following. Bob equals new Bob. That's an odd thing to say. So string HTML equals bob.lookup. See, I have one method there. I'm going to give it a URL. So I'm going to give it a URL to my own website, http://www.learnvisualstudio.net. And then what we're going to do is console.writeLine. And I'm going to give it the HTML string. And then console.readLine. All right, and that's all we'll need to do. And so now what I want to do is go ahead and run the application. Cross my fingers, hope it works. Awesome, it worked. So if I were to scroll up in this window, you can see there's so much content here on that home page that it didn't really easily fit in one viewing, so you have to scroll up and down. But there's just HTML there from the home page of my website. Very cool. And I'll just go ahead and enter to exit that. Great. So now what we want to do is actually open up Windows Explorer, and I want to see what actually happened in the bin/debug directory of my project. So let's go to Documents, Visual Studio 2013, Projects. I'm going to look for the namespaces and referencing assemblies, Solution folder. Then I'm going to look for the Project folder, and then I'm going to look for the Bin folder, and then I'm going to look for the Debug folder. All right. So here we can see that we have our actual application, the .exe assembly, .NET assembly. And then there's a bunch of files that we noted before that are used for Visual Studio, syncing up, debugging features, all that good stuff. But here also we see the tabor.dll file that's added as a result. You can see that the assembly is copied to my output directory, in this case, bin.debug, which I'm going to need to distribute with my app whenever it's put on somebody else's computer. So you might be wondering, well, then why don't I need to distribute? Why didn't it put all the other assemblies in here from the .NET Framework? That's because in order for somebody to use your application, say you wanted to create a release version of your application, they already need the .NET Framework installed on their computer, and they need it updated to the version that you're using and that you compiled against when you went to build your solution, build your file, your assembly. Okay, so they already have it on their computer. It's just going to reference it in a common place on the computer called either the global assembly cache or in a specific location to the .NET Framework. The .NET Framework will find the files that it needs, that it knows it needs, that it's familiar with, that were packaged with it. Okay, so you don't have to worry about that. Just any custom assemblies like the tabor.dll need to be then distributed with your application. All right, I realize that I just kind of brushed through that last part. It's not all that pertinent for now. It just works. Okay, as long as somebody has the .NET Framework class library and the .NET Framework installed, the runtime installed on their computer. Okay, so we learned in this lesson how classes are organized into namespaces to help disambiguate class names, or rather how to avoid naming collisions between two classes that have the same name but are in two different namespaces. So we talked about the using statement that allows us to shorten the full name of the class, namespace, namespace, namespace class, to just using the class name, and it basically, the using statement just tells the compiler that it should first attempt to resolve all class names against those namespaces that we've added into the using statements at the very top of our code file. I also demonstrated how to use the IDE to help find namespaces for classes that we want to use within our application. The little helper menu where you hover over it, and then also the control period technique that I demonstrated helps you get to create those using statements automatically. We talked about the topic of how code is packaged into assemblies, and that when you create a new project from a new template, part of the job of the template is to add references to commonly used assemblies. The .NET Framework class library is so large that it wouldn't make sense to add a reference to every single namespace and class all at once. However, if you need something from the library, you may need to add a reference to an external assembly. So additionally, many companies have created their own libraries of code that you may need to use if you go to work for them that encapsulate all the business logic necessary for a given area of their business. Also, there are third-party vendors as well as open source projects that provide libraries that you might want to use within your application. So in these cases, you have to add a reference to the assembly that contains the given library of code that you want to utilize. And then you can go ahead and use it within your app. Okay, so next up we're going to talk about those mysterious words, private and public, that keep popping up. We've ignored them until now, but we're going to discuss what they are in the very next lesson, so we'll see you there. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. We haven't spent much time talking about scope with regards to variables. So I want to more fully explain that concept and then use that as a launching pad to explain the keywords public and private that you've seen several times in relations to writing methods inside of classes. What do those keywords do? We're going to talk about that in this lesson. Before we jump into that topic, like I said, let's talk about variable scope. So let me start by saying that whenever you declare a variable in a block of code, that variable is only alive for the life of that code block, meaning that when the code block is finished executing, the variable that was defined inside of that code block is no longer accessible, and its values are disposed of by the .NET Framework runtime. So let's see how that applies to the common code blocks that we've worked with up until this point, and then we'll expand beyond that. All right, so let's create a new project, and we're going to call this one Understanding Scope. To begin testing how variable scope works, I want to begin with a simple code example. And so, again, the concepts that we talk about in this lesson also apply to object references, object variables, like we've seen in the last few lessons. So any variable, whether it is a simple type, like what we'll use here, or a variable that holds a reference to an object, this still applies, just to make you aware of that. Okay, so here we go. Let's start simple. All right, and so if we start debugging this simple application, you should see the results 0 through 9 printed screen. There's no surprises here, right? Okay. So now what I want to do though is just test the boundaries of this variable I. It was defined here at the beginning of the for loop. Can we reference I outside of the for loop, outside of the code block where we created it? So let's try to console write line the last value of I, and already you can see that I'm fighting IntelliSense. When I try to type in the letter I, it wants to autocomplete to something else. That's your first sign that Visual Studio is not going to cooperate. All right, so and therefore it's really attempting to insert what it hopes would be the next logical identifier or keyword in that line of code. So I have to go back, as you saw me do, and attempt to edit this manually to force it to take the variable name I. And as you can see, there's a blue line and a red squiggly, all kinds of things Visual Studio is pointing to. And if I hover my mouse cursor over the red squiggly portion, it says the name I doesn't exist in the current context. All right. So it offers me a few other options. I can generate a property stub for I, or I can generate a field stub. I'll hit escape on my keyboard. So I just want to use the variable I. I just want to get to it. I mean, we're using it here. Why can't it work? Well, I try to run the application, get a compile time error. Obviously, it's not going to happen. All right. So what's the problem? Well, the problem is that the variable I is defined in the for iteration statements code block. Outside of that code block, I can no longer access I because it doesn't exist any longer. So I want to comment out that little test, like so, and move on to the next one, all right? And so let's go outside of the for loop code block, and I'm going to add a new variable j, and I'll initialize string j equal an empty string. And then what I'll do inside of the for loop is I'm going to set j equals i.toString, like so, and I'm just going to leave everything else the way that it is, but below it, I'm going to go console.writeLine, and I'm just going to set outside of the for, and I'm going to use a new string concatenation character, just the plus symbol instead of the string formatting. Could have used it, just wanted to show you a different way to go about it, that's all. All right, so let's see if this works. And so you can see we get 0 through 9 in the for loop, and then the very next thing we get is outside of the for loop, the value of j is 9 because the last set of j was to the last iteration of I, okay, and that's why we get it. But more importantly, we see that since the variable j is defined outside of the for iteration statement's code block, not only is it accessible inside of the inner code block, but it's also accessible outside of that as well with whatever value was assigned to inside of the code block. Okay, so I'm going to do this. I'm going to go outside of static void main, and I'm going to go private static string k equals empty string. All right, so before I go any further, I've never demonstrated this before. When you declare a variable at this level as a child to the class itself, you're creating a field. Fields are like properties, but they have a subtle difference. I briefly mentioned the difference between getters and setters and how an advanced version of properties you're able to write your own code that kind of becomes the gatekeeper for the setting and getting procedure. All right, I mentioned it very briefly. Don't worry if you don't understand that. But the subtle difference between properties and fields is that fields just don't give you that ability. And so up to now, we've been creating those auto-implemented properties. They're basically the same as fields. I mean, we didn't write any getter or setter code to control that operation. So essentially, they're the same. And so I don't want to talk about the subtle differences anymore between fields and properties. It's not really pertinent to this conversation. However, in this case, notice that I'm adorning it with the private keyword because I don't want it to be accessible outside of this class. I'll have more to say about that in just a few moments here. So finally, I also adorn the private field with the keyword static since I plan to use this field inside of the body of my static void main. So remember, a static member is accessible across all instances of the class, and all of the methods, properties, and fields that it utilizes have to be static as well. So that's why I used static, because I plan to use this new field inside of my static void main. All right, so let's go ahead and continue on with this next example. So we have underneath the assignment of j, I'm going to assign k equals i.toString as well. Seems a little pointless, but we're just trying to familiarize ourselves with the scope. And so k, we'll set it the same way like that. All right, so do you suppose that this will work? Will we be able to retrieve or set the value of k and retrieve the value of k since it was defined out here at the class level? Let's go ahead and run our application and see. And it actually does work. We've defined k in the outermost code block at the class level. We were able to see the value of k inside of the inner code blocks, both in the for loop and in the static void main code block as well. All enclosed or child code blocks have access to that variable because it's defined outside of that code, of those code blocks. So to reinforce this idea, let me do one more thing here. I'm going to go right here inside of the for loop, go if I equals 9, then I'm going to create a new variable, string L equals i.toString. All right, fair enough. So now outside of that, let's go console.writeLine. and then we'll just do L like so. All right, and you can already see the red squiggly line under the variable L. The name L does not exist in the current context. All right, so based on what we've seen so far, will the variable L be accessible to that console.writeLine statement? Well, no, because the variable L doesn't exist in the current context. It doesn't exist except inside of this new innermost code block. And if we try to run the application, we'll get that same exception at compilation time. All right, so let's comment out that line of code. And we're also going to comment out this line of code with the value of k. And what I want to do is create a helper method, static void helper method, and all we'll do inside of here is console.writeLine and k from the helper method. Okay, so will this work? K is defined as a sibling inside of the same code block as the helper method, so can we access the value of k from here? Also, I'm going to need to call this, so let's go right here and call helper method, like so. Okay, let's try this. And it actually does work, all right? And it does work because k is defined outside of the code blocks that we're using it in, regardless of which code block, whether main or the helper method. All right, so hopefully, if you've had any confusion or misconceptions about variable scope, we were able to clear it up in this little example. All right, so let's move on now to the bigger topic, which is that of accessibility modifiers, you know, the use of the keywords public and private. Well, in the methods that we've written in previous lessons, we always started with the word public or private. These are called accessibility modifiers, and they're used to implement another tenet of object-oriented programming called encapsulation. In a nutshell, classes should be black boxes, and think of those old-style television sets. Maybe your parents or grandparents, or maybe even you, if you're old as I am, remember having to get up and turn a button to turn on and off the television. And then there might be a dial that you would actually have to get out of your chair to change the channel. There were no remote controls back then. And then another dial on the television set just to adjust the volume. It also had a place to attach an antenna and maybe an electrical cord with a plug on the end that you would plug into the wall. All right, and that was it. Everything else about the television was self-contained. And so as a kid, I was fascinated when my dad would pop off the back of the television to fix something. To this day, it still seems like magic because I absolutely know nothing about the innards of televisions. All I know is the public interface, the button, the two dials, and the fact that you could hook up an antenna, whatever that did, and the fact that you could plug it into the wall, which I suppose supplied electricity to it, okay? Frankly, to use the television, that's all you need, right? The same should be true of classes. All the important behind-the-scenes functionality should be encapsulated behind interfaces like public methods and public properties. The class may have private properties, or rather private fields, as well as private methods that are used to enable all the magic that goes on inside of the class. But the consumer of the class shouldn't have to know anything about the inner workings of the class in order to operate it, okay? All they need to know are what's exposed publicly through the public properties and methods, all right? So in a nutshell, private means that the method can be called by any other method inside of the same class, but not outside of the class. So you use them to create private helper methods, just like we've been doing up until this point. We learned several lessons ago, and we've been using that terminology of a helper method. Essentially, when I use the term helper method, I'm talking about a private method that supplies some additional functionality to those public methods that are exposed then to anybody who needs to work with the class through that method, okay? So a public method is going to be used by outsiders. Private methods are only going to be used by insiders, methods in the same class. All right. So let's do this. I'm going to comment out just about every line of code here that we've got so far, including this, including all of this, all the way down to the read line there, and I'll comment all of this out as well. All right, make sure you do that. Okay, and we'll make some room for ourselves here to start the next part of this lesson. All right, so let's go ahead and then create a new class, and we'll create a car class again since we're familiar with that. And I'm not going to create any properties right now. I'm just going to create two methods: a public void do something, and then a public, private string helper method. And here we're just going to return hello world. And yes, this isn't a very realistic example. You would never need a helper method to just return the words hello world, but we're just focusing on the public and the private nature of these methods. Okay, so here I'm going to do console.writeLine, and I'm going to call the helper method from inside here. All right. Now I want to make this point clear. If this were real code in a real project, I would never ever add a console.writeLine in the body of a class method. That's a responsibility of presentation code, not this car code, which I would call the domain class. Okay, I realize you have absolutely no idea what I'm talking about. Just never do it. I'll explain the reasons for this in the series that I create on application architecture on my own website, www.learnvisualstudio.net, when we talk about layering your applications, giving responsibilities to certain layers of code, and then assigning, delegating those responsibilities to the given classes and methods and such. All right, so let's just move on from there. All right, so then to call this from our static void main, what I'm going to do is car equals new car, and next I'm going to do car dot, and notice that IntelliSense shows the public do something method, but not the private helper method. All right, so already IntelliSense is pointing us away from the usage of helper method because it's private and we can't access it from outside of the class. So in a sense, the consumer of the car class has no idea that the helper method even exists. All it knows is that in order to accomplish its task, it needs to call do something, the do something method. Now I say, in a sense, obviously we as developers can read the source code and we can see the innards of do something, and we can see how it works, how it calls the helper method, and how it works. But if we became the main method and we saw it from the main method's perspective, we wouldn't be able to see how it worked internally. Now, admittedly, this is extremely mundane. It's a simple example that's only real value is to illustrate the notion of encapsulation, hiding the implementation, exposing the interface. All right. Next, I want to talk about the naming convention that I used here. We spoke about this a couple of lessons ago. Whenever something is public, it should start with a capital letter, like the capital D in do something and the capital S in something. All right, and so this is called, it should start off with a capital letter and then use camel case from that point on. So whenever something is private, it should start off with a lowercase letter, like the lowercase h in helper method. Now, this is just a naming convention. Are you free to break this convention? Absolutely. You don't have to pay attention to this, but you might do so at your own peril. Other programmers are going to look at your code and they're going to say, dude, what were you thinking? Okay, it's just an easy way to identify the accessibility of a given method by looking at its naming convention. All right, I would assume that without even having to look at anything to the left, that do something was a public method, and without having to look at anything to the left, I could tell that this was a private method. All right, so the same would be true for variables and things of that nature. Notice that all the variables that we used here earlier, I, J, K, L, all right, they're all lowercase. If I wanted to make something public, I would capitalize the first letter. So again, it's just a naming convention for you to consider, but I highly recommend it. All right, so what's the purpose of this pithy little example that we just developed here below? Well, I really want you to start thinking about primarily using this information with regard to the .NET Framework class library. However, when you build your own custom classes someday, you should strive to expose public methods that give a simple, straightforward, obvious usage for your class while keeping other helper methods and functionality privately tucked away and unavailable to prying eyes. You don't want developers just fiddling around with the innards of your classes and potentially misusing your class. You want to give them a way to use the class properly through the methods that you design. This also removes ambiguity and it makes its usage much clearer as well. So in the .NET Framework class library, methods and properties are exposed using the keyword public. Now, they may also use private methods and fields, but you would never know. They may use other types of accessibility modifiers as well, such as one called protected. And a protected method in a base class is visible only to its derived classes, but to no other classes. Why you'd want to use that, again, that's a topic for another day. Don't want to talk about much about object-oriented programming, the philosophy behind it, but that is the technique or the tactic that you can use to achieve that functionality. So private methods in a base class cannot be seen by its derived classes. So as you can see, the accessibility modifiers like public, private, and protected provide different levels of visibility depending on what the author of the class deemed necessary. So just be aware of this. If you can't access something that you think you should be able to access, it might be because that particular method is hidden on purpose by the designer of the class, okay? So just to recap, we talked in this lesson about variable scope, how variables have a lifetime based on the code block in which they're defined. When the current code block is part of the current scope of execution at runtime, then the variable will be available. When the current scope of execution no longer involves the code block, the variable will no longer be available. And we also talked about accessibility modifiers like public, private, and briefly about protected and how that might impact the way in which we use the .NET Framework class library, and even someday whenever we create our own class libraries. So we want to make sure to hide the implementation details and any private helper methods behind public method interfaces. All right? All right, you're doing great. Hang in there. We're getting close to the end. See you in the next lesson. Thank you. I'm out there with WWW.NET Writing skills they need for software job, building web apps, world as quickly as possible. So in this lesson, I'm going to show you another decision statement, the switch decision statement, and then we're going to talk about enumerations, and then we'll show you how the IDE, which is IDE, helps you use the two conjunction quite nicely. So if you're calling our discussion of the if statement back in lesson 7 or 8, we use a number of if and else if statements. So for example, if user value equals 1, then do this, else if user value equals 2, then do that, else if user value equals 3, and so on. Right? And honestly, that approach is fine. But generally, if you have a lot of potential values, you can write the same intent more succinctly by using the switch statement instead. So in that instance, in that example lesson 7 or 8, we only have 3 cases, but we have 10 cases, or 20 cases to check through, right? We can write something more compact using the switch statement. So let's go ahead and create a project called use the switch. And so I'm going to write a lot of code here, so make sure you follow along. Okay, I'm guessing you probably figure out how this works without me walking through it. However, I'm going to explain a couple aspects in more detail. So let's see the results. So first of all, I'm going to go ahead and type in green lantern, and it returns back to the yellow light. Okay. You'll notice that I typed out most of this. There is a code that helps you create this more easily. You can go switch, tab, and create a space structure for you. And now we can go user value, anything on there, right? Just so you know, so in terms, we're going to evaluate the value of the variable user value that user types in. So we see here's 6 syntax that allows us to evaluate. Again, several possibilities, bad answer, and so on. And then once we match whatever user typed in, we can run a code block after semicolon, and we can call break statement to break out the switch. Once we found the case that applies to our situation, so no additional evaluations are made after that. So what's the difference between the statement and the switch statement? Well, in some situations, you can improve clarity of code, especially when there are many possible values that require evaluation. While the if statement can handle more complex situations, it's generally the purpose we need to evaluate many possible scenarios like what we've done here, right? But here's where the if statement really shines. Okay, so as you can see here, I can create another called complex statement. This just demonstrates the complexity that you can express using the if statement that you cannot accomplish with the switch statement. So here I'm checking for either condition, this is true, this is true, using the or operator. I can here's another or between checking if the specific value or this range of values is true, so I'm going to use chain together multiple conditions and then be able to perform some result like console level message. Okay, so using the switch, this is impossible. But in my opinion, the switch statement is clearly design in this type of scenario where you're evaluating against several known cases that you want to check against. Okay, anyways, move on to enumerations. These will put together. Enumerations are basically a data type that allow only a small list of possible values. So enumerations constrain the data, forcing it to comply to the only one set of possibilities. And in so doing, it makes your code much more reliable. So generally speaking, comparing next strings like I've done here, comparing whatever user types in like that against a string called capital B, A, T, M, A, N is not a very reliable practice. In fact, some call it bad programming practice. So in this example, we have the possibility that the user will type in back in all lowercase letters. Now, in this case, we use the to upper method of the string type in order to ensure that we're comparing two strings, so we have a chance of these two match regardless of where capitalization and user has whatever I have. What about the word green lantern? Is there space between those two words or no space? I suppose we could latch on another thing here like a trim. That will remove any space characters before or after. So I guess I need to replace function to replace all spaces with nothing. Space to remove all the empty spaces from the entire string and compare it against various cases here. The previous defines just too many special cases, and so it's generally again not a programming practice. So this is why the class library, the creators of the library, force you to set property values equal to enumeration. And you see them all over the place, and so that's from current. So let's do this. I'm going to create another project. Let's see what we got here. And we're going to this time console application called enumerations. And we're going to start by showing some enumerations that are available within the framework. So let's say, for example, they want to set foreground color of the console window. So I'm going to type this line code console dot foreground color equals, and notice the space on the keyboard after the equal sign that tells it pops up. It's automatically selecting the console color enumeration. So if I choose this and hit the period after the console color enumeration, it gives me a number of colors that I can choose from. So for example, I can choose dark red. All right. So in this case, you can see that I've been constrained to set foreground color property to a specific data type called console color. And console color only has two options to choose from. You saw that list of colors now that work. All right. So let's see how much we can have their own enumerations.
And I just want to show you this in action. So let's go ahead and start the application, and you can see that I get the text, the foreground color of the text, and that red color. All right, great. So foreground color property is constrained only offer viable colors. I can't just use a little string, dark red, because the foreground color is not of type string. It is of type enum, console color. Somewhere there's a enumeration defined called console color in the class library that defines all possible color combinations allowed in the console. And the benefit to you, the developer, is that it forces you to correct value leading to higher quality code. You might spell a little string red, and might not catch that until runtime. However, using enumerations, the error will be caught at the time compilation. It's the definition of working with strongly typed language like C#. So when our builders point out essential deal properties in the class library, there are some enumeration type. Be aware of that and pay attention to the IntelliSense, which will guide you on what to do next. Okay. Having said that, let's show you how to create your own custom enumerations in C# so you can better understand how this works. Maybe someday you create your own custom enumerations for your own applications. Right? So let's do this. I'm going to do this outside class program. Enum superhero. And I'm merely going to inside the block type the names, the values as this type, this enum will be available. So let me turn out this code. And let me show you how to actually use this enum. So superhero, my value equals superhero. See how I got that from there? Now I can choose one of these possible values. So now what I do is read this example of very awesome we're talking about switch statements. And I want to show you this cool way to work with both the switch statement and enums that Visual Studio kind of makes possible. All right, so here we go. So I'm going to switch tab. And then I'm going to type in my value, enter, enter. And notice when I hit the second enter, that it automatically used all of the enumerations that I defined. So that's a little Visual Studio IE magic that I was referring to a little later, where it will automatically create all the cases for the enumerations that you find. That's awesome. Okay, so let's continue on with this example here. Actually, go ahead. Okay, so before we're ready to go with this, we have a little bit of a challenge. What we do is get the string that you just typed in into a format that matches our enums, since that is what we're comparing against. So superhero is not a string, it is a type of itself. So we're going to do a format conversion. And really the easiest way to do this is like so. So for format conversion, I'm going to do the following. If enum try parse type superhero, we'll pass in the user value collected from user. We're going to use this little version where we tell it to ignore the case true. And then if we're able to successfully parse user value into the type superheroes based on string comparison, then we will output the new value into my value variable. And I'm going to close this if statement around the switch. I'm going to automatically test the switch just a little bit. All right, let's clean that. Let's talk about this line code in line number 21. We're trying to convert a string that the user types in with the name of one of our enums. This is hardly a foolproof approach, but it does demonstrate this enum.tryparse method. We're trying to parse a string into one of the enums of the superhero enum type, and it's related, right? So that's why we have the data type in between the open and closing angle brackets. In C# when you see the angle brackets, it's called a generic method. As you'll learn, you make a generic method specific by specifying the data type. I'll talk more about generics in upcoming lessons. Just know that for now we're attempting to convert a string value that the user types in, the user value variable, into a superhero enum. So there's three parameters of the tryparse method. The first is the string that we actually want to evaluate. That's the user value variable. The second parameter is whether we should ignore capitalization in the user value string, which we said true, so we do want to ignore capitalization. The third parameter is an output parameter. An output parameter is like an input parameter, except it's sent from the method to the caller. All right, so how is this different from a return value method? So how is an output parameter any different from a return value? Well, look what happens here. Tryparse will return either true or false. So if tryparse is false, then tryparse fails. But if it succeeds, it will return true, and the parsed enum will be sent out via the output parameter. So we use an output parameter so that we can both communicate the successful value of an operation as well as the result of the successful operation. So now we know that tryparse succeeded. We can expect my value, the output parameter, to contain a valid enum that we then use in our switch table below. All right, so let's finish this up. We have to tell you something. Right line. And that else here. Console right line does not compute, right? Because we don't know how to match, so we'll hit the else statement and print out the string. And I'll try this to Superman, and see I'll try one time, some such, and it does not compute. All right, great. So what's the method here? We're able to use enumeration to rely on the Visual Studio IDE's code snippet, plus its lookup of the type we're trying to switch against, and explores out all possibilities. And now we have to do the implementation for each case in this case, for one line for the console right line. The other method is that any way from little strings, and rely on the fact that whatever user types in will match one of the enumerated values, so it doesn't have to catch it, we can catch it here, right? So we're not working again with unreliable match strings. All right, so in this lesson we talk about switching. We look at enumerations, especially those that we've seen in the class library. We then create our own enumerations to prove how it works, to show you how the IDE makes it easy to combine switch with enumeration that created using code snippets and automation within the Visual Studio IDE. And also how to use the enum.tryparse method. I intentionally skipped over the complex part, and you might be wondering about these angle brackets. Well, I don't really want to talk about the idea of generics just yet. Just know that you'll need the data type that you want to convert tryparse your string into inside those angle brackets. And we'll talk about generics in just a few lessons from now, and so we'll see you there. Thank you.